will be a star freelancer. Learn new skills. Set your goals. Increase your skills. Browse over 100 plus videos and ebooks. Jump to starfreelancer.eu.
Congratulations, you made it. Welcome to the Java Masterclass and thank you for investing in it. My name is Tim Buchaka and I'll be the instructor leading you through this course. I've been a programmer for 40 years now and have been using Java for 22 years. I think I'm well placed to teach Java. My mission is a simple one, and that's to teach you Java to the level where you can become a Java programmer. Whether you're new to programming or if you've got some experience in another programming language, or even if you know some Java and are looking to take those existing skills to the next level, in any of those scenarios, this course is most definitely for you. This has been the best-selling Java course on Udemy for many years. And I think one of the main reasons is that it's constantly updated. And in fact, as I record this video in September of 2022, I'm updating the course to JDK version 17. If I just lost you when I used the term JDK, that stands for Java Development Kit, and it's the software that is used to create Java programs. But we'll find out a lot more about that as we go through the course in detail, actually. But if you know something about the JDK, you might be wondering, well, Tim, why are you updating the course to JDK 17 when JDK 19 is out already? There is a very good reason for this, and in this section there is a video titled Which JDK, which explains my reasoning for using JDK version 17. But if you are running older versions of Java, say Java 11 or even Java 8, you will be able to follow along and get a lot out of this course. It's best to use Java 17 though. Please don't skip the next few videos in this section because there's a few videos there talking about things like video quality and so on and so forth, as well as that version 17 of Java video. So that's it. Welcome again. Let's move on now to the next video. I'm currently in the process of remastering this entire course. When the course came out in 2015, it focused on the then current version of Java, version 8. We've come a long way and now we are working on Java 17. Some of the improvements include incorporating features of Java 17, adding slides that can be downloaded, fixing errors in older videos, addressing confusing concepts in more detail, in general making the course better. As I complete each section, I'll add it to the course and send out an announcement. For now, don't wait for that, just get stuck into the course right now. A good portion of the course is already updated to Java 17. See you in the next video. All videos in this course have been uploaded in 1080p, which is the highest quality format that Udemy currently accepts for videos. That's the good news. The bad news is that sometimes Udemy's video play seems to blur the videos a little bit. Usually the blurriness disappears after 5 to 20 seconds of video playing. But if you have ongoing issues, come down here and click on this little cog and resolution. 720p is the best one to choose normally if you haven't got the auto option. But if you have got the auto option, select that because that will give you 1080p if Udemy's video player dictates that your internet speed is fast enough. In general, just give the Udemy video player time to load up for better quality videos and all should be fine. Thank you for watching. Let's move on now to the next video. Learning to program can be difficult sometimes, and if you need help, here is how to find it. Firstly, when you log in, you've got these options for support. Choose Q&A. When you do that, you can click on Ask a Question and enter a title about the question and a detailed description, and then post the question. It's literally that easy. Our Abisola, my teaching assistant, or even another student, a member of the community, will pop in there and actually help you out. Here's an example post, just to give you an idea. Note the title and the description there. But also, the other thing I want to show you is if you've got some source code that's not working, don't upload a screenshot. Instead, upload the code itself. Click here and you can paste the code directly in. Notice that it gets nicely color-coded and formatted when you do that. Doing that makes it much easier for other people to take that code and use it. Because if you post an image, it's impossible for someone to grab your code and paste it into their IDE, into IntelliJ, get a result, and try and figure out what's going on. They would have to manually type all the code in to help. But posting source code makes it a lot easier for others to help, formats and color codes that source code, and dramatically increases the chance of getting an answer. With that said, you can upload images. Sometimes images are preferable. If you have an issue where you want to show something that is not source code, then use an image. Take advantage of the search facility because tens of thousands of questions have been asked and answered. Chances are high that your query has been answered previously. The search is straightforward, as you can see there. Just type the question here and it brings up an answer. Notice that you can search all questions and all lectures instead of a specific lecture. So you might want to hone your results in a particular lecture. That can be a good idea if you've got a problem with a specific lecture to try and search just within that lecture. But you can also search across all lectures and many questions. I think at last count, as you can see, over 100,000 questions have been asked and answered. Here are some tips on actually asking questions. This will also help you in your future career as a programmer. Firstly, be as specific as you possibly can. If you're getting stuck on a particular lecture, just posting a question saying, "I can't get this code to work" is not very helpful. While it is technically correct, it gives little information for others to be able to use to help you. It is much better to supply information such as the lecture you are working on, paste in the source code you are using, maybe a supplementary screenshot if you think it needs it, the error message you are getting, and so on. You will need this skill when you become a programmer in the real world. If you're starting out at a new job and you go to your team leader, your senior programmer who's working with you, or even a peer programmer, you need to give them as much information as possible. People aren't going to be happy if you just say, "This is not working. Can you help me?" Because we're all busy in today's society. The other thing to keep in mind is that it's usually better to ask a new question rather than appending your question to another question that's been previously answered unless your question is completely related to that one. The reason for that is some of this depends on the notification system of Udemy. Older questions that have a new question added to it often don't seem to get shown to people trying to help. But new questions you leave do. So try not to piggyback on other students' questions with your question. So it's usually better to post a new question and get an answer to it that way. But again, always make sure you use the search facility first because that's going to help you a lot and give you the skills to make you a great, productive programmer. Alright, so that's support. I'll finish the video here. Let's move on now to the next video. Let's talk about source code. Before we get into source code, I want to say that it's essential for you to be typing in the code as you see me typing it in this course, because you can watch videos and learn a certain amount about programming. But to really master programming and really understand it, typing in the code, running the programs, finding errors, and fixing them, that's your success, your path to becoming a programmer. So it's highly recommended that you do that. So what you can do, what a lot of our students do is watch a video once to get the general feel for what's in it, then they'll go back and watch it again. Then they'll be typing along the second time they're watching it. So as they see me type something on the screen, they'll actually type the same thing into their computer, IntelliJ IDE, or whichever one you're using, whichever editor you're using. And that's the process where you'll get the most out of the course. So either do that, watch the video first and then follow along the second time by typing in the code. Or if you're feeling confident enough just as you're watching the video for the first time, be typing along. And be prepared to pause the video if needed, rewind, and do whatever. Really make sure you understand a concept thoroughly before moving on to the following video. All the code I'm typing is available for you to download. Each lecture has got this resources section you can see here. So you can click over to that in Udemy and you can download the source code. So you can grab that, unzip it, and then you can open that code up after you've unzipped it directly in your editor and you'll be able to actually follow along and compare your code to my code. It could be a good idea to do that, or if you want to just put my code into your project and sort of paste it in and use it that way. So it's available there, lecture by lecture, but down at the bottom of the course, you can see that I've got a lecture here which has all the source code. You can scroll down and click on the relevant file, which will be downloaded to your computer and then unzip it. So again, I just want to clarify that it's essential for you to get the most out of this course to be typing the code as you see it, which will help you become a productive Java programmer. Alright, let's move on now to the next video and start some programming. One of the biggest tips I can give you is persistence. To be persistent. You're finding your way to becoming a programmer. It is a journey that can be frustrating at times. You may even want to give up at times, but the people who succeed as a programmer work through that and come out the other side as programmers. That's just the nature of learning to program. Rewarding most definitely, but frustrating at times. You get frustrated because things aren't coming to you naturally. Still, over time, you get better and better at programming and things will make a lot more sense. I've actually got a link in the following lecture. It's a text lecture, and you can click on that and go to YouTube and watch a video on persistence. Really important there, but there's another vital video in that same lecture on the 4 stages of becoming a programmer. I think both are mandatory before you go much further to get you in the right mindset. The videos are short and to the point, so I suggest you take the time to watch them. I've got no doubt that you can succeed as a programmer, but going in with that mindset is one way to ensure it's going to happen. Alright, so that's now the housekeeping done. Let's talk about installing the software we need for this course. So we're going to be using JDK version 17 in this course. Now JDK stands for the Java Development Kit, and it's the software that is used to create and run Java programs. Now we're also going to be using IntelliJ IDEA, and that's much like a word processor, but for creating programs. Now I'm one of the early adopters of IntelliJ. I started using it way back in the early 2000s, and it's a very powerful piece of software packed with lots of features for both beginners and pro developers. The great thing about it is it's extremely beginner friendly, as well, and there's a free community edition or paid ultimate edition. So either edition will work just fine. You don't need to spend any money for either of those tools actually. And in the upcoming videos in this section of the course, I'm going to show you how to get the Java Development Kit and IntelliJ IDEA working for Windows, Mac, and also for Linux. Now, if you want to use another integrated development environment, IDE, such as Eclipse, NetBeans, Atom, or something of that nature, you're welcome to do that. It will work fine. Other than that, let's get started. Before I get into which version of Java you should use, please note that I will use the terms Java and JDK interchangeably. Technically, Java is the language and the JDK helps you write Java programs. You run your Java programs with a Java Virtual Machine, JVM, with Java Runtime Edition, JRE. But more on that later. Which version of Java JDK should you use? I recommend you use JDK 17, which is not the latest version. Sounds weird, right? I'm not suggesting that you use the newest version. There is a very good reason why. Oracle has moved to an LTS model for Java. LTS stands for long-term support. They release an LTS version of Java that is intended to last for years and is fully supported and updated throughout those years. The previous LTS version was Java 11. After its release, Java 12 through 16 were released during its lifetime and are no longer supported. It's the same with Java 17. It is the current LTS version of Java and should be the version you use for the foreseeable future. Oracle, the owners of Java, have publicly stated they will support it till at least 2029. Companies will standardize on Java 17, so this is a good version for you to master, as you will likely be using it professionally in the future. My recommendation is to download and use Java 17 for now. If anything changes in the future, I'll let you know and let all other students know by recording a new video or posting an announcement. Alright, so Java 17, JDK 17 is what we want. Thanks for sticking with me in these initial videos. You can finally get started doing something other than watching me in the following video. We need to install some programs to write Java programs, starting with the JDK and then IntelliJ IDE. There are separate Java install videos for Windows, Mac, and Linux, and different IntelliJ IDE videos for each operating system. I've done it this way as the installation process differs depending on the operating system. Watch the relevant video for your operating system and finish by watching the configuration of IntelliJ video, which is a single video covering all 3 operating systems because the configuration is the same for all operating systems. Confused? Don't be. It will all make sense shortly. The bottom line, skip any upcoming videos that don't apply to the operating system you are running on your computer and watch the ones that apply. Let's start with the Windows installation in the following video. This is the Windows installation video. Skip this if you're on a Mac or running Linux. Right, so we've established that you want to install Java 17, or to be specific, JDK version 17. This video will show you how to install on Windows 11. Note that if you are running on Windows 10, the installation will be pretty much identical. Just follow the steps you see in this video if you are running Windows 10. The only potential gotcha is if you are running a 32-bit version of Windows 10. These days most computers are running the 64-bit edition. In these rare cases, you will find you need to download an older version of the JDK. If you have a relatively new PC from the past 4 to 5 years, or even a bit longer, then all should work. Windows 11 only comes in a 64-bit version. So if you are running Windows 10 or Windows 11, just follow along and assume your computer is running a 64-bit edition of Windows and it all should work fine. Let's open a browser and go to java.sun.com. Click Java SE, which stands for Java Standard Edition, by the way, which we will be using in this course. You can see that right now it's showing Java SE 17 LTS. Specifically, it's showing Java SE 17.0.4.1 LTS. The numbers after the 17 refers to the update version, and chances are high when you are watching this you will see different numbers because a new version will probably have been released. Just choose the latest Java 17 version. Be sure not to select the newer version, which for me is showing Java SE 19. We want Java 17. If you don't know why, watch the previous video where I explain why we need version 17. Right, so I'll click Java 17 and that takes me to another page. From here I will click Windows and then I get a list of options I can click to download. The easiest one to use is the x86 installer, so I'll click that here and let it download. Now that it's downloaded, I will run the downloaded file, which will start the installation process. I'll double click it. I'll click Yes here to allow the program to install. As you can see, it is just like installing any other program. I will draw your attention to the location it's being installed in because you may need to know that in an upcoming video. Alright, I'm going to let this installation complete. And we're done. Great. So we now have the JDK installed. In the next video, it's time to download and install IntelliJ, which is the program we will be using in the course that works with the JDK we just installed to let you write and execute Java programs. See you in the next video. This is the Mac installation video. Skip this if you are on Windows or running Linux. Right. So we've established that you want to install Java 17, or to be specific, JDK version 17. This video will show you how to install it on a Mac. Let's open a browser and go to java.sun.com. Click Java SE, which stands for Java Standard Edition, by the way, which we will be using in this course. You can see that right now it's showing Java SE 17 LTS. Specifically, it's showing Java SE 17.0.4.1 LTS. The numbers after the 17 refers to the update version, and chances are high when you are watching this you will see different numbers because a new version will probably have been released. Just choose the latest Java 17 version. Be sure not to select the newer version, which for me is showing Java SE 19. We want Java 17. If you don't know why, watch the previous video where I explain why we need version 17. Right, so I'll click Java 17 and that takes me to another page. From here I will click macOS and then I get a list of options I can click to download. You may be aware that recent Macs run Apple Silicon. Because of this there are two options, the ARM 64 version and the x64 one. If you have an Intel Mac, choose the x64 DMG installer. If you have a Mac running Apple Silicon, a model with M1 or M2 in the name, then choose the ARM 64 DMG installer. I'm running on a MacBook Pro with an Apple M1 Max configuration, so I'll choose the ARM 64 DMG installer. You choose the appropriate version for your Mac. If you are prompted with allowing downloads, as I am here, click the Allow button. The download will start. I'll wait for it to finish before continuing. When it's done, I'll open the downloaded DMG file like so. Here I will double click the .pkg file to start the installation. I'll click Continue here, then Install. I'll enter my password and press Enter. The installation continues. Once this screen is reached, you are done. I'll close down all the windows and then click this Close button. I'll click Move to Bin to delete the installer program since we are done with it. And the JDK has been installed. Let's move on to the next video where we will install IntelliJ on the Mac. In this video, we're going to install the OpenJDK version 17 on Ubuntu 22.04. If you're on Windows or Mac OS, then check out the relevant videos for your operating system. So we want to start by opening up applications by clicking here and selecting Terminal. Note that my screen may look slightly different to yours. Just click Activity in the top left of the screen, click in the search box and type Terminal and press Enter. This opens up a new terminal window. Firstly, we want to check if Java is already installed on your computer. Type Java --version. If you get a message similar to this, it means Java is not installed. You may get a message with an older version of Java you have previously installed. In both cases, continue on and type the following: sudo apt update, enter. You may or may not be prompted to enter a password here. If you are prompted, enter your password to continue. Give that a moment to complete. Next, we want to download and install the JDK. Type the following in the terminal window: sudo apt install -y openjdk -17 -jdk. This will take a while to download and install. I'll fast forward and come back once it's done. Okay, that's completed. Type Java -version. And as you can see, it's showing Java 17.0, which is correct. Type Exit to exit the terminal. The JDK installation is complete. Next, we want to go to the next video and install IntelliJ. See you in the next video. Now that we have Java installed on our machines, I want to introduce you to the software tool we'll be using to begin to explore the Java programming language, JShell. Firstly, let's open a command prompt on Windows or a terminal in Mac or Linux to check our Java version to make sure we are ready. On Windows, you can press and hold the Windows key located next to the space bar and then press the R key. This will take you to the Run window where you can type in CMD and hit the Enter key. On a Mac, you can press the Command key and spacebar at the same time to get to Spotlight and then type in Terminal. This should take you to the built-in terminal on your Mac. For Ubuntu Linux, click on Show Applications in the bottom left of your screen. Then in the search bar, you can type in Terminal and hit Enter. Now that we're in our terminal, we'll first check what version of JDK we're using. To do that, we'll enter Java -version. Now, depending on when you installed your version of Java 17, your output may be slightly different than what you see on screen here. The important part for this course is that you see Java version 17. As you can see, I have version 17 installed. Your exact version may be different, but as long as the version number starts with 17, you should be fine for this course. If you do not see version 17.something, please revisit the installation video for your operating system to get that installed. There are different ways we can interact with Java, create programs, and execute or run them. You could use a simple text editor to write Java code. We could, for example, use a simple text editor such as Notepad on Windows or the TextEdit app on Mac to write our code. We could even use a terminal-based editor such as Fire if the operating system we are running supports it. As we can see in the slide, this isn't the easiest code to look at and read. But if we had to, we could certainly code this way. Doing it this way would also require us to learn to compile and execute Java code manually. Most likely, you'll be using an integrated development environment or IDE to develop your Java code. An integrated development environment or IDE is the most commonly used method of writing Java code. An IDE is a powerful tool with many features that help simplify writing code by making it easy to read. It can keep us organized and provide hints about possible errors and best practices. The IDE can also help with code completion by essentially finishing our sentences for us. And as you can see in this slide, the exact same code we just saw in Notepad looks a lot better and is much easier to read. Later in the course, we will introduce you to IntelliJS IDE, which makes things very easy. But let's start with the basics. We can execute Java programs directly from the command prompt or terminal. From the command prompt or terminal window, we can simply run the Java executable by typing Java followed by the Enter key. As you can see on the screen, we get a bunch of output. A lot of this may not make sense to you, and if it doesn't, don't worry. My goal here is simply to show you that you can directly interact with Java from a command prompt or terminal. What you are seeing here on the screen is a list of options that we can use when running a Java program from the command prompt. Because we did not include any of these options, Java has responded by providing what is essentially its built-in help. So next, let's take a look at the first tool we will use to begin our Java journey. As previously mentioned, that tool is JShell. JShell became a standard component of the Java Developers Kit in Java 9. It is what is known as a read-eval print loop interactive program, or REPL for short, which means it does pretty much just that. It reads the command or code segment we type in. It evaluates and executes the code and often allows shortcuts to be used. It prints out the results of the evaluation or execution without making the developer write code to output the results. Lastly, it loops right back for more input, more code segments or commands. JShell runs in a terminal or on the command line for Windows and is useful for quickly trying out new ideas. JShell is a kind of sandbox or playground that lets us experiment with code in a simple, safe, and fun way. It does this with instant feedback, which, for brand new developers, is very rewarding. Note that although JShell, because it is a REPL environment, is interactive, and that is not the same thing as an integrated development environment. JShell does not replace the need for an IDE. It's just a handy tool to quickly get started with Java. We will be transitioning to an IDE later in the course. We'll use JShell for the first part of this course, both to introduce it to you and to explore some basic concepts in Java. For the rest of this video, we'll look at some of JShell's built-in features and try to get comfortable with some simple commands. First, let's take a look at some online documentation for JShell and navigate to Oracle's JShell documentation. This link, and all links I type in the course, is available in the resources section of this video on Udemy. As you can see on the screen, the documentation starts with a simple introduction and is divided into various sections such as snippets, commands, and so on. We are not going to explore this documentation in detail, but I want you to be aware it is here and that it can be very useful if you get stuck with a problem or simply want to learn more on your own. And in general, I encourage you to be curious and take advantage of the many online resources available to you. And as you'd expect, we'll be looking at many such Java Online resources together first as we progress through the course. For now, let's switch over to JShell and learn a bit about it. I'll scroll the screen down again. Let's clear the screen by typing CLS and pressing Enter. On a Mac or Linux, the command is clear. I'll launch JShell now. JShell. As you can see on the screen, this has launched JShell for us and also confirms we are running version 17 of Java. Now we will follow some on-screen advice and check out the introduction. /help space intro and then enter. You can see we get a little bit of output from this with a simple introduction to JShell and a couple more hints. Let's take a look at the JShell help. /help. As you can see, there are several commands available with a brief description of each. We won't be going through all of these commands, just a few of the more common ones. As you can see, there are options to save and open files, reset JShell to its initial launch state, and even review the history of what you have typed, and so on. Let's take a look at the top command there, the list command. As you can see highlighted there, the command /list is followed by some options contained within left and right square brackets. Those brackets indicate options for the command. We can also see that the /list command is used to list the source you have typed. Since we have not yet typed any source, meaning code, let's use the -all option. /list space -all. What we see in the output is a list of the built-in code or libraries of code that JShell includes in its environment. One of the great things about Java is it has been around a long time and there is a lot of code already written that we can take advantage of. We don't have to reinvent the wheel because we'll be able to find and use existing code to do things like connect to the internet, solve maths problems, or get input from a user. Please note too that if we had typed in some code already, it also would be listed here. So the list command shows us the history of Java code run in JShell. Although we didn't execute the import statements you see here, JShell executed them when it started up. In addition to seeing the history of the Java code executed, we can use the up and down arrow keys to scroll through whatever we ourselves typed in JShell. If you use the up arrow now, you'll see that it brings up the list all command again. If we press the up arrow once again, we'll now see the help command we typed in at first. The up and down arrow keys will be very useful to us as we execute one line of code, then want to change something about it and execute it again. For example, if we scroll down and we edit the statement, we see the list all command, and instead of listing all the code, we change that to list only the code that ran at startup by typing -start, then hit enter. The output is the same since we haven't entered any Java code just yet, but this is an example of using the up and down arrow keys to get previous code. Once we have the previous code on our current prompt, we can edit that code, then execute it without new changes by hitting enter again. One other useful thing in JShell is when you want to write a couple lines of code in Java, but you don't want them to be all on the same line. You can do this with the use of curly braces. Let me show you what I mean. Opening curly brace. As you can see, the JShell prompt has changed. It is now 3 dots followed by a greater than symbol. The new prompt we are seeing in the JShell terminal is telling us that JShell is ready for another line of code to be typed in. And you can keep adding new lines of code, pressing enter in between without anything actually running until you complete the set of curly braces. Don't worry if you don't quite get that just yet. We'll be showing you lots of examples of ways to enter code in JShell. But if you accidentally get yourself into this situation with this different looking prompt, know that you can either enter a right curly brace to get out of it or type Ctrl-C to escape out to return to the normal JShell prompt. And finally, there is the command to exit JShell. /exit. And we are now back at the regular command prompt. Why did we introduce you to JShell and not write any Java code? I have a good reason for doing this. Our first Java code is going to be the very traditional program for a beginner, and we'll do that in the next video. I wanted to get all the JShell commands and usage out of the way, so in the next video, we can concentrate on just Java code. Remember, later in the course, we will swing over to an IDE instead of JShell. In this video, we confirmed what Java version we were using and introduced you to some of the most important commands in JShell. We now know how to see the history of the commands we typed in, how to use the up and down arrows to scroll through history, and most importantly, how to exit, both from the multiple line prompt and from JShell itself. Right, let's write some Java code. I'll see you in the next video. In this video, we're going to print some things to the screen to get our first real taste of programming. The Java Shell tool, or JShell as it's referred to, is the tool we'll be using to achieve this, and is the one I talked about in the previous video. Be sure to watch that previous video if you need a recap on how to access it for your operating system. For best results for this course, make sure you follow along as closely as you can, typing the code segments I'll be typing into your own JShell session or editor window and performing the operations that I'll be demonstrating. JShell is a sort of playground to test code segments. Integrated development environments are great tools which guide both new and experienced programmers, simplifying the debugging and improving programming standards. But nothing beats learning from your own mistakes and figuring out how to get a line of code to work when it wasn't working before. This emulates real-world problem solving, and you'll find when you type in your own code, you'll be making all kinds of typos or omitting or overlooking some characters that are required. This is the best way to learn and pick up all the nuances of any programming language you're learning. If you do encounter a mistake on your own, pause the video, try solving it on your own, and if that doesn't work, remember the working code segments are always available in the resources section of every video. In addition, I'll be trying to talk through and demonstrate some of the most common mistakes we all make in Java. If you're making these mistakes and correcting them on your own, you won't forget them easily. If you're like most programmers, figuring out how the pieces fit and seeing the result of the code working after a bit of a struggle is the best part of programming. Coding is a lot of fun, and I promise you'll feel the same way as we progress through this course. Alright, so let's get started. It's always been a tradition when you're learning a new programming language to create a simple program that outputs the text, "Hello World." This lets us test all the paths that are necessary to create a successful program with very little investment of time or knowledge of the language. It's the first step, and honestly, even after many years of programming, I still get that first feeling of achievement when I've accomplished this step in a new language. If you can print "Hello World" to the screen, you're on your way to bigger and better things. Let's do that now. First, I'm going to open a command line window for my operating system, and from here, I'll invoke the Java Shell tool. JShell. I'll press enter. JShell is running now, and from here, from the JShell prompt, we can type in our first code segment. Remember to type in the following code exactly as you see me type it. System.out.print, opening parentheses, double quotes, "Hello World," closing parentheses, semicolon. This line of code is called a statement in Java. Let's pause for a moment and talk about statements. So what is a statement? It's a complete command to be executed. It can include one or more expressions, and I'll be talking about expressions and related topics as we progress through the course. What we've typed above is a command to print some information to the screen using syntax provided by the Java language. We specified what we wanted Java to print in the parentheses and double quotes. In this case, the text "Hello World." Effectively, we're telling Java to print out the words as we've specified them in the quotes, "Hello World." After we press the Enter key, the program executing the code should print that text to the screen. In this case, the output is printed on the very next line. And there you have it. We've executed our first line of Java code successfully, printing out "Hello World" to the screen. I hope you can feel that moment of satisfaction I always feel at this moment, knowing that your system is ready and able to execute whatever new commands you can now learn, and you're at the beginning of a fun and interesting journey, getting a computing device to do what you want it to do. Don't forget that Java is a write-once run anywhere, and that this little program you've created can be executed on any device where Java runs. Now I've got a bit of a challenge for you here, and the challenge is to see whether you can modify the statement we typed below so that instead of it printing out "Hello World," it prints "Hello Tim." Looking at this code, how do you think you go about achieving that? Let's see if you can figure that out and get that to run. You have a few options here. You could just retype the entire line in from scratch with the changed text to print out. But we want to modify the statement, not type a new line in. To modify the existing line, press the up arrow key. Remember that in JShell, you can see the history of the lines you've previously typed using the up and down arrows. Pressing the up arrow now will display the code we first typed in, so make the change and then press enter to see the result printed to the screen. Click pause on the video now and try that out, and I'll see you when you get back. Welcome back. Hopefully you managed to make that first change. Let's go ahead and modify the code to change the output. All we need to do is to press the up arrow key to display the previously typed in code. Then I'm going to delete the word "world." And to make sure that it's grammatically correct, I'm going to use a comma, then a space, and then Tim. With the statement modified, we can press enter. There's the output, "Hello Tim." This is another point of confirmation for a lot of programmers when you make your first change to a line of code and you get to personalize "Hello World" to whatever you want. Congratulations if you managed to make that work. These are the first steps almost all programmers make in almost every programming language, regardless of their experience. If you had a problem getting it to work, don't worry. The more you work at this course, the easier things will be to understand, so hang in there. Every video builds on some content in previous videos, and you'll have lots of opportunities to explore these concepts further, so you won't be left behind. Next, let's look at some common errors you might get when typing in Java code. We'll start with what happens if you forget to add the closing parentheses. I'll press the up arrow key to scroll through the JShell history, and I'll find the previous line we typed in. Next, I'll remove the closing parentheses to see what JShell does. Okay, so what does this somewhat weird looking new prompt mean? Well, JShell is assuming we haven't finished typing in all of the code since we haven't closed the parentheses set, so it waits for us to type something in. I can now go ahead and add the closing parentheses here in this line and the semicolon completing the statement, then press enter. And then we have it. It now prints out "Hello Tim" as before. Another common mistake is when you forget the closing double quote. So let me press the up arrow again, then remove the closing double quote after Tim. Here, you can see that JShell was a little less friendly and didn't give us a chance to end the text properly as it did with the closing parentheses, but gave us an error and closed string literal. If you're new to programming, that error probably doesn't mean anything, but text specified in double quotes is called a string literal, and we'll learn about literals in an upcoming video, but what JShell is trying to tell us is that we started out defining a string literal, which is what you do when you use a double quote, but we didn't finish the job correctly. We didn't add a trailing double quote, which is why we get this error. I'll again press the up arrow key and add the double quote back in, properly closing our string literal, the text, "Hello Tim." The error has been resolved now, and we get the output, "Hello Tim." I want to show you one more common error before we move on to the next video. If you're coming from other programming languages such as Python or JavaScript, replacing double quotes with single quotes is perfectly fine, but in Java, you'll end up getting an error. I'm going to replace the double quotes with single quotes to see what happens. You can see here that the error is similar to what we got when we forgot the trailing double quote, but now the error message is warning us about something called a character literal. Once again, character literals will be covered in a future video, but essentially what it's saying is that single quotes are used for characters, and we're trying to use it as a string literal, which is not allowed. I'll change that back now just so it's correct. These were a few examples of errors that might occur when you're coding in JShell. Let me encourage you to play with this line of code in JShell in as many ways as you can think of to see what kind of errors you might get or what kind of output is produced. This is the whole point of JShell, to provide you with a safe place to test code segments. Remember that the key combination Control-C should cancel what you are in the middle of and get you back to the JShell prompt. Typing / and the word exit or / with the shortcut text EX will end your JShell session if you get stuck. Alright, so well done. You've successfully executed your first program in Java and maybe even made some mistakes you've learned from. Let's now move on to the next video. In the previous video, we saw how to write our first code in Java. It was pretty basic to say the least, printing out some text on the screen, but it was a good place to start. In this video, I want to talk about variables and keywords. A keyword is any one of a number of reserved words that have a predefined meaning in the Java language. In Java syntax, all code is case sensitive, and this includes keywords. As we'll see soon, an int, all in lowercase, is not the same as int with a capital I. Here, an int, all in lowercase, is a keyword in Java. Let's take a quick look at all the Java keywords. On the screen we can see a complete list of the Java keywords, and if you look closely, a brief explanation for some of their current statuses. I have highlighted several, including int, which we just mentioned, and actually is short for integer. All of these highlighted keywords are what is known as primitive data types. We'll be looking much more closely at these data types and all the other keywords in upcoming lectures. For now, I really just wanted you to have a chance to see all the keywords and get a preview of some of the ones that we will be reviewing in the next few lectures. So that's a bit more about keywords, which we'll continue to learn more about throughout the course. But if we want to start getting the computer to do something useful, we need to start using variables. So what are variables? Well, variables are a way to store information in our computer. Variables that we define in a program can be accessed by a name we give them, and the computer does the hard work of figuring out where they get stored in the computer's random access memory, or RAM. Now, a variable, as the name suggests, can be changed. In other words, its contents are variable. So what we have to do is tell the computer what type of information we want to store in the variable, and then give the variable a name. There are lots of different types of data, that we can define for our variables, some of which we've shown you in the keyword list previously. Collectively, these are known as data types. As you may have guessed, some data types, which are called primitive data types, are keywords in Java. When we get to the object-oriented features of Java, we'll learn that we have a lot of flexibility for creating our own data types, but in the next couple of videos, we'll explore primitive or a special kind of built-in data type. So let's start out by defining a variable of type int being an abbreviation for integer, which is a whole number. That's a number without any decimal points. To define a variable, we need to specify the data type, then give our variable a name, and optionally add an expression to initialize the variable with a value. And we'll be talking about expressions shortly. For now though, let's swing back to JShell to see how to define our first variable. Int my first number equals 5, semicolon. Note that I've capitalized the word first and the word number. Later in the course, I'll explain why I'm doing that. I also put a semicolon on the end of that line to complete the statement. So here, we've defined our first variable by specifying a data type of int and giving the variable the name of my first number. We've set the value to the number 5 using an equals sign. This is called an assignment operator. Remember that the data type int represents an integer value, which is a whole number. And finally, we added that semicolon to end the line to form a statement. The semicolon ends the line and tells Java just that the line is complete. So this entire line, as we've talked about, is a statement. We briefly discussed statements in the previous slide, describing a statement as a complete command to be executed. Here, this statement is a specific type of statement, a declaration statement. A declaration statement is used to define a variable by indicating the data type and the name, then optionally to set the variable to a value. So here, the type of the variable, note that type is a shortcut for the word data type, is an int. The name of this variable is my first number, and the value we're assigning or initializing our new variable to is 5. We can see this value assignment on the line of output from JShell. So rephrasing this for clarity, we're declaring a variable of type int with the name my first number and assigning it the value of 5. Assigning a value in this statement, or initialization, is optional here. In other words, we could have omitted the equals 5. With Java, in general, variables have to be initialized before being used, but we'll talk more about that in an upcoming video. If you're initializing a variable in the declaration statement, what you type to the right of the equals sign is assigned as the value of the variable. This is known, the part of the statement that follows the equals sign, as an expression in Java. And we will be using expressions a lot as we go through the course. So what is an expression? An expression is a coding construct that evaluates to a single value. And we won't go into a deep discussion of that now because we've got upcoming videos where we'll talk about that in a lot more detail. Now we can see in the output that Java has read this statement we've created and executed it. What's happened behind the scenes is that Java has allocated a place in memory to store a single whole number and set up a mechanism to allow us to access that memory location by the name we gave it, in this case, my first number. That's how we'll access it. So in other words, you don't need to know anything about where in memory this is taking place or where Java is storing the contents. To access the number, you don't refer to a memory location, you refer to a variable name, my first number in this case. So we're leaving Java to do all the dirty work. Alright, so now that we've declared the variable, let's see if we can print out the value. So looking at the declaration statement, I think we've got a good idea of what the output value should be. Let's take a look at a challenge now. So the challenge is to look at creating a new system.out.print below the declaration for my first number and see if you can figure out how to print out the value of the my first number variable. So pause the video here and have a think about it, then try to print out the value that we've assigned to our variable. Resume the video when you're ready to see how I do it. Alright, let's walk through it together and discuss how to print the number 5 out using our variable. So you may have thought when you first started that the following code would give you the result we wanted. System.out.print, opening parentheses, double quotes, my first number, closing parentheses, semicolon. This is similar to what we did in the Hello World video. As you can see, we in fact get the output my first number as text, and not the contents of our variable that we declared, which of course should be 5. The reason we've got my first number printing out and not the contents of our variable is because we put the text my first number in double quotes. And when we put something in double quotes, it's called a string literal. We talked very briefly about this in the Hello World video. Remember that a string literal has to be included in a set of double quotes. Now, a literal, unlike a variable, cannot be changed. A literal is the simplest form of an expression and not a variable. So here, what we're saying is, literally, no pun intended, print out the text, my first number. And unsurprisingly, perhaps, since those were the instructions we inadvertently gave, we can see my first number being printed. So in essence, that's why we're getting that value. If we remove the double quotes, which I'll do right now, I'll edit that line to remove the double quotes before and after my first number. So we need to remove both double quote characters to remove any errors. Recall from the Hello World video that double quotes should be used as a set to describe a string literal with a beginning double quote character and an ending double quote character enclosing the text. We'll execute this again without double quotes. This time we should see the right value. And we can see the value 5 shown on the screen. I made sure that I typed the name identically to the declaration line, matching each character case by case, that is using a lowercase m in my, uppercase F in first, and uppercase N in number, with no spaces between, and you can see we got the value 5 printed as the output. So now, let's explore what it really means for a variable's content to be variable. In the line of code we called the declaration statement, we've assigned our integer variable, named my first number, a value of 5. Another way to state this is that we've initialized our variable to 5. This is its beginning value. You can only initialize a variable once, either in the declaration statement, or if not there, meaning you optionally chose not to set the variable at that time, then in a statement made later in the code, but a value must be assigned to the variable before you can use it in a print statement or in an arithmetic operation, for example. We'll walk through this shortly. For now, let's reassign the value in our variable, changing its value from 5 to 10. This is a very similar statement to the declaration statement, except we don't specify the data type in the subsequent statement. We'll double check to make sure to finish the line of code with a semicolon and execute that line of code by hitting enter. My first number equals 10, semicolon. Next, we'll call the same line of code we called previously, printing out the value in the variable named my first number. Here, the value is printed out as 10. To reiterate, the only thing we changed was the value in our variable. The variable name and the data type remained the same, meaning the storage area in memory is still allocated to hold the integer value we specified it would hold, and my first number is still the mechanism we'll use to set and get that value in memory. In this case, we set the value in that memory, changing it from 5 to 10. Let's, just for fun, change the value again. Here's your challenge. Change the value of our existing variable from 10 to 1000 and print the new value out using the system.out.print method as we've done previously. Pause the video here and try that out using JShell. When you've completed the task or need a little help, start the video again. Welcome back. I hope you got that to work, but let's walk through the exercise together because there are some things I'd like to clarify as we go through it. My first number equals 1000, semicolon. Next, we'll call the same line of code we called previously, printing out the value in the variable named my first number. You could have also just typed the previous statement in rather than using the up arrow key. In either case, the value printed should be 1000. Now, let's use a JShell command which will list all the statements we've executed and assigned values to in JShell. /list. This JShell command lists all the Java statements you've executed in JShell. If you have followed along, your output should look as follows. We've executed 7 statements. The first statement is the declaration statement, which created and initialized our int variable named my first number. In the fourth statement, we assigned a different value, 10, to the variable my first number, and on the sixth statement we executed, we changed our existing variable, my first number, to the value of 1000. But maybe you tried saving yourself a bit of typing and you scrolled up to the first line in history, the original declaration statement, which started with int and changed that value 5 to 1000. And again, to print it out. And your result was the same, the value of 1000 gets printed. There's one important difference, however, that I want to point out. The statement you scrolled up to and changed, which included the data type, was actually a redeclaration of the variable myFirstNumber. JShell lets you do it, but a Java compiler in any integrated develop environment wouldn't allow it. It may not quite make sense yet, but it's important to note that once you declare a variable, you cannot redeclare it in a normal Java code block, even if you're redeclaring it with the exact same data type. Let's just review that statement I just made. By declaring a variable again, we are effectively redeclaring a variable, and in normal Java programming, that would not be allowed and would throw an error. Due to its interactive nature, JShell holds our hand and allows the redeclaration to occur without throwing an error. For now, just follow along, knowing that redeclaring a variable for a second or subsequent time is not allowed, and later in the course, when we switch to a full editor, you'll see what happens when we try and do that. Note that we can assign a value to a variable multiple times in Java, but it's the declaration, which includes the data type, that cannot normally be done a second time for the same variable. In our statements up to this point, the expression, defined on the right side of the equals sign, has been a simple literal value, either a string or a numeric literal. But the expression to the right of the equals sign can be a lot more complex. In the examples we just reviewed, we used a literal integer value of the number 5, and then you saw us we changed it to the number 10, and then 1000, but now let's look at something a bit more interesting. Let's add an expression that is the sum of two numbers, as I'll do here. myFirstNumber equals 10 plus 5 semicolon. I can state what I'm doing here as setting the value in my existing integer variable name, myFirstNumber, to the sum of the numbers 10 and 5. You can see I've added an operator by using the plus sign before the number 5, so it's 10 plus 5. I'll explain operators shortly. So let's hit enter to execute that now. And we've now got the value 15 output on the screen. And if we were to re-execute the print statement, we get the same output, 15. I'm not going to do that now, but you're welcome to if you'd like. Java has looked at the expression to the right of the equals sign and figured out that it's a mathematical expression, and it's basically calculated that to be 10 plus 5, which equals 15. And sure enough, we got that value assigned to our myFirstNumber variable, as we can see in the JShell output. We can get a lot more complex. Let's do that just before we finish the video. myFirstNumber equals opening parentheses 10 plus 5 closing parentheses plus opening parentheses 2 times 10 closing parentheses semicolon. That should give us 35. 10 plus 5, that's 15, plus 2 times 10, the 2 times 10 is 20, that's 15 plus 20, giving us the final value of 35. Let's execute that by hitting enter. And sure enough, we get the value 35 showing. So you saw that I introduced an operator there. In fact, we've got a couple of operators there. We've got the plus operator and the multiplication operator showing. Java operators, or just operators, perform an operation, hence the term, on a variable or value. Addition, subtraction, division, and multiplication are four common ones that I feel sure you're familiar with, but there are lots more operators, and you'll be seeing those as we go through the course. By the way, if you want to get a downloadable list of all these slides, navigate to the last section of the course and look for a lecture called Bonus Lecture and Information. Alright, so let's end the video here, and in the next one, we'll figure out how to use other variables in expressions. See you in the next video. In this video, we'll be continuing what we were working on in the last video, but here we'll be using variables in expressions. Remember, the expression is the code segment that is on the right side of the equals sign in an assignment or declaration statement. This code can be a simple literal value like the number 5, or it can be a complex mathematical equation using multiple literal values and mathematical operators. In this video, we'll talk about how to use variables to replace literal values. Up until now, we've only used literal values in our expressions, and we've also used several operators, such as in the example we used in the last video, shown here on the slide. Here, the expression is the equation 10 plus 5 in the first set of parentheses added to another equation 2 times 10. If you've quit JShell and come back, please go ahead and pause the video and declare and initialize myFirstNumber as shown in this slide. We'll be using the myFirstNumber variable again in a few minutes. Next, we want to create 2 more variables, so I think this is a good time for a challenge to get you to do just that. The challenge is to create 2 additional variables in JShell. Here's what we need. One variable called mySecondNumber, which is an int with a value of 12. And another variable called myThirdNumber, also of type int, with a value of 6. So pause the video now, set up the declarations for our 2 new variables in JShell, and come back and resume when you're ready to move forward. So, alright, welcome back. How did that go? Hopefully you got that to work, but let's go over it now. Before we start, I'm just going to redeclare my first number as described in the slide. Int myFirstNumber equals opening parentheses 10 plus 5 closing parentheses plus opening parentheses 2 times 10 closing parentheses semicolon. We'll go ahead and add our 2 additional variables. First, we declare and initialize mySecondNumber, as I'll do here. Int mySecondNumber equals 12 semicolon. And next, we declare and initialize myThirdNumber as follows. Int myThirdNumber equals 6 semicolon. And we can see from the output that JShell created these 2 new variables for us. Before we proceed, let me tell you about a JShell command that will list any variables that we've created in our session, so try this if you've just followed along and successfully created those variables in your JShell session. Type in /var and press enter. You can see, after executing that command, JShell lists the 3 variables we've declared, their data types, and their values. This is a handy way to keep track of what variables are available for our use in future code snippets, which we might want to create in JShell. Hopefully, your own variables that you created during the challenge look like the output shown here. So now, we ask the question, is there a way that we can sum the values of these new variables, mySecondNumber and myThirdNumber, and assign the result to yet another new variable, which we have not set up yet? So yes, definitely there is a way to do this, and we're going to do that next. Instead of using a literal number, which is all we've really seen so far in the course, let's use variable names directly in the expression of a declaration statement. Int myTotal equals myFirstNumber plus mySecondNumber plus myThirdNumber semicolon. And in fact, if you have other variables or expressions that you wanted to add, you could keep going and make this an extremely complicated expression. Java will quite happily interpret that and be able to process it as long as the syntax is correct. So now the expression is myFirstNumber, which is 35, mySecondNumber is 12, and myThirdNumber is 6. Adding up those numbers in our head, that is 35 plus 12, which is 47, plus 6 makes it 53. Let's try executing this statement by hitting enter and see if we added that up correctly and get the same result. And there it is, 53 showing on the screen. And just to show you another example, let's change myThirdNumber, which currently is defined to have the value 6, and we'll change that to be myFirstNumber multiplied by 2. So let's do that now. MyThirdNumber equals myFirstNumber times 2 semicolon. Here, what we've done is we've assigned myThirdNumber to be equal to the value of myFirstNumber, which has the value 35, if you'll remember, times 2, which gives us 70. So the variable myThirdNumber has now got a value of 70, as we can see. Now, if we execute the same statement we did before for myTotal should equal 35 plus 12, which is 47, plus 70, which should be 117. We'll use the arrow keys in JShell to scroll up, which we used previously to find where we declared and set up the value for myTotal. I want to continue to try to encourage you to exercise best practices here, even in JShell, so I'm going to remove that data type from the statement before we execute it, because we don't want to redeclare the variable, we just want to give it a different value. If you do forget to remove it and just run the statement as it was originally, it will still work in JShell, and that's okay for now. I'm going to use the up arrow twice, remove the int data type, and then hit enter. And so now, there's the result, 117, as we expected. Alright, so let's end the video with another challenge for you to try, which I'll describe on this next slide. First, create a new variable and call it myLastOne. Its data type should be int. It should be set to the value of 1000 minus or less than the value in the myTotal variable, which we've just talked about in our previous code segment. Next, print out the value of the myLastOne variable on the line after you declare it. Hint, we need to use another operator that we haven't actually used in the code before, but if you think about this, it should be easy to figure out which operator you need to use. Okay, those are your instructions, so pause the video now, see if you can complete the challenge on your own, and when you're ready, come back and resume the video. Go ahead, I'll wait here, so pause the video now. Welcome back. Hopefully you managed to complete that challenge. As usual, we'll now go through one solution together and see if it matches yours. Let's see what we can do here. Int myLastOne equals 1000 minus myTotal semicolon. The variable myTotal last had the value 117 assigned to it, so this statement starts with the literal number 1000 and then takes away 117, which gives us 883 from the JShell output. It's good practice to use system.out.print to output the value, even though JShell automatically does that for you. Since the print statement was part of the challenge, let's print the value of myLastOne next. So we'll type system.out.print, opening parentheses, myLastOne, closing parentheses, semicolon. And again we get the value of 883 printed out as expected. I just want to end by saying, if you ever get stuck here and you're finding weird errors, one of the first things to look at is the spelling of a variable name, especially the case you use, meaning whether it's upper or lowercase. Let's just explore what that kind of error looks like for a minute in JShell. Instead of outputting the variable myLastOne with a lowercase m, we'll change the first letter to an uppercase M. When we try to print that out, you can see that we get an error, and it's pretty descriptive that the code cannot find symbol, and then on the next line it tells you what symbol it cannot find, myLastOne, which starts with a capital letter M. The compiler can't find any variable with that specific name, so it can't execute the code. This is a very common mistake. Java code is case sensitive. This includes not just keywords and language syntax, but variable names and data types as well. myLastOne is not the same variable as myLastOne. Int is not the same as int or int. You'll see later on that there is a need for some things to be in uppercase, but most of the time. Keywords will be in lowercase, and variables will always be exactly as you declare them, including capitalization. Remember that case matters in Java code. The /var command in JShell can help you identify any misspellings you may have made. Now later on in the course, we'll be looking at best practices for naming variables because there are specific rules we should follow, but we'll check with that later on in the course. And so, just to recap, in this video, we used expressions to assign values to our variables, and we used variables we created in expressions. For now though, in our expressions, we've looked at only one data type so far, which is the type int. In the next video, we'll be looking at and discussing some additional data types. Okay, so we'll see you in that next video.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
We've been working only with the int data type so far in the course. In this video, we'll continue to look at int as well as several other primitive types. We'll also introduce the wrapper class, a special category of data type which offers additional functionality that primitive types don't. In Java, primitive types are the most basic data types. The 8 primitive data types in Java are shown in the table below, listed by the type of data stored for each. You can see from this table there are 4 different types to store whole numbers: the byte, the short, the int, which we've briefly looked at, and the long. There are 2 types to store real numbers: the float and the double. And finally there is the char and the boolean, which are in categories of their own. Consider these types as the building blocks of data manipulation. Remember that primitive data types are simply placeholders in memory for a value. We're going to explore all of these primitive data types in Java over the next few videos. Alright, If you remember from the previous video, we created some code in JShell which declared a variable of type int and assigned it some expression, which we'll do again now. Int my value equals 10,000 semicolon, then enter. So what that's doing, if you recall, it creates a variable called my value of type int, and next we're initializing it here on the same line with the value of 10,000. The computer has allocated enough space to store an int, and it's assigned a name for that variable of my value. But if you're pretty new to programming, you may be asking what actually is an integer and what values can be stored in an integer. An integer is a whole number, meaning it doesn't contain a fractional element or a decimal. There's a specified range of values allowed for the int, which is true for most data types. What this means is that the allowable range of values is not infinite. There's a defined minimum and maximum value for each numeric data type, meaning you can't assign a number bigger or smaller outside of that range. So how do you know what that range is, and is it important to know? We can get that range programmatically for each data type, and there may be times when we'll need to test if a value is in range. Alright, let me first show you how to get the valid range for an int. Let's type in some code in JShell, then we'll review it carefully. Int my minInt value equals integer.min_value semicolon. Okay, so what are we doing here? You maybe could guess, based on our previous discussion, that this is the minimum value of an int data type. You can see that we created a variable of type int and named it my minInt value, and we've assigned it an expression. This expression, integer.min_value, will look unfamiliar to you. That's because integer is a wrapper class, which we'll explain shortly, but for now you just need to understand that there are some values stored on this class which we can retrieve by this mechanism. Here we're getting the minimum value allowed for an integer data type. Let's press enter and see what that value is. JShell will echo the value derived from the expression, as we see next. This is telling us that the minimum value you can assign to an int is -2,147,483,648. You cannot try to assign a value less than that to an int variable, and we'll get into that shortly. But first, let's get the maximum value by doing the same kind of thing using a slightly different expression. Int my maxInt value equals integer.max_value semicolon. Now that we know the min and the max values, we can say that the range of values which an int data type can store is from integer.min_value to integer.max_value. Let's use some of the programming skills we've learnt so far to print out that range as a statement to the JShell window. Next, I'm going to show you how to display both text and some non-text data on the same line. First, let's just print out the minimum value in a statement to the console. Instead of just printing the variable as we've done before, we're going to first print a label saying what it is, then print its value. So we'll start by typing system.out.print, opening parentheses, double quotes, integer minimum value equals plus my minInt value, closing parentheses, semicolon. The plus sign, plus, when used in system.out.print, will print different data types together as a single line of text. In the example, we want to print a label before a numeric integer value. Whatever follows the plus sign in system.out.print here is converted to a string by Java and concatenated to the string before it. This is perfectly valid syntax in Java. And pressing enter will print out a more informative message for our users. So it's a handy way to combine text with numeric output. There are better ways to print this out, but at this point in the course, the use of the plus operator is perfectly acceptable. Let's do the same thing, but instead of using our variable, we can just use the expression integer.min_value. System.out.print, opening parentheses, double quotes, integer minimum value equals plus integer.min_value, closing parentheses, semicolon. This gives us the same output as before, so we can use either a variable or this type of expression here. And now let's print the range for the integer in a single line of text for our users. First, I'll do this on a single line in JShell. System.out.print, opening parentheses, double quotes, integer value range, opening parentheses, plus integer.min underscore value plus double quotes to plus integer.max underscore value plus double quotes, closing parentheses, semicolon. It may not be perfectly obvious looking at this statement, but here we are putting a string literal, including a left parentheses we want printed out. Then we follow that with a numeric value, the minimum value. Next, we print the word to, and then the maximum value. We end with a final string literal, a single closing parentheses, to make our line of output more readable. Pressing enter, you can see we have nice succinct output, even if that code looked a bit ugly. Let's look at that statement again, but this time I want to do the same thing, but on multiple lines in JShell. Hopefully, you can see more clearly how many times this one expression is using the plus operator. When we introduced JShell, we talked about when you leave a Java statement unfinished and press enter, JShell prompts you for more code with the ... and right arrow prompt. So let's try this now. System.out.print opening parentheses. JShell is waiting for us to type something in, so let's go ahead and type in the rest of the statement. Integer value range left parentheses. Plus integer.min value plus two in quotes plus integer.max value plus closing parentheses in quotes. Notice this is a string literal and not actually the closing parentheses for the statement. Closing parentheses, semicolon. Looking at the code this way, you can see the expression is made up of three string literals, one of which is a right parentheses only. There are four plus operators, as you can see, and two integer values. Again, not really elegant, but pretty useful if we don't want to constantly be outputting small amounts of information. Pressing enter gives us the same result as before. Let's talk about why we're using integer in the expression to get the min and max value. That's because int is a primitive type that really only gives us the option to set the variable's value. Integer, on the other hand, is what's called a wrapper class. Let's talk about wrapper classes now, but first, to understand them, we need to briefly talk about classes. So what is a class? A class is a building block for object-oriented programming and allows us to build custom data types. We'll be talking more about classes in a future video. Java uses the concept of a wrapper class for all of its 8 primitive data types. A wrapper class provides simple operations as well as some basic information about the primitive data type which cannot be stored on the primitive itself. We saw that min underscore value and max underscore value are elements of this basic information for the int data type. The primitive types and their respective wrapper classes are shown in the table below. You can see there that in general, it's pretty easy to remember the wrapper class name for your primitive data type. It's the same name, but with an uppercase letter at the start. The wrapper classes for char and int, character and integer respectively, are the only two that differ in name other than that first capitalized letter from their primitive types. We'll talk more about these later on, but for now, let's take a look at int and the integer wrapper class. In the case of an int, we can use integer, and by doing that, it gives us ways to perform operations on an int. In the code we just reviewed, we were able to use min underscore value and max underscore value on the wrapper class integer. To discover the minimum and maximum range of numbers that can be stored in an int, as we saw when we printed out these values previously. Min underscore value is the smallest value we can set an int to, and max underscore value is the biggest. Just to confirm that, let's try adding just one to the max value and see what happens. So to do that, we're going to type system.out.print opening parentheses, double quotes, busted max value equals plus opening parentheses, my max int value plus 1, close both parentheses, semicolon. So what we've done is add 1 to the maximum value, which technically shouldn't be possible because we've established that my max int value already contains the maximum value of an integer. Press enter and let's see what the output is. Look what's happened to the busted max value. We've assigned the maximum value +1 to it, so how is it possible the outcome is a negative number? This is called an overflow, meaning we tried to put too large a number into the space allocated by the computer for an integer. Now it didn't fit, but the computer tried to fit it anyway, instead of throwing an error, and by doing that, it overflowed. The reverse is also true here, and we'll try that for the minimum value. We'll press the up arrow key, and then change the plus to a minus, my max int value to my min int value, and we'll change the text max to min. Can you see what's happened there? In the case of our busted min value, trying to subtract 1 from the minimum value, we've ended up cycling around to the maximum value. This concept is called underflow this time, and not overflow. If you try and put a value larger than the maximum value into an int, you'll create something called an overflow situation. And similarly, if you try to put a value smaller than the minimum value into an int, you cause an underflow to occur. These situations are also known as integer wraparounds. The maximum value, when it overflows, wraps around to the minimum value and just continues processing without an error. The minimum value, when it underflows, wraps around to the maximum value and continues processing. This is not usually behavior you really want, and as a developer, you need to be aware that this can happen and choose the appropriate data type. Imagine if you had a counter for your website visits and set it to an int data type. If you were fortunate to reach that maximum value, which we said was about 2.14 billion, your counter would then go negative. As we'll see in the next video, there's a data type to hold much bigger numbers if we need them to avoid situations like this. But ultimately, as programmers, it's our responsibility to use the appropriate data type and also to ensure the range of numbers we're trying to store in that data type is really within the supported range. In addition to the problem of underflow and overflow, assigning a literal number that's outside of the valid range for a variable will throw an error. Let's take a look at an example. First, let's print out what that maximum value is again. System.out.print, opening parentheses, double quotes, integer maximum value equals, plus integer.max underscore value, closing parentheses, semicolon. And now we want to assume a value that is the max value +1. Int my max int test equals 214748368, semicolon. Note here that the number we've typed in ends with an 8 and not a 7. So it's bigger than the maximum value by 1. So what we've done here is we've assigned a numeric literal to my max int test that is bigger than the maximum value. As a result, this time we get an error. In this case, the number is too large. You might be asking, what's the difference between this and what we did earlier? An integer wraparound event, either an overflow or underflow, can occur in Java when you are using expressions that are not a simple literal value. The Java compiler does an attempt to evaluate the expression to determine its value, so it does not give you an error. Here are 2 more examples that will compile and result in an overflow. The second example may be surprising. Even though we're using numeric literals in the expression, the compiler still won't try to evaluate this expression, and the code will compile, resulting in an overflow condition. If you assign a numeric literal value to a data type that is outside of the range, the compiler does give you an error. We looked at a similar example previously. This might seem like a confusing difference right now, but don't worry, we'll be talking about equation results more in the operator section of the course, and how these expressions are a bit different than literal expressions. Let's just correct that last statement now by changing the last digit back to a 7. And this time, we don't get an error. So any number literal you use, similar to what we've shown in the code sample so far, is assumed to be of type int by Java. There are ways to tell Java otherwise using a character at the end, which we'll get to in the next video. I want to point out one other feature in Java for numeric literals, which is valid syntax, because you might find reading large number literals somewhat hard to understand. In Java, you cannot put commas in a numeric literal. For example, the following is not valid syntax. So Java provided an alternative way to improve readability, the underscore. You can put the underscore anywhere you might want a comma, but you can't use an underscore at the start or end of the numeric literal. Just like how we would use commas in a document to make numbers more readable when we write them out, we can use underscores in Java code to achieve the same goal for any readers of our code. So let's walk through what that looks like in JShell. So we'll press the up arrow key to display the previously typed in code. Then we'll add the first underscore before the last 3 digits. We'll add another underscore before 483, and then the last one we'll add after the first 2. So you can enter it in that format if that's easier for you to understand and to read at a glance. Let's end the video here, and in the next video we'll discuss 3 more primitive types, namely the byte, the short, and the long. I'll see you in the next video. In the previous video, we saw that Java has 8 primitive data types and that the wrapper classes give us extra options. Of these primitive types, half are used to store whole numbers, numbers without a fractional or decimal component, one of which we've explored already, the integer or the int data type. In this video, we'll take a look at the other 3 whole number primitive data types. These are the byte, the short, and the long. We've previously said that Java has 4 primitive data types used to store whole numbers. These are the byte, the short, the int, and the long. They are listed here in this table by the range of values the type will support. The byte supports the smallest range, and the long supports the largest range. So short is shorter than int, meaning the value range of valid values is shorter, and long is longer than int, and the byte is the smallest of them all. So let's start with the byte. In the last video, we output the valid range of the int in a single line of text, which I'll show again here. System.out.print, opening parentheses, double quotes, integer value range, opening parentheses, plus integer.min underscore value, plus, double quotes, to plus integer.max underscore value, plus, double quotes, closing parentheses, semicolon. We use the wrapper class integer to get the min value and max value from that class and append it all in a single line of code. One reason to do it this way was to first show you how to print out different types of data using the system.out.print statement. And also, for the next few exercises, I think you'll find it's a bit easier to see the ranges in a single statement, like we've done here. Our output is printed out in a single line of text, as we can see. So how do we go about exploring the range for a byte data type? You've got it. We use the byte with a capital B wrapper class and replace integer everywhere in the previous statement we see with the byte. So let's do that. The output now is shown with the byte value range. Now you can see that in the case of a byte, the range is quite small. The minimum value of a byte is minus 128. The maximum value of a byte is 127. Given its small range, you probably won't be using the byte data type a lot. The byte wrapper class is the byte. Maybe one reason to use a byte is if you had a requirement to store a lot of numbers that are within that range and you want to save memory or try to boost performance. A smaller data type takes up less space and can be quicker to access. Generally, however, this is less of a concern today because of speed of modern computers, but certainly was a factor when Java was first created. Another reason to use the byte instead of an int is if you wanted to document that you're only expecting or using a small range of values. This can be a form of code documentation in the sense that someone would read the code and then note you're using a data type, in this case that is quite small, and that there was a specific reason for it. Alright, so that's the byte data type. The next one we're going to look at is our short data type. Let's do the same thing we did before and print the range out in a single system.out.print statement. I think by now you might agree with me that it's pretty handy to have the ability to use the arrow keys in JShell to retrieve statements we've already executed. This lets us quickly edit them and test similar code. We'll do that now to get the range of values for a short using the short with a capital S wrapper class. As expected, the range of values for short data types is broader than a byte's is, but not as large as the int data type. The minimum value of a short is minus 32,768. The maximum value of a short is 32767. The short wrapper class is the short. Both the byte and the short have the same overflow and underflow issue as the int data type has, but obviously with their own range of numbers. In other words, if you're using an expression assigned to a byte and its value might go over the value of 127, you could end up unexpectedly with negative numbers. Be sure to review overflow and underflow in the previous video, since this is an important concept. Next, let's have a brief talk about how much space each of the data types we've talked about take up in memory. It's this amount of space that determines or limits the range of values we've been discussing. Alright, so I want to talk about the size of primitive types and what width means. Size, or width, is the amount of space that determines or limits the range of values we've been discussing. A byte can store 256 numbers and occupies 8 bits and has a width of 8. A short can store a large range of numbers and occupies 16 bits and has a width of 16. An int has a much larger range, as we know, and occupies 32 bits and has a width of 32. The point here is that each primitive type occupies a different amount of memory. We can see that an int needs 4 times the amount of space that a byte does, for example. It's not particularly relevant for you to know these numbers, but it could come up as an interview question, and it's useful to know that certain data types take up more space than others. Also note that size, in all capital letters, like min_value and max_value, is available in the numeric wrapper classes, so you could use integer.size if you forget the size of an integer, for example. Alright, so there's one more data type, and that's of use to you when you've got a large number that you want to process that's larger than the range available for an int. We call that type the long data type. Let's go ahead and create a variable of type long. Long, my long value equals 100 semicolon. This looks simple, but technically what I've done there is wrong. Well, maybe not wrong, but misleading. The number 100 by default is an int. Java allows certain numeric literals to have a suffix appended to the value to force it to be a different data type from the default type. The long is one of these types and its suffix is an vel. This is one of the few instances Java is not case sensitive. A lowercase vel or an uppercase L at the end of a whole number mean the same thing. The number is a long. When you're assigning a long literal value to a variable, you need to put the letter L on the end of it, and that tells the computer that it's a long value. Remember, I mentioned at the start of this video that Java will default literal whole numbers to be integer data types. So 100 in this line of code is really an int being assigned to a long variable type. So let's make it more clear for people who'll be reading our code later on. We can go ahead and put an L character suffix on the numeric literal there. And you can see that can be really confusing, since a lowercase L looks very similar to the number 1, making it look like we might be assigning 1001 to my long value. So for that reason, when you're including the L suffix, I recommend that you use the uppercase L to make it clearly stand out. We can see that it's much easier to read and recognize with the capital L. First, we know our literal value is a long data type by the use of the uppercase L suffix. And we can see it's being assigned to a long variable which will have enough space to hold that largest range of numbers. A long has a width of 64. Do you remember how we can check that programmatically? Let's do that here real quick, since we've only talked about it in a slide previously. System.out.print, opening parentheses, double quotes, a long has a width of plus long.size, closing parentheses, semicolon. In this code, we use the wrapper along with a capital L and retrieve the size or width of that long data type from its wrapper class. Remember, case matters, so we use long.size. The capital L on long in this case means we're using the wrapper class. Size in all capital letters is the way we get the size of the data type from the wrapper. The size of 64 is obviously double the size of an int data type, which we established had a width of 32. This means it's twice the width of an integer, so the actual number we can store in a long primitive type is huge. It's actually 2 to the power of 63. Let's get that range as we've done previously for the other data types. As expected, the range of values for long data types is much larger than the int data type. Now, compare that to the size of an integer, and it's significantly larger, as you can see. How big is the difference in the range of values that a long can store compared to the int? You can see from this table that the difference is quite significant. So the long data type has a pretty big range of numbers there, and yes, it's got the same type of overflow and underflow problem we've discussed for the other primitive types. The del character lets Java know you really did mean for the number to be treated as a long. It turns out, in some circumstances, we don't have to use the L suffix. Let's swing back to JShell now. Let's assign the value of 100 to my long value, but without using the L suffix this time. My long value equals 100 semicolon. The reason this works is that an int will always fit into a long data type because a long is twice its width. So Java is smart enough to know that. Java will convert it into a long instead of giving us an error. But if we try to type in a literal value for a number that is bigger than an int can handle without the long suffix L, we'll get an error. I'm not sure that makes sense to you without seeing it in code, so let's look at that in JShell so you can understand what I'm talking about. We know that previously we've used the maximum range for an int as a literal value and assigned it to an int variable. So let's start with that using the max value for an int and assigning it to a new long variable we'll create. Long, big long literal value equals 2_147_483_647 semicolon. We know that's the maximum integer number. But if we change that, making the value bigger, which we'll do here by adding an underscore, and the number's 234 to the end of the literal value in the previous statement. And now we get an error, as we can see there, integer number too large. Clearly, Java is telling us it's still treating that number as an integer. A numeric literal that exceeds integer.max_value must use the del suffix. We cannot create a numeric literal in Java that exceeds integer.max_value without using the del suffix. We'll always get the error integer number too large. So if we put an L on the end of the number there, it treats it as a long. Now suddenly, that number has been accepted. Clearly this is correct. It's got the 234, which we added at the end. Before we finish the video, let's talk about how Java is also smart when it comes to converting numbers from an int data type to something smaller like a short type. Java can determine if the numeric literal value we're going to use is not going to fit into the short variable. Let's look at this with some code in JShell. Short, big short literal value equals 32768 semicolon. Clearly we've got an error there and it's saying incompatible types. It requires a short but found an int and the value of the int doesn't fit into a short data type whose max value we've seen in this video is 32,767. But if we change that last digit to a 7, which we know is valid because it's the maximum value of a short data type, the error's disappeared and Java is quite happy to let you assign the literal 32,767, which is by default an integer, to that short variable. In this particular case, the literal number we've entered doesn't exceed a short's maximum value and it can actually fit directly into our short variable. Alright, so let's finish the video here, and in the next one we'll start talking about a bit of arithmetic using these data types, and then we'll talk about another important concept called casting. So I'll see you in the next video. In the last video, we were introduced to 3 new data types, the byte, the short, and the long. In this video, we'll be using these additional types in some basic arithmetic. We've already done some math using integers, but now we'll be using these other data types. We'll finish the video with a discussion about casting, which is a way to get Java to treat a variable of one type like a different data type. We'll talk about when and why casting is sometimes necessary in Java code. So let's start by declaring a couple of local variables, starting with one short and one long. We'll use the wrapper classes to get the minimum value for each data type. We did this in previous videos, so it should be familiar to you by now. But this time, we're going to do something a little differently. We're going to declare and initialize the variables on the same line in JShell, something we haven't done before this. Short, my min short value equals short.min_value, semicolon, int my min int value equals integer.min_value, semicolon. This is perfectly valid syntax for different data types as long as we use a semicolon between each declaration, as I'm doing here. This is really taking 2 lines of code and just typing them out on a single line for convenience. Okay, let's press enter and see if that works. And JShell prints out the values of our variables, so we know this line executed successfully. It's also possible to declare 2 variables in a single statement, so let's do that next. Byte myMinByte value equals byte.min_value, comma, myMaxByte value equals byte.max_value, semicolon. Here, we are declaring 2 byte variables, but it's important to note that the byte data type is specified only once at the start of the statement, and the variable declarations and assignments are separated by a comma. If we press enter now, we can see that worked fine. There are some rules for declaring multiple variables in one statement, however. You cannot declare variables with different data types in a single statement. If you declare multiple variables of the same data type in a single statement, you must specify the data type only once before any variable names. So let's break the rules and see what happens. First, we'll try to declare 2 variables with different data types in the same statement. Short, first short, equals 1, comma, int, first integer equals 2, semicolon. And you can see this gave us the error identifier expected. This problem is easily fixed by changing the comma to a semicolon, which we'll do to fix that up. We'll just press the up arrow key and change that statement to 2 statements, replacing the comma with a semicolon. And that worked because now we simply have 2 separate statements on one line. Next, let's try to break the second rule, which is about declaring 2 variables of the same type in the same statement. Byte, first byte equals 1, comma, byte, second byte equals 2, semicolon. And you can see this gave us the error identifier expected. The problem here is the second byte data type declaration. You can fix this in one of 2 ways, either change the comma to a semicolon which creates 2 separate statements, or remove that second byte data type after the first comma, so let's do that. We'll press the up arrow and edit that line and remove the word byte after the comma there. So these are a few rules for declaration statements, but don't worry if you find it a little hard to remember or confusing. We'll be reviewing these rules and others as we progress through the course. When we move over to IntelliJ, it will guide you when you do make mistakes. Just remember that putting more than one statement on a single line is perfectly legal in Java. A statement needs to end in a semicolon, and multiple statements cannot be separated by commas. Okay, so enough of syntax rules. Let's get back to some math. Let's use one of the variables we just created in a division operation. For this, we'll type in a bit of code. Make sure you follow along yourself, typing this code in JShell. Int myTotal equals opening parentheses myMinInt value divided by 2 closing parentheses semicolon. So that's just a simple bit of math that takes the value in the variable myMinInt value, which of course is the minimum value of an int, and divides that value by 2. The new variable myTotal of type int gets the result of the division operation, and this all works without any issues. Let's try the exact same thing, but this time with the byte data type, creating a new variable of type byte called myNewByteValue. Byte myNewByteValue equals opening parentheses myMinByteValue divided by 2 closing parentheses semicolon. Now suddenly we've got an error. So why have we got an error? Shouldn't this work? We know that the value of the result of that division operation should be in the range for a byte. The Java compiler does not attempt to evaluate the value in a variable when it's used in a calculation, so it doesn't know if the value fits and throws an error. If your calculation uses literal values, Java can figure out the end result at compile time and whether it fits into the variable, and won't throw an error if it does. In both examples, an int result is being returned from the calculation, but in the second example, Java knows the return value can fit into a byte. We know that if we simply assign a literal value to a byte variable and the literal value fits, there's no problem. But here we've got an expression that uses a variable that's been divided by 2. That's the difference compared to what we've done previously when we've used a literal value. Java can make assumptions about literal values that it can't make about expressions with variables. This problem comes about because the default whole number used by Java is an int, and that's why we've got an error here. So basically, what's in the parentheses is treated as an int by the computer, and that's why we're getting this error. But we definitely know the expression will result in a number that fits. So how do we let Java know? Well, we do that with a concept called casting. Casting means to treat or convert a number from one type to another. We put the type we want the number to be in parentheses like this. Other languages have casting too. This is common practice and not just a Java thing. So let's do that. We'll cast the result of our expression to a byte before we assign it back to our variable. Opening parentheses, byte, closing parentheses. And now we can see the error has disappeared. Because we've used this cast, we've told Java treat this value following the parentheses, byte, parentheses as a byte, and the error disappears. And we're really being specific here in telling Java that this is a byte, so treat it as a byte instead of the default, which was an integer. And we can do exactly the same thing for a short. So we can type short, my new short value equals opening parentheses, my min short value divided by 2, closing parentheses, semicolon. And as we see, that gives us the same type of error. But this time, it's requiring a short and found an int data type again. So let's use a cast in the code. Opening parentheses, short, closing parentheses. And the error disappears. So what effect does int, being the default value, have on our code? Looking at the scenarios we just looked at in summary, we know the following. This statement works because the result is an int, and assigning it to an int variable is fine. This statement doesn't work because the expression, my min short value divided by 2, is an int, and an int can't be assigned to a short because the compiler won't guess the result. This statement works because the result of minus 128 divided by 2 is an int, but when calculations use only literal values, the compiler can determine the result immediately and knows the value fits into a short. And finally, this code works because we tell the compiler we know what we're doing by using this cast, and the compiler doesn't give an error. So generally speaking, an integer is the whole number you are most likely to use in many cases, and you can probably guess that now because Java uses the int by default. That's more or less telling us that that's what it's expecting to use most of the time. Because an integer is assumed automatically by Java, you saw that in these cases, we got an error when we were assigning calculations to smaller data types. In the first case we demonstrated using the variable myTotal, we did use an int variable, and that's why we didn't have any problem with the result also being an int. Because of this, my advice is to always use an integer unless you've got a really good reason to not do that. Alright, so let's end the video here, and in the next one, it's time for a challenge to solidify some of the information we've been learning in the last few videos. I'll see you in the next video. Alright, so we've covered a lot of material and it's time for a challenge. Your challenge is to create 4 new variables. A byte variable, set it to any valid byte number, it doesn't matter. A short variable, set it to any valid short number. An int variable, set it to any valid integer number. Lastly, create a variable of type long. Make it equal to 50,000 plus 10 times the sum of the values of the first 3 variables, your byte, your short and your int values. In other words, use the variable names in your expression to calculate the sum. Pause the video now, and I'll see you when you get back. Alright, how'd you do? Were you able to figure that out on your own? Let's walk through the solution together now. You will find that as the challenges get more complex, you may do it one way, or I might come up with a different method. This is not only perfectly valid, it's a great way to discover multiple ways of getting one task done and should increase your learning. No matter how experienced you are as a programmer, you can often learn something new or interesting by reviewing someone else's code. Okay, let's start off by creating our variables. We've got byte value equals 10, semicolon. Short value equals 20, semicolon. Int value equals 50, semicolon. So we've got our first 3 variables set up. Next, we'll work out how to build the expression for the last variable. Long total equals 50,000 L. I'm going to put an L there to signify it's a long data type. Plus 10L times. After this, we need to multiply that by the sum of the byte, short, and int values. We can add that directly into the same statement. Opening parentheses, byte value plus short value plus int value, closing parentheses, semicolon. So that's actually one solution done in a single line. And just to confirm this, and there you can see we got the result 50,800. Even with this small exercise, there were different ways to do it. Maybe you added a variable that first summed up the byte into long variables, then included this in your expression for the long variable. Let's quickly do that. I know my challenge did not call for this additional variable, but if you did code it this way, it's valid and another good way to do it. Int sum of 3 equals byte value plus short value plus int value semicolon. And then we can use that in the expression that we assign to the final long variable. Long total equals 50000L plus opening parentheses 10 times sum of 3 closing parentheses semicolon. And again we get the value of 50,800. In the last statement, I added a set of parentheses around part of the equation. Parentheses are another way to make your code more readable. They also make it clear which calculation should be done first. In this case, it's a bit more obvious we are multiplying the sum of the other 3 variables by 10 before adding it to the 50,000. I also did not include the L suffix in the numeric literal 10 in this example. Remember that L is optional if the value is less than the integer maximum value. You can include it as a way of creating self-documenting code for future readers, but it works just the same without it in this instance. So, those are just 2 variations to the same end result. Maybe you came up with others. Considering the many paths to the same end result is one of the things that makes programming so interesting. Also notice how we didn't need to do any casting. This is because the right side produced a long because we used a long literal in the first part of the equation, so in this instance, the result is a long. But what if we wanted to do something similar with a short? I know this isn't part of the challenge either, but we'll just go through it anyway. That would be something like short total equals opening parentheses 1000 plus 10 times opening parentheses byte value plus short value plus int value close both parentheses semicolon. Enter. Now clearly we've got an error doing that, and the reason why we've got an error is it required a short but found an int. Now we do have to cast. So we need to be specific here and put a short cast in front of the expression there. Opening parentheses, short, closing parentheses. We created a short cast by adding the word short in parentheses before the parentheses that enclose the full equation. If we press enter now, we get the output 1800 and not an error. So the point of this, after solving the challenge, was just to suggest that integer is the best primitive data type for whole numbers generally. But even if you're using type long, you saw that Java handles a lot of the complexity for you, and you don't have to do this casting with a long. So that's it, 4 bytes, shorts, integers and longs, which are the first 4 primitive types in Java's list of available types. We still have 4 left to go. In the next video, we're going to start talking about decimal numbers because, of course, we've only been dealing with whole numbers up until now. Some things work fine with whole numbers, like age and air temperature, but there are many things that do not, like your bank account balance or mathematical constants like the value of pi. Conversion equations are also rarely expressed in whole numbers. For example, you might want to convert pounds to kilograms or something of that nature. In that scenario, having the ability to use decimal points in the number would be necessary for an accurate conversion. So let's start working on that in the next video. It's now time to start looking at floating point numbers. Unlike whole numbers, floating point numbers have fractional parts that we express with a decimal point. In this table, you can see some examples of both whole numbers and floating point numbers in comparison. Floating point numbers are also known as real numbers. The examples on the left show 2 positive, numeric literal integers, and one negative long. The examples on the right show just a couple of ways to express floating point numbers. We use a floating point number when we need more precision in calculations. There are two primitive types in Java for expressing floating point numbers, the float and the double. The double is Java's default type for any decimal or real number. When we talk about floating point numbers, we talk about both the width and the precision of the type. Precision refers to the format and amount of space occupied by the relevant type. This table shows the width of each of the floating point types and their ranges. The ranges are shown in Java's scientific notation, which we show below in blue colour. You can see the E notation followed by either a positive or negative number. Scientific notation can be translated into more familiar terms by replacing the E in the number with the phrase times 10 to the power. So we can say the minimum value of a float is 1.4 times 10 to the power of minus 45, and its maximum value is approximately 3.4 times 10 to the power of 38. Think about that for a moment using the double's minimum value shown below, remembering that 10 to the power of minus 1 equals 0.1 and 10 to the power of minus 5 equals 0.001, for example. Imagine writing out the double data type's minimum value in decimal format. That would be a lot of zeros after the decimal. I hope you can see that a double can represent a much smaller decimal value than a float, and also a much larger decimal value than a float, which is why it's called more precise. Because it's more precise, Java chose it as the default type for floating point numbers. So now that you know what kinds of values a float and double type will store, let's go back to JShell and see them in some Java code. Alright, so now that we're back in JShell, let's confirm what we saw on the slide, what those ranges are. We'll do something similar to what we've been doing for other primitive types by retrieving their min and max values from the related wrapper class. We'll do that with a statement that might look familiar to you now. This code is similar to the way we got ranges for the whole number data types. System.out.print, opening parentheses, opening double quote, float value range, opening parentheses, opening double quote, plus float.min underscore value, plus opening double quote, to closing double quote, plus float.max underscore value, plus closing double quote, closing parentheses, closing double quote, closing parentheses, semicolon. Remember, we're using the wrapper float with a capital F and getting both the min underscore value and the max underscore value and printing it with informative and formatted text. Now let's execute this by hitting enter. And you can see in the output that we have the values we saw on the slide. Now let's do the same thing for double by replacing float with double in the last statement and executing that statement. And you can see again in the output that we have the values we saw on the slide for double. So you really can see there that a double can work with a much bigger range of numbers, and it's also a lot more precise than the float. But of course, on the other hand, it needs twice the amount of memory, 64 bits or 8 bytes, to store that number compared to the float, which requires 32 bits or 4 bytes to store its number. Now that we conceptually understand floats and doubles, we're going to take a look at how to use some of these variables. We'll start by declaring three variables, an integer, a float and a double, and you'll see why later on in the video. We're going to do this on a single line in JShell again because it's a bit more convenient and I think easier to see. Int my int value equals 5, semicolon, float, my float value equals 5, semicolon, double, my double value equals 5, semicolon. Before we continue, let's quick talk about two other numeric literal suffixes. Earlier, we learnt that the letter L is used in a whole number literal if the value is greater than the int's max value or smaller than the int's min value to specify a long value. The suffix is optional otherwise, but you might want to use it to self-document code. Important, the double data type is Java's default type for real numbers. For example, any number with a decimal is a double. So 10.5 is a double by default in Java. The double data type can be specified as a numeric literal with a suffix of either lowercase d or uppercase d, but because doubles are the default in Java, the suffix is optional to use. The float data type can be specified as a numeric literal with a suffix of lowercase f or uppercase f. This suffix is required if you're assigning a real number to a variable that was declared with a float type. Much in the same way Java has chosen to use an int as its default data type for a whole number, Java uses a double for its default type for a real number. It is important to note that Java did not choose the smaller and less precise float data type. This is because using a more precise data type generally outweighs the benefits of using less memory. Unless you're absolutely certain you don't need that additional precision in your results, it's best to stick to using a double rather than a float. So getting back to our code, notice that we haven't put anything on the end there of any of the number files. What I mean is, we haven't included a suffix in the numeric literal that we assigned to any of these variables. We just used a simple literal file. You may remember we used a nil suffix when we wanted to specify a long literal. But you can see we did not put an FD or any suffix there, and that's been accepted and executed fine. What this means is we can assign an integer literal to both a float and a double variable. You can put an F or D there to confirm the data type. It's good practice to do that in general if you're typing in literal numbers to make it abundantly clear what you intend them to be. So let's do that now, first for the float variable we previously declared. My float value equals 5F semicolon. And then for the double, my double value equals 5D semicolon. So you might have noticed that we got the same output whether we use the suffixes or not when we assign a whole number literal to these variables. That works fine for a whole number, but you'll find that if we add a decimal 0.25 to make it 5.25, a decimal number. Now, if we remove that F there, we will actually get an error. Let's try to declare a new float with a value of 5.25. Float, my other float value equals 5.25 semicolon. And now we get an error. The reason we get this error is, as previously pointed out, the double is the default floating point number in Java. So here, we've got a similar problem to what we saw with other data types in previous videos. On line 2 of the output, you can see that Java doesn't like trying to put a double into a float variable type. In this case, the literal value that we've typed in, 5.25, is being interpreted as a double. Alright, so next, a quick challenge for you. Thinking back to our discussion on casting, how do you think you'd do the same for the float to remove this error? So have a think about that. Pause the video and try it out and see if you can get it to work to remove the error. When you're ready, come back and resume the video and we'll go through the solution. So pause the video now. Okay, so welcome back. Did you get that working? If you remember, the format of the cast is the name of the data type you want to convert to, a float in this case, inside the left and right parentheses. Float, my other float value equals opening parentheses, float, closing parentheses, 5.25 semicolon. I usually add a space there between the cast and the value just to make it clear. So what's happened here is the error has disappeared. That's because we're telling Java, yes, this is a literal double that's been typed here, but we want you to treat it as a float, and for that reason, the error then disappeared. It's generally not recommended to do that though, for a couple reasons. Firstly, as I'll talk about in the next video, floats aren't usually recommended to be used much these days. Double is the preferred floating point data type to use. But secondly, it's a lot clearer, I think you'd agree, to just add the letter F right at the end that tells you, okay, that's a float. Float, my other float value equals 5.25f semicolon. And that's generally the format that most programmers will use. They would use an F suffix to indicate the type rather than explicitly cast it, which is just a little bit more code to look at. Not everyone realizes that Java's default data type for a decimal literal is a double, which is larger and more precise than a float. Java likes to put a similar line of code in its code segments on exam questions to what we saw earlier, omitting that F suffix. Without your compiler or IDE, this statement can look fairly innocuous. The number 5.25 is a double, so assigning it to a float will raise an error. This is a gift question to an exam taker if you can easily spot this compiler error. Just remember, in Java, a decimal number literal is a double. A float is less precise than a double, so you cannot just assign a less precise value to a more precise variable type without using a suffix or explicit cast. Alright, so let's finish this video here. Next, we'll start exploring more about these floating point types, and we'll start doing some division to see what happens and what those numbers will look like. So I'll see you in the next video. In the previous video, we were introduced to the primitive types Java uses to store real numbers, the float and the double. In this video, we'll take a look at the differences in precision when using arithmetic. Alright, so let's continue on with our floating point discussion and using the float and double primitive types. We're going to declare my int value, my float value and my double value from the previous video because we'll be using it again in this video. Int my int value equals 5 semicolon float my float value equals 5f semicolon double my double value equals 5d semicolon. Alright, we can see there that my int value is showing the value of 5. No surprises there. But the float and the double are showing the decimal points, so 5.0 and 5.0 both for the float and for the double value. Let's pause for just a minute and talk about the default output for numeric data types. In this slide, we show default output as it would be in JShell or by using system.out.print for both whole and real numbers. You can see from this table that there are more ways to express a decimal real number literal than a whole number with the use of the nef or d suffix, as well as using Java's scientific notation in the literal value. Another interesting difference is that, for whole numbers, the output is never in scientific notation. But for real numbers, it could be, as you can see. Later in the course, we'll learn how to make these numbers print with the exact format we want and specify the exact number of decimal places to be printed. Alright, so let's now try doing some division to see what happens. We are going to assign the output of a simple division equation to each of the variables we created, starting with simple integer division. So let's type my int value equals 5 divided by 2 semicolon. Okay, maybe for developers from other languages, this isn't such a simple thing. The result is a whole number of 2. Did you expect it to be 2.5? Java uses a rather complex process when determining what type of data to output from calculations based on the types of the numbers used in the equation. We're not going to get into that right now, except to say that because both 5 and 2 are integers, the result is an integer value, and that value is 2. The decimal part is not included. Let's try something similar with the float variable. My float value equals 5f divided by 2f semicolon. So here, we did get 2.5, as we expected, because we used the division operator on 2 floats. The suffix made these numeric literals floats here. In this case, Java returns a float, so we do not need to cast the result. And let's use a similar equation with double literals and assigning it to our double variable. My double value equals 5d divided by 2d semicolon. We also get 2.5 as the output. So you can see what's happened there. The int type has got a value of 2, but both float and the double have got the value of 2.5. In the case of the float and the double, we've got a much more precise answer because it can handle the fractional part of a number. And obviously, that's the reason why you'd want to use a floating point number to be more precise with things like division. Alright, so moving on, let's explore this a little more. We'll change the divisor, which is the number we are dividing by, from 2 to 3. First, we'll do it for the integers, so 5 divided by 3 is assigned to an int variable. Can you guess the result? My int value equals 5 divided by 3 semicolon. Again, the result truncates any fractional part and returns a whole number, a value of 1. Next, let's do the same thing for the float. My float value equals 5f divided by 3f semicolon. You might remember that the real result of dividing 5 by 3 is 1.666666 with the 6's going on indefinitely. This is called a repeating decimal. In computer language, you can never represent this kind of number exactly, but you can represent it more or less precisely depending on the data type used. In this instance, the number is printed with 7 decimal places in the output. And now, let's see what the double division looks like. My double value equals 5d divided by 3d semicolon. For a double, the number is printed with 16 decimal places in the output. Actually, this output is a little misleading. For the float, the number stored in memory is actually more precise than that shown, but the output stops at 7 decimals. The same is true for a double. The number in memory is more precise than that represented by the number shown here in the output. But this example should make it clear that a double will more accurately represent numbers like these. Alright, and just a reminder again that in terms of the number that we're typing in here, if we're typing in a decimal number, we can do something like this. My double value equals 5.00 divided by 3.00 semicolon. We don't need the D suffix, remembering that Java will automatically look at a decimal number and assume it's a double. And we get exactly the same output as before. Let's take a moment here to change one of the operands to a literal int, leaving the other operand as a double or decimal number. So we'll again edit our previous statement and change 3.00 to just 3, a literal integer. So, as long as one of the operands is a double, your result will be a double. And another reminder that this won't work for your float variable. Let's try. My float value equals 5.00 divided by 3f semicolon. So here, even though one of our literals is a float, 3 with the f suffix in this case, the other is a double, 5.0, and the result is a double, and you cannot assign a double to a float variable. So you might be thinking that given the fact that double takes up double the amount of space compared to the float, which is a single precision number, that perhaps you should be using the float data type. However, the double primitive type in this case is recommended, and there's a number of reasons for it. Why should we choose double? First, it's actually faster to process on many modern computers. That's because computers have, at the chip level, the functionality to actually deal with these double numbers faster than the equivalent float. Second, the Java libraries that we'll get into later in the course, particularly math functions, are often written to process doubles and not floats, and to return the result as a double. Java selected the double because it's more precise and it can handle a larger range of numbers. So consequently, you'll find that double was used a lot in the code that's out there in the various libraries. So for all those reasons, it's highly recommended that you use the double. For that reason, I'm not going to be using the float anymore in this course. Any floating point number code that we use moving forward will be a double. Alright, so to end this video, it's time for a quick little challenge. The objective of this challenge is to convert a given number of pounds to kilograms. Steps. 1. Create a variable with the appropriate type to store the number of pounds that we want to convert into kilograms. 2. Calculate kilograms using the variable above and store the result in a second appropriately typed variable. 3. Print the result. Don't forget to use the conversion formula shown here. So pause the video now, type your code in and give it a test run and see if you can get the result. Alright, so welcome back. Hopefully you managed to solve that challenge successfully on your own, but let's go through it and come up with a solution. We're going to be using a double here for floating point numbers, and hopefully you've taken in my reasoning for using the double. So we're going to start by typing double number of pounds equals 200D semicolon. Now 200 is just an arbitrary number. You could have used any number for the calculation. And next, we're going to create another variable called converted kilograms. The formula we'll use will be the number of pounds we want converted times the number I gave you. Double converted kilograms equals number of pounds times 0.45359237D semicolon. We don't have to put the letter D there as a suffix because we're dealing with a double data type anyway and it would be assumed. But we'll do that for consistency. And we'll print out the results with a label again. System.out.print, opening parentheses, double quotes, converted kilograms equals plus converted kilograms, closing parentheses, semicolon. And you can see we've got a result there, 90.718474. Now, just to be sure that this result is actually correct, we'll open a browser. We go to Google and we'll say 200 pounds to kilograms. We've got the result there, 90.7185. Looking at our code, our result is 90.71847, so obviously that would be 7,185. Google has just rounded up. So clearly, our calculation has worked well. Okay, so that's good. We successfully converted pounds to kilograms, and hopefully you managed to solve that challenge. Another quick thing I wanted to show you is you're already aware now that we can type double pi equals 3.1415927D semicolon. But remember, we can also express a number using underscores. Here, we'll be including underscores both before and after the decimal point. Double another number equals 3_000.4_567_890D semicolon. So you can format it in that way if you want. I'm just showing you that because you may see that out in the wild when you're coding and wonder what it is. If we take a look at another number, we can see that it's stored exactly the same way we typed it in, minus the underscores. The 0 at the end of another number was ignored because it's not needed. Alright, so I just want to finish off by talking about another important point about floating point numbers. In general, float and double are great for general floating point operations. But neither should be used when precise calculations are required. This is due to a limitation with how floating point numbers are stored and not a Java problem as such. Java has a class called Big Decimal that overcomes this. You'll remember that we've said previously that a class is a kind of a custom data type, and Java comes with a whole library of helpful classes. For now, just keep in the back of your mind that when precise calculations are necessary, you'll probably need to use the Big Decimal class and not a float or double. For general calculations, the float and double types are fine. Again, we'll discuss this later in the course. Alright, so that's it now for the floating point data types. In the next video, we'll look at two more primitive types in Java, namely the char and the boolean. So I'll see you in the next video.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
In the previous videos, we've dealt with whole numbers and also with single and double precision numbers. In this video, we're going to talk about two additional primitive types in Java, the char and the boolean primitive type. Let's define our first char variable. Char, my char, equals, single quotes, D, semicolon. Here, we put the letter D in single quotes. That could be any single character, for example, a letter, a digit, or any other character like an exclamation mark, a hash, a dollar sign, and so on. It is important to understand that the char is different from a string. If you recall, we've used literal strings before, and that's where we've typed some text in double quotes. We haven't really used a string variable yet, but we'll be doing that in upcoming videos. This table is a quick summary of the differences between the char and the string. So, the char data type is similar to the string in one sense that it allows you to store characters. But in the case of the char, you can store only a single character, and the string supports many. The char's literal value is declared in single quotes, while a string uses double quotes, as stated in the previous slide. So let's go back and try and add a second character, like another D, inside the single quotes. You can see there, unclosed character literal, which means too many characters were found. Java expected to find only one character, followed by a single quote, but it found an extra character before the second single quote. It is literally only allowing us to save one character. Let's go back and delete that to make it valid. You might be wondering now, just how useful is this type? Why would you want to use a variable that only allows you to store one character? One example might be to store the last key pressed by a user in a game. Another example might be to loop programmatically through the letters in an alphabet. Chars were much more relevant when Java was released in the late 1990s compared to today, with much faster computers that have got lots more memory. So in these days, you don't need to focus so much on saving memory. For now, keep in mind that if you're going to be using a char, you can literally only store a single character in a single char variable. Now you might be looking at that and thinking, okay, I can only save one character, so therefore it must only occupy a single byte in memory. Well, it turns out in terms of storage, that's not the case. A char occupies 2 bytes of memory, or 16 bits, and thus has a width of 16. The reason it's not just a single byte is that a char is stored as a 2-byte number similar to the short. This number gets mapped to a single character by Java. So when you print a char, you will see the mapped character and not the representative number. And you can use single quotes and a character literal to assign a value to a char, which is much simpler than looking up the representative number. Imagine if this mapping wasn't done by Java and you had to go and look up the value in some lookup table each time you wanted to set or get a char. How tedious would that be? But in some instances, characters aren't represented on the keyboard, or you may have reason to use special characters in other languages. To do this, Java supports a Unicode value for characters, which you can use to set a char value. Unicode is an international encoding standard for use with different languages and scripts by which each letter, digit, or symbol is assigned a unique numeric value that applies across different platforms and programs. In the English alphabet, we've got the letters A through Z, meaning only 26 characters are needed in total to represent the entire English alphabet. But other languages need more characters, and often a lot more. Unicode allows us to represent these languages. The way it works is that by using a combination of the 2 bytes that a char takes up in memory, it can represent any one of 65,535 different types of characters. Let's swing over to the browser and look at a website called unicodetable.com. Here, we can see there that we've got a lot of symbols on the screen, and if we scroll down, you can see there's lots of different symbols, and these are all Unicode characters. And you can see there are pages and pages of characters, and as I'm scrolling down, that's actually generating more. So I'll go back up to the top again, just to the first letters there. Let's find the Unicode value for the capital letter D. There are actually 3 ways to get the value, and we'll walk through all 3. The easiest way to get the value is to hover our mouse over the letter or symbol we're interested in. A small pop-up will appear with 2 values. The first value, that starts with U+, has the Unicode value after the U+, so we are interested in the value 0044. The second way is to click the character. Here I'll click capital D, and now you can see a very large pop-up. Here you can see the label Unicode number and the value next to it. Again, this shows U+ 0044, so the Unicode value is 0044. Finally, if you like doing math, you can use the column and row headers to derive the value. For the capital letter D, the row header is 0040 and the column header is 4. You can add these numbers together, or another way to think of it, just replace the last 0 in the row header value, in this case 0040 with the column header value, which for this D is 4. Either way, it results in 0044. Now that we have the code, how do we use it in Java? We'll put the single quotes as we did before, but this time, because we're putting in a Unicode character, we need to put a /U in those 4 digits. You remember from the chart that it showed you, but in Java, the syntax is /U. Char my Unicode equals single quotes /U 0044 semicolon. Now you can see we've got D printed out there. Whether you use the literal character D or the Unicode representation /U 0044, you've stored a number representing the letter D in the myUnicode variable. The Unicode value is one way to represent a number. Let's pull up that chart again, and we'll go back and hover over the capital letter D. Here, what I want you to notice is the second half of this pop-up, DEC68. This stands for the decimal number 68. It turns out the integer 68 is another representation for the character D. What does this mean in Java? Well, it means you can assign a numeric literal to a char variable, which we'll do now. We'll assign the literal value 68 to a char variable. Char my decimal code equals 68 semicolon. And you can see this also prints out the character D. There are 3 ways to assign a value to a char. Each of these methods represents storing the letter, capital D, in memory. So we've seen that we can assign the actual character D in single quotes. We can assign a Unicode value using the /U notation, and we can even assign an integer value as we've shown. Let's do the same thing for another character, but this time we'll make it a challenge for you. Create 3 char variables to store the character for the question mark symbol. My simple char should be assigned the literal question mark character. My Unicode char should be assigned the Unicode value for the question mark. my decimal char should be assigned the decimal value for the question mark. Print all three variables in one statement that starts with the label my values are. Hint, use the chart at www.unicode-table.com. Okay, so pause the video now and give that a try. When you've completed that challenge or get stuck, come back and we'll walk through it together. So, how'd you do on that challenge? Let's go back to that chart at www.unicode-table.com and find the question mark character. In case you are looking for it, it is above the capital letter O. Once we find it, we'll just hover our mouse over it and we'll get that pop-up which gives us the two bits of information we need to complete the challenge, the Unicode value which is U plus 003F and the decimal value which is decimal value 63. So now let's write some code. First, the challenge said to set up a char named mySimpleChar and assign it the literal value for a question mark symbol, so we'll do that. Char mySimpleChar equals single quotes question mark semicolon. Next, we need to use the Unicode value, which we said was 003F, so let's do that, remembering that we use \U and not the U plus from the chart. Char myUnicodeChar equals single quotes \U 003F semicolon. And the third variable is a char named myDecimalChar, and we're going to set that to a number 63, which we also derive from the chart. Char myDecimalChar equals 63 semicolon. So in all three cases, JShell printed out a question mark. Now let's print these out using system.out.print. System.out.print, opening parentheses, double quotes, my values are plus mySimpleChar plus myUnicodeChar plus myDecimalChar, closing parentheses, semicolon. And you can see the output. My values are question mark, question mark, question mark. And that completes the challenge, so good job if you were able to do that. And hopefully now you understand why you'd use a Unicode value and how to look one up. So now the final data type we want to talk about is the Boolean. A Boolean value allows for two opposite choices, true or false, yes or no, 1 or 0. In Java terms, we've got a Boolean primitive type and it can be set to two values only, either true or false. The wrapper for Boolean is Boolean. Booleans are actually pretty useful and you will use them a lot when you're programming. What we want to do now is create a couple of Boolean variables. Let's go ahead and do that. Boolean, my true Boolean value equals true semicolon. Boolean, my false Boolean value equals false semicolon. So a Boolean can have one of two values. It can either be true or it can be false. So what would be a practical example of using a Boolean in a program? Well, let's just say you wanted to know whether a particular customer was over the age of 21 or not. We might create a Boolean like this. Boolean is customer over 21 equals true semicolon. You can see what we've done there. The variable name is a question. Is the customer over 21? And we've assigned the value of true to that, meaning that in this particular case, the customer is over 21. Developers will often use the word is as a prefix for a Boolean variable name. This creates a name that seems to ask a question, which makes reading the code more intuitive. But other prefixes can be just as valid. Here are some example Boolean variable names, such as is married and has children, that clearly define what condition is being tested. As we get more familiar with Java, we'll continue to look at both common and best practices for naming variables, classes, and methods. In terms of the Boolean, you'll see practical applications for this primitive type once we start tackling conditional logic. So, at this point in the course, we've covered all of Java's primitive data types. In the next video, we'll do a quick recap of these types, then we'll move from just using string literals, like our simple hello world example, to using string variables. Let's move on now to the next video. In the previous video, we looked at the char and also the Boolean types, which were Java's 7th and 8th data types. So at this point, you should be familiar with all 8 of Java's primitives. You've seen a similar slide before, and we'll show it again here. So, in review, the 8 primitive types that we worked on previously were the byte, the short, the int, the long, the float, the double, the char, and the boolean. Each of these primitive types, as we've discussed in previous videos, has got its own size and is used for different purposes. So the byte, as we found out, can only hold a number in the range of -128 to +127. It's entirely possible that you'll go for years as a Java developer and not even need to use the byte ever. But if, as the person writing the program, you know that a byte will fit your purpose, you can use it as a data type to increase the memory efficiency of the code you are writing. The most common primitive types you'll use will be an int, a double, and a boolean, and you'll probably from time to time need to use a long and a char, but not as often. The short, float, and byte data types are rarely used, if at all. As you get more experienced in Java, you'll learn to use the right primitive type for a given computing problem, and that's actually all part of becoming a programmer. So just to reiterate, those are the 8 data types we've looked at, all primitive types built into the Java programming language. As we go through the course further, you'll find that there's a way to create your own data types, which in Java are called classes. This slide demonstrates that most Java programs use some combination of the data types shown in this diagram. You'll use Java's primitive data types, Java's built-in classes, and probably some combination of your own custom classes and somebody else's. You've already been introduced briefly to a few of Java's built-in classes. These were the wrapper classes, and you may remember we mentioned big decimal as a better alternative to floating point primitives when working with currency. We've also said that classes are special data types that can provide extra functionality, like the wrapper classes that contain more information than a simple primitive type. What's interesting about classes is that you can combine data types like maybe one or more ints, doubles, booleans, etc., and create a sort of super data type, which again are called classes in Java. There's an entire section in this course on classes, so I'm not going to go into more detail about them here, except as it relates to the next type on our list, the string. The string is a data type in Java which is not a primitive type, as this slide clearly shows. It's actually a class, but it enjoys a bit of favoritism in Java to make it easier to use than a regular class. In other words, it's treated a little bit differently, and you can use it in ways you wouldn't normally for most other classes. So what is a string? A string is a class that contains a sequence of characters. If you recall, in the case of the char primitive type, it can contain only a single character, either a regular character or a Unicode character. A string, on the other hand, can contain a whole set of characters, in fact a large number of characters. It's technically only limited by the amount of memory space or heap space in your computer, which turns out to be the max_ value of an int. And if you recall, when we were looking at ints, that maximum size is around 2.14 billion. So that's a heck of a lot of characters that could potentially fit in a string. Let's jump back into JShell and take a look. We will define a variable of type string. String, my string, equals, double quotes, this is a string, semicolon. As you can see, a string is very much like a primitive type in terms of how we use it, meaning we can just assign a string literal to a variable. Now let's go ahead and print out our new string variable. But let's preface the string with a little descriptive message. System.out.print, opening parentheses, double quotes, my string is equal to, plus, my string, closing parentheses, semicolon. So here you can see we can also output a string literal and a string variable automatically by using the plus operator. In fact, you may remember we did something similar when printing string literals and other variables in one statement. You can also do something similar using the plus operator when assigning an expression to a string variable, so let's do that now. My string equals my string plus double quotes, comma, and this is more, semicolon. Let's print that out again by scrolling back through our JShell history and using the system.out.print statement we used previously. You can see that by using the plus operator, we get a result that is the original string plus the text we specified after the plus sign. When the plus operator follows a string, it technically is called the concatenation operator because the text that follows it is concatenated to the previous text and returned as a result of that operation. And we can see from the output that my string is now equal to the full text. This is a string, and this is more. You can also use Unicode characters with strings. By looking up the Unicode character for a $sign on the unicodetable.com site we showed you earlier, I hope you'll understand how we retrieved the Unicode value of 0024. So let's test this out and add a $sign that way. Let's just set our string to a new value as we'll do here. My string equals double quotes, I wish I had \00241, comma, 000, comma, 000.00, semicolon. And the output says, I wish I had $1 million. We could have simply put the $sign character in place of the Unicode value, but there are times when symbols aren't available on your keyboard and you'll want to look up the Unicode value using them this way. This string looked a bit confusing because it was hard to see where the Unicode value ended and the numeric value, 1 million, started. I did it this way because I didn't want a space between the $sign and the dollar amount. So you can see that string has got some versatility. We can use a combination of Unicode characters and regular characters. Unlike the chart data type, we can actually have a significant amount of characters if we like. Alright, let's try something different now. There is a way in JShell to run a couple of lines of code, multiple statements, all at once, without declaring them on the same line. To execute multiple lines of code as a set, in JShell, first start with an opening curly brace and press enter. JShell will display an alternate prompt as you can see. You can add a statement and press enter until you've added as many statements as you want to run. Finally, add the closing curly brace, noting that a semicolon is not required after this brace. Once you press enter after the closing brace, all of your statements will run in the order you put them. So let's do that here. First, we enter a single left curly brace and press enter. This tells JShell we want to execute a few statements together and will display the ... greater than prompt we just discussed. String, number string, equals, double quotes, 250.55, semicolon. Number string equals number string plus, double quotes, 49.45, semicolon. We'll output the result with system.out.print number string. So pausing here, we can see we created 3 statements, each ending in a semicolon. When we do finally type in the closing curly brace, these 3 statements will be executed in order. This is similar to typing them on the same line, but when we execute code this way, JShell won't print the value out of each statement. Instead, it just prints whatever we put in system.out.print statements. Before we add the closing brace and execute it, what do you think the result will be? Will the 2 numbers be added together? In other words, if our math is correct and we are adding 150.55 and 49.45, the result should be 300. What do you think? Will we see 300 in the output? So let's find out. We'll run these statements next by using the right curly brace. The right curly brace ends this group of 3 statements and executes them, so let's press enter and see what we get. Now we see that, in fact, we don't get the number 300 at all. Instead, we've got the 250.55, and after that we've got 49.95. Before we talk about why that's the result, let's just do the same thing, execute those 3 statements, but on a single line in JShell. We are typing the same 3 statements as before, but on a single line in JShell, and then we'll press enter. So we got the final system.out.print statement with the same result, but you'll see, as we've seen in all the videos to date, that the variable values were output for the first 2 statements. This is behavior that is specific to JShell. There are 2 ways to execute multiple statements in JShell. Put your statements on a single line, or enclose your statements in a set of curly braces. This shows 2 ways to execute multiple statements in JShell, both ultimately give you the same result. But if you want each statement to output its value, then list them on the same line in JShell. If you want to emulate a Java program, which will only print what you put in the system.out.print statements, then group your statements between beginning and ending braces. Okay, so that's another JShell hint for you, but let's talk about this weird and unexpected result. So what exactly happened here? Well, in fact, technically, the 49.95 was added to 250.55, but it was added as a string. It was concatenated, in other words, in the same way we saw previously with the text strings we looked at. Now, the reason for that is that we're not using a numeric type, such as an int or a long, etc., or even a double for that matter. We're using a text data type, a string in this case, and a string treats the text or digits in the double quotes as text and only text. In general, when you type something inside double quotes, Java by default interprets that to be a string literal. So there's no numerical calculations done. We'll need to convert that to another type or save it in another type in order to be able to perform mathematical calculations to numbers in a string. In fact, let's look at this in a slightly different way. Let's declare a new int, but we will add a little twist to it. Int myInt equals double quotes 10 semicolon. In this case, you can see that while we're declaring an int variable here, we put the value 10 in double quotes. Java interprets that as a string and throws an error similar to some of the errors we've seen in the past regarding data type incompatibility. Later in the course, I'll show you how you can convert what you think is a number from a string to a number data type. But for now, anything you type into a string is a string, and you can see it's treated differently to the numeric data types that we saw previously. Alright, there is another thing I want to show you that might surprise you. Let's declare a couple more variables, one string and one int. String last string equals double quotes 10 semicolon int myInt equals 50 semicolon. So we have two new variables, one a string and the other an int. Now let's try to add those two new variables together. Last string equals last string plus myInt semicolon. Notice that what we are actually adding is a numeric data type of int to a string. What do you think is going to happen when this is executed? What output are we going to see? Or do you think this is going to cause a Java error? Let's execute it and see what we get. You can see there that last string is now equal to 1050. So even though we've used an integer data type now, in the second part of the expression, we've still ended up concatenating the integer to the string value 10. Our string variable, last string, is still configured and set up as a string. In Java, the plus symbol is an operator which can mean addition if used for numbers. But it also means concatenation when applied to the string. The string plus anything else gives us a string as a result, concatenating anything after the string as text to the initial string. So keeping that in mind and looking again at our code, Java is smart enough here to say, okay, I know that the integer you've defined, myInt, is actually an integer. But I also know that you're trying to add it to a string, and of course last string was in fact declared as a string. What Java does in this case is it actually looks at the contents of myInt and converts the value, 50 in this case, to a string. And then this is concatenated to the string value 10. And that's why we're seeing 1050 as the value of our last string. So myInt isn't treated as a number in the true sense, rather it's treated purely as text by the computer here because it knows it's being added to the string last string. So the myInt variable itself is still an integer variable with an integer value, but because it's being added to a string, the value is treated as a string. And we can continue on with this example. Let's do something similar with a double. Double number equals 120.47 semicolon last string equals last string plus double number semicolon. You can see here last string is now equal to 1050 but also with the 120.47, which was the decimal version from our double data type. So the behavior was exactly the same as when we used an integer. Java's treated the double value as text and appended that as text to our string variable. What we're doing here is only a very elementary way of dealing with strings and adding to strings. In later lessons, we're going to look at more advanced features of a string because we can do all sorts of things with string. Using strings and manipulating strings will be something you do in every program you write, so the string class and its features are important to know. A string is different from many other classes because the sequence of characters in the string are immutable. What does this mean? Immutable means that you can't change a string after it's created. So in the case of the code we've written, the value 120.47 is technically not appended to the current contents of last string. Instead, a new string is created automatically by Java. The new string consists of the previous value of last string plus a textual representation of the double value 120.47. The net result is that our variable last string has the concatenated value. However, Java created a new string in the process and the old one will get discarded from memory automatically. Now don't worry if that makes no sense at this time. It will later in the course. For now, I just wanted to point out that strings are immutable, and that will make more sense and become more important as we progress. Because of this, the code that we just wrote there was quite inefficient. Because a new string gets created for every operation, appending values like this is inefficient and generally not recommended. Java provides another class that is more efficient if you are doing a lot of appending of multiple strings or values. The string class is immutable, but can be used much like a primitive data type. The string builder class is mutable, but does not share the string's special features, such as being able to assign it a string literal or use the plus operator on it. Both are classes, but the string class is in a special category in the Java language. Java provides a class in its library to address the inefficiency of the immutable string when you are creating a large amount of text from many smaller parts. This class is called the string builder class. Unlike a string, the sequence of characters in a string builder class can be changed. We'll be revisiting the string and the string builder classes in much greater detail after we develop a better understanding of how classes work in Java. But I've also shown you the string concatenation operator today because you'll come across code written in the style we've used in this lecture. Using operators like plus to concatenate string values is code you'll probably see. It's useful for you to know how to do things this way, but it's also important to understand there's a better way to do it, so stay tuned for more on strings and string builders in future videos. The string is so intrinsic to the Java language it can be used like a ninth primitive type. But it's not a primitive type at all, it's a class. From your point of view, you can treat the string like a ninth primitive type by directly assigning a string literal to it and using the plus operators with it. The Java language set the string to be used in a simpler fashion compared to traditional classes, which we haven't covered yet. You'll be using a lot of strings as we progress through the course and in general in your working life as a Java programmer. The plus sign and other mathematical symbols like the minus, multiplication, and division signs are examples of operators which we've only briefly mentioned so far. We're now going to look at operators in more detail, so let's move on to that next video now. In the previous video, we did a recap of the primitive data types as well as getting a formal introduction into string. In this video, we're going to take a look at operators, operands, and expressions. We've discussed very briefly what operators are, and we've used a few of them in some expressions. Let's go deeper into that now. So what are operators? Operators in Java are special symbols that perform specific operations on one, two, or three operands and then return a result. In the example below, which we saw in a previous video, we used the plus or addition operator as well as the multiplication operator. But there are many other operators in Java. So what is an operand? An operand is a term used to describe any object that is manipulated by an operator. So if we consider this statement, int myvar equals 15 plus 12 semicolon. The plus here is the operator and 15 and 12 are the operands. Variables used instead of literals can also be operands. Another example from our challenge. In the line above, byte value, short value and int value are operands, as are the numeric literals. What's an expression? An expression is formed by combining variables, literals, method return values, which we haven't covered yet, and operators. They are a way of forming and combining those values to produce a result. In the line below, 15 plus 12 is the expression, which returns the value of 27. In the statement below, byte value and short value and int value is the expression. Alright, let's officially explore operators using some code in JShell and start by typing. Int result equals 1 plus 2, and now I'll add 2 forward slashes to include a comment and type what is the expected result, 1 plus 2 equals 3. You've actually seen this operator in use before. We've already done some basic arithmetic using the plus or additive operator. In fact, we've used several operators already. But now I want to clarify and go through the major operators so that you can become familiar with them and know how to use them. And you'll find that some operators tend to be used a lot more frequently than others. So what we've done on this line is we've added a comment at the end of the line with 2 forward slashes to type out what the expression should evaluate to before we print it out. More on comments in a moment. How many operators would you say are in this statement? Well, we've actually got 2, the equal operator and the plus operator. The equal operator is also called the assignment operator, and it's used to assign a value. In this case, it's assigning what's on the right-hand side of the equals operator to the variable we've called result on the left. The value being assigned will be 3 in this case, which is the sum of 1 plus 2. The plus or addition operator is a 2 operand operator. It adds the operand to the left of the plus sign to the operand on the right. So the expression is using 2 operands here. Most of the operators you are probably familiar with are used on 2 operands. An operand itself can be an expression and can contain multiple expressions and operands. In the next video, we'll cover single operand operators, which simply perform a function on the one operand itself. But first, since this is the first time I've used a comment in code, let's pause a moment to talk about comments. Comments are ignored by the computer and are added to a program to help describe something. Comments are there for humans to read. We use 2 forward slashes in front of any code or on a blank line. Anything after the 2 forward slashes right through to the end of the line is ignored by the computer. So aside from describing something about a program, comments can also be used to temporarily disable code. Let's introduce another variable next. Int previous result equals result semicolon. Let's go ahead and change the value of result. Result equals result minus 1 semicolon. Then we'll next include a comment there. And the comment is going to be the expected outcome of the operation. Because result is 3, we're taking away 1, and the answer should be 2. And then we have it, result is now equal to 2. Before we move on, some of you may be wondering about the value that is now in the previous result variable after the last statement. To summarize, we assign result to previous result, and then we change the value of result. But did this also change the value in previous result? This is a good question, and we'll look at that now. So let's swing back and see if the values in the previous result and result variables are independent of each other. So let's see what value previous result has. We'll just print the value of previous result using system.out.print here. And even though we previously assigned result to the previous result variable, it did not get updated when result got a new value of 2. The value in previous result remained unchanged. When we assigned result to previous result, the value of result at that time was 3, and 3 was assigned to previous result. Any further changes to the value of result don't affect previous result as we've just demonstrated. Before we move away from the plus sign operator, let's compare what happens if you use it on character data types. We've seen before that the char holds a single character and the string can hold multiple characters. We've also discussed in the previous video that a string plus anything else gives us a string. But what about chars? Let's create 2 char variables and print them out using the plus operator as we'll show here. Char first char equals single quotes a semicolon char second char equals single quotes b semicolon. So we create first char to hold a capital A, second char holds a capital B, so now let's print them out similarly to what we did for 2 strings. System.out.print opening parentheses first char plus second char closing parentheses semicolon. And can you guess what the result will be? Is it going to be A? Concatenated with B? Let's hit enter and see. So the result definitely does not look like A concatenated with B. Where did 131 come from? You might remember that we said chars are stored as 2-byte numbers in memory. When you use the plus operator with chars, it is these numbers in memory that get added together. The character values don't get concatenated. The decimal values for A and B are 65 and 66 respectively. If you don't know how I got these numbers, revisit the video on chars and using the Unicode table to get both the Unicode and decimal values. So adding 65 and 66 will give us 131. This question has come up occasionally in our Q&A, and I wanted to explain why this happens. If you really want to print A concatenated with B, you can concatenate these variables to a string. We'll do that next. System.out.print opening parentheses double quotes plus first char plus second char closing parentheses semicolon. So in this code, I'm starting with 2 double quotes. This is called an empty string and is a valid string literal. We next use plus on that string, Any plus after a string is going to be a concatenation operator, as we've stated several times, so let's hit enter. And now the character A was transformed into a string and concatenated to an empty string, and the same occurred with the character B. It's probably unlikely you'd be outputting data a single character at a time using the char, but it is important to understand that the char and the string do not treat the plus sign the same. Alright, so let's try another operator we've seen before, and that's probably very familiar to you, the multiplication operator. Let's set the value of result to 2 first, just so that we are all on the same page before we go on. Result equals 2, semicolon. And now, using multiplication. Result equals result times 10, semicolon. And we'll add a comment to describe what we expect the equation result to be. Add a comment using 2 forward slashes, and the expected result, 2 times 10 equals 20. So one of the operands, in this case, is result which has the value of 2, and we're multiplying 2 by 10, so the new value for result should be 20. Let's press enter to see if that's correct. And no surprises there, I hope. We get a value of 20 when we use result which has a value of 2, the first operand, and we multiply it by 10, the second operand. And next, let's do a bit of division, remembering now that result has the value of 20 from the previous statement. Result equals result divided 1/2 by 4, and also we add the comment of what the expected result is, 20 divided by 4 equals 5. And again, no surprises there, the result equals 5. So moving on, we'll now look at the remainder operator, which may not be as familiar to you as the last few we've reviewed. The remainder operator is represented in Java by the modulo sign. The remainder operator goes by several other names, modulus, modulo, or just plain mod for short. The remainder operator returns the remaining value from a division operation. If there is no remaining value, the result is 0. This table shows some examples. In the first example, 10 can be divided evenly by 5, so there is no remainder. In the second example, 10 can be divided evenly by 2, so there is no remainder. In the third example, 10 can't be divided evenly by 3, but we get 3 from the division, which gives us 9 with 1 remaining. Finally, using 1 as the right operand always gives us 0, so it's unlikely to add value to our code. You might ask, when would you ever use the remainder operator? This is a pretty useful operator actually, though it is a bit less common than the others. We'll talk about how to use it to get a set of even numbers or get all numbers divisible by 5, for example, when we get to looping. So to see that working, we're going to type the following code. Again, just in case you've been exploring as you should in JShell and maybe lost track of the value of result, we'll set it to 5 before proceeding. Result equals 5, semicolon. And now we'll try out the remainder operator. Result equals result modulo 3, and a comment that we expect 5 modulo 3 to result in 2. So the way the modulus operator works is that you ask yourself how many times does the right operand fit into the left operand, and then what is left over, this is the result. In this case, 3 fits into 5 only once, and what is left over is 2. And if we press enter, result equals 2, so that is how the remainder operator works. Let's review what we've learned in this video. This table shows the 5 operators we just reviewed. For all of the numeric types, whole numbers and decimals, the operators are mathematical operators as shown. Only one operator, the plus operator, is supported by string, but it means concatenation, not addition. None of the operators are applicable to a Boolean. Because the char is stored as a whole number literal, all the operations are applicable to a char. Alright, so that covers the most common operators, all of which have 2 operands. In the next video, we'll continue on with operators, but we'll start looking at some shortcuts you can use when using operators. See you in the next video. In the previous video, we talked about operators, operands, and expressions. In this video, we'll continue our discussion with operators, and we'll see how they can be abbreviated to simplify the code. Very shortly, we'll be transitioning to coding in the IntelliJ IDE, so in the next video or 2, I want to continue to prepare you for that environment by using the curly brace feature in JShell. So why use multiple statements in curly braces? First, it's a way to group statements together before executing them. It allows us to put statements on multiple lines, which is more natural and readable. We can execute the group of statements as a whole, which more closely resembles running code in Java. Although putting multiple statements on a single line is allowed in Java, it's not considered best practice for readability of code. I also want you to get used to writing system.out.print statements to view the output. The echo feature, which is part of the read evaluate print loop of JShell, is not a feature that exists outside of JShell itself. Another important restriction when putting coding statements in the curly braces is that we're required to include the semicolon. This will help you get back into the habit of ending every statement with a semicolon in case you've gotten a little sloppy in JShell and been ignoring them. So let's do that. We'll start with a couple of simple statements. We start a group of statements with a left curly brace and hit enter. We declare result to be an int and set it to 1. Here, we'll increment result by 1 by using the plus operator, so result equals result plus 1. We print result out. Finally, we execute the statements above by adding the closing right curly brace and hit enter. Okay, so once again, there shouldn't be any surprises. We'll press the up arrow key in JShell and we'll see all the statements that we typed in the group. Note that doing this lets us edit any line in this group, but first, let's talk about these statements. The variable result started out with a value of 1. We used an expression on the next line, adding 1 to the value in result and reassigning this new value to result. This is a very common way to increment a variable. Now, let's use one of the abbreviating operators, which are sometimes called shorthand operators. Incrementing by 1 is a very common requirement in programming. Obviously, we can do the following. Result equals result plus 1. But we also have 2 other shorthand ways to do the same thing. The postfix increment operator is represented by plus plus after the variable name. This is a standalone statement and does not require an assignment. The compound assignment operator is represented by plus equals 1 after the variable name. This is also a standalone statement and includes the assignment. So now, while we are in edit mode, we can use the arrow keys to move to the line that contains result equals result plus 1 and change it to result plus plus as we'll do next. Result plus plus, semicolon. So we get the same result, result equals 2. Using this abbreviating operator, known in Java as the postfix increment operator, gives us the same thing as result equals result plus 1. There is another abbreviating operator for decrementing a variable by 1. This one is called the postfix decrement operator and looks the same as the increment operator, except it uses minus signs and not plus signs. Decrementing by 1 is also very common. We can decrement simply by using the equation. Result equals result minus 1. But we also have 2 other shorthand ways to do the same thing. The postfix decrement operator is represented by minus minus after the variable name. This is a standalone statement and does not require an assignment. The compound assignment operator is represented by minus equals 1 after the variable name. This is also a standalone statement and includes the assignment. So let's use the postfix decrement operator. To use it, we will again use the up arrow key to retrieve our last set of statements, and we'll change the plus plus symbols after result to minus minus on the second statement and hit enter. Minus minus, semicolon. Since we are now decrementing, it should come as no surprise the result is 0. So we've tried out the postfix increment and decrement operators, which allowed us to change a variable either by adding or subtracting by 1. You'll have noticed from the slides that another way was presented, and this was called a compound assignment operator. Again, in JShell, we want to press the up arrow so we can continue to edit the statements we've been using. In this instance, we want to replace result minus minus with result minus equals 1. Result minus equals 1, semicolon. Okay, this one might look a little weird at first, but it's just a shorthand or abbreviated way of writing result equals result minus 1. You'll find that you'll get used to these shorthand operators and we'll be using them quite often in this course. You can use the compound assignment operator for addition as well. So we'll do that next and go through the same process. We'll press the up arrow key in JShell and then, while we're in the edit mode, we'll replace minus equals with plus equals in the second statement. Plus equals 1, semicolon. And because we're using addition, This statement result plus equals 1 has the same behavior as result equals result plus 1, and the final result equals 2. Unlike the increment and decrement operators, you can use the compound assignment to do more than increment or decrement by just 1, so let's increment by 5 next. In JShell, we'll press the up arrow and once again change the second statement, changing result plus equals 1 to result plus equals 5. Plus equals 5, semicolon. Now, result equals 6 because we added 5 to the result instead of just adding 1 as before, and result was initialized to 1. As you'd assume, we can decrement by any number we want as well. So let's make this a little more interesting and give you a challenge. Using the code we have been using, either by scrolling up and editing the group of statements or creating a new group of statements. Initialize an int variable named result to the value of 10 rather than 1. Next, use the compound assignment operator with the minus sign to subtract a number from result using a value of your choice. Print the result out using the system.out.print statement. Pause the video now and give that a try on your own. When you're done, start the video again and I'll see you when you get back. Alright, welcome back again. Were you able to successfully subtract a number from result? And if you did you use the compound assignment operator with the minus sign? Let's just walk through that together. So in JShell, we are going to hit the up arrow, which brings up our group of statements from JShell's history and lets us edit any statement in the group. The first thing we'll do is change result equals 1 to result equals 10 in our first statement. Result equals 10, semicolon. Next, in the second statement, we'll subtract 7 from the result using the compound operator. Remember, this is just shorthand for setting the value of result to result minus 7. Minus equals 7, semicolon. This should give us the result equals 3. So that's how you would use the minus compound operator, subtracting an integer value from result. But maybe you were a little more adventurous in your own code. Maybe you decided to subtract a decimal number from result. Let's do that for a bit of fun next. Again, hit the up arrow and we'll edit the second statement. I'll change the value from 7 to 5.5. 5.5, semicolon. What do you think the final result will be? Will this give us an error or give us the result 4.5? What do you think? Okay, so let's hit enter. So the result equals 4. Was that a surprise? I think it might have been, since it still kind of surprises me. Although I've said that this should be the same as the statement, result equals result minus 5.5. Actually, it isn't 100% true when you are using incompatible data types. When result is an int, the compound operator assignment, result minus equals 5.5, give us a different result from what we expected, which was result equals result minus 5.5. In fact, the compound operator hides a potential error, the lossy conversion error we've seen several times. Let's examine what I've just said in code in JShell so you have a better understanding. Let's hit the up arrow to get into edit mode for this group of statements, then we'll change that second line to what is generally assumed to be its replacement, result equals result minus 5.5. Result equals result minus 5.5, semicolon. Executing this code gives us the error, possible lossy conversion from double to int. Maybe this is what you thought the compound minus operator would have given us, but didn't. Let's hit the up arrow again and now manually cast to an int as we've done before using int in parentheses. But I'm also going to need to put the equation in a set of parentheses, which I'll do here. Here I have to cast to an int, but I need to cast the entire result of the equation, so I enclose it in parentheses as well. What would have happened if I didn't put parentheses around the equation? Well, think about that for a minute. Java would have assumed we were only casting the variable result to an int, and we still would have gotten the same possible lossy conversion error. So now let's press enter. And here our result is 4 again, as it was when we first used the compound minus operator. The compound assignment operator, x minus equals y, is often said to be x equals x minus y. But that's not entirely true if y is not the same data type as x. X minus equals y is really x equals data type of x, x minus y. An implicit cast is done when using this operator, so no error occurs, but unexpected results may occur. So summarizing for our own sample of code, result minus equals 5.5 is really result equals int result minus 5.5. That might be a lot to take in right now, but what I really wanted to do with this example is encourage you to experiment. Never take a simple code segment for granted. Even something as simple as this challenge can be explored, changed, and retested, and can enhance your understanding of the Java language. So, how do we actually get the result to be 4.5 using the compound minus operator if that's what we really wanted? Let's make another change. Again, we arrow up, and this time change the data type for the variable result from an int to a double in the first statement. I'll set this back to the compound minus operator. And now our result equals 4.5. Since our variable is now the same data type as the value being subtracted using the compound assignment operator, we don't require any implicit casting, and the result is what you'd expect. Okay, so that was your challenge. I hope you found that interesting and a bit surprising. So finally, we have two more compound assignment operators to get through for multiplication and division, so let's do that real quick for the sake of completeness. In JShell, we use the up arrow and change the second statement from result minus equals 5.5 to result star equals 1.5. We also want to make sure that the variable result has a double data type. Since we changed that previously, we should not have to change it, but just check that that is so. Result star equals 1.5 semicolon. And now the result equals 15.0, which is 10 times 1.5. And finally, for division, going through the same process, we use the up arrow and change the second statement from star equals 1.5. Let's change that to divided equals 1.5. Divide equals 1.5 semicolon. Remember, this operator generally means the same thing as result equals result divided by 1.5 when data types are compatible. Now our result equals 6.66666 and so on. This looks like another case of a repeating decimal, and we can see that using a double gives us a great deal of precision in the result. Alright, so let's finish the video here. In this video, we've covered several different types of abbreviating or shorthand operators. The abbreviating operators we've discussed so far are the postfix increment operator, the postfix decrement operator, the addition compound assignment operator, the subtraction compound assignment operator, the multiplication compound assignment operator, and finally the division compound assignment operator. There are others, but these are generally the most commonly used. We'll be revisiting the increment and decrement operators again in more detail, since these are used quite often to facilitate looping. We'll explore them more, as well as a few additional shorthand operators as we get more experienced as the course progresses. In this video, we were able to revisit previously discussed topics as well, such as casting, floating point precision, and data type conversion errors. In the next video, we're going to continue exploring more operators, but to do that, we need to first talk about the if-then statement. We'll also be moving to IntelliJ as promised and start using the benefits of a fully integrated development environment. So I'll see you in the next video. Welcome to section 4. In this section, we're going to make the switch from JShell to an integrated development environment. An IDE is the easiest, least error-prone way to develop, manage and deploy Java classes. It provides many benefits to developers, including increased productivity, code completion, refactoring of code, debugging tools, version control, and team development, just to name a few. And don't worry if you don't understand some of these terms, they will make sense as we progress through the course. I like to think that the jump from JShell to an IDE is like the jump from a typewriter to a word processing program on a modern computer. It's unlikely that you will want to go back once you have experienced the benefits. IntelliJ IDEA is one of several IDEs available for Java. It's also written in Java, developed by JetBrains, and simply known as IntelliJ. JetBrains offers a free and open source community edition. If you are new to programming, I highly recommend you use IntelliJ for this course so that you can follow along with me. This will eliminate the IDE as a possibility for unexpected problems and confusion. But if you already have an IDE that you are comfortable with, then by all means, go ahead and use it. Also, it's important to understand, for those of you who have never used an IDE, that many of the skills you will learn in this course in IntelliJ will be applicable to other IDEs. Most IDEs are very similar in terms of configuration, display of information, and execution of code. If you learn how to use one IDE, you will be able to get up to speed in another IDE fast. You now need to install IntelliJ to continue with the course. Thankfully, this is an easy thing to do. I've taken the liberty of recording a separate IntelliJ installation video for Windows, Mac, and Linux. All you need to do is watch the relevant video for the operating system you are running on your computer. All 3 videos are in this section of the course. Once you have installed IntelliJ, it needs some configuration. I've recorded a configuration of IntelliJ video which covers all 3 operating systems. Watch that video after you have installed IntelliJ, and then you will be ready to get started programming in the IntelliJ IDE. See you in the next video. For this course, we're going to use an IDE called IntelliJ IDEA. An IDE, or Integrated Development Environment, is the tool that we use to write programs. The main feature is a text editor that we type our code into. But an IDE also compiles and runs our programs for us. And as you'll see, it also warns us about errors in our code before we run it. The IDE we're going to use is called IntelliJ IDEA, created by a company called JetBrains. There are other IDEs available, and you can use any that you want for this course. If you've already got an IDE that you like and you're comfortable using, then it's fine to continue using it. Most modern IDEs provide the same or very similar features. If you haven't used an IDE before, I suggest you use IntelliJ IDEA. That way your environment will work the same way as you'll see in the videos. A reminder that this video is for Windows. Check out the other videos in this section if you are on a Mac or running Linux. It's time to download and install IntelliJ IDEA, which we need to write Java programs. Let's visit jetbrains.com in a browser. Hover over Developer Tools at the top and click IntelliJ IDEA. Click Download. Make sure Windows is selected here and choose the Community Edition of IntelliJ IDEA to download. The Ultimate Edition is a paid version of IntelliJ IDEA, which is not needed for this course. Alright, I've started the download, and I'll come back once it's done so we can install it. The download is now complete, so let's install it by opening it up here, and then we will get a wizard pop-up. I'll click Yes here to allow the installation to proceed. I'm going to click Next. And Next again. It's optional, but I'm going to choose the option to create a desktop shortcut and click Next. I won't change the screen, click Install. And now it will finish off the install. And we are done. Move on now to the IntelliJ configuration video in this section after the other operating system install videos, as there's some important things we need to configure to get everything working. I'll see you in that video.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
For this course, we're going to use an IDE called IntelliJ IDEA. An IDE, or Integrated Development Environment, is the tool that we use to write programs. The main feature is a text editor that we type our code into. But an IDE also compiles and runs our programs for us. And as you'll see, it also warns us about errors in our code before we run it. The IDE we're going to use is called IntelliJ IDEA, created by a company called JetBrains. There are other IDEs available, and you can use any that you want for this course. If you've already got an IDE that you like and you're comfortable using, then it's fine to continue using it. Most modern IDEs provide the same or very similar features. If you haven't used an IDE before, I suggest you use IntelliJ IDEA. That way your environment will work the same way as you'll see in the videos. A reminder that this video is for the Mac. Check out the other videos in this section if you are on Windows or running Linux. It's time to download and install IntelliJ IDEA, which we need to write Java programs. Let's visit jetbrains.com in a browser. Hover over Developer Tools at the top and click IntelliJ IDEA. Click Download. Make sure macOS is selected here and choose the Community Edition of IntelliJ IDEA to download. The Ultimate Edition is a paid version of IntelliJ IDEA, which is not needed for this course. As with the JDK, there are two options here, one for Macs with an Intel CPU, the other for Apple Silicon. As you can see, Intel is the default. Click Download without changing anything if you have an Intel CPU in your Mac. In my case, my computer is an M1 MacBook Pro Max, so I'm going to click the drop-down box and select Apple Silicon. If you get this pop-up, which usually only occurs if you are running Safari, click Allow. The download starts. I'll come back when the download is complete to finish off the installation. As you can see, the download is complete. I'll click the DMG file to start the installation. All I need to do is drag the IntelliJ icon to Applications like this. Give it a few seconds to copy over and we are done. I'll close all these windows down and eject the IntelliJ installer by right-clicking and selecting Eject, and we are done. Let's move on now to the Configure of IntelliJ video in this section of the course. For this course, we're going to use an IDE called IntelliJ IDEA. An IDE, or Integrated Development Environment, is the tool that we use to write programs. The main feature is a text editor that we type our code into. But an IDE also compiles and runs our programs for us. And as you'll see, it also warns us about errors in our code before we run it. The IDE we're going to use is called IntelliJ IDEA, created by a company called JetBrains. There are other IDEs available, and you can use any that you want for this course. If you've already got an IDE that you like and you're comfortable using, then it's fine to continue using it. Most modern IDEs provide the same or very similar features. If you haven't used an IDE before, I suggest you use IntelliJ IDEA. That way your environment will work the same way as you'll see in the videos. Installing IntelliJ on Ubuntu 22.04 is fairly painless. Let's get started. Click Activity and then move over to the search box again and type Terminal and press Enter. Type the following in the terminal window: sudo space snap space install space IntelliJ IDEA community space classic and press Enter. You may or may not be prompted to enter a password here. If you are prompted, enter your password to continue. This will download and then install the latest version of IntelliJ. It will take a while, so I'll fast forward this bit and be back shortly. Okay, we are done. The only other thing you need to know how to do is to start IntelliJ. Type IntelliJ IDEA community and press Enter. Give it a few moments to start. And there you have it, we are running IntelliJ. Now that we have the JDK and IntelliJ running, we need to configure IntelliJ. Watch the following video, which will show you how to configure IntelliJ and link it to the JDK we installed in the previous video. See you in the next video. In this video, we want to configure IntelliJ IDEA so that we can actually start some Java coding. This video is applicable whether you're running on Windows, Mac or Linux. So firstly, we need to link the JDK we installed, Oracle's JDK 17, with IntelliJ IDEA so that they work together. Basically, that means telling IntelliJ where the JDK is installed on the computer. The JDK is effectively a software development kit or SDK. Whatever you call it, it contains the tools you need to write programs. The Java development kit includes the tools that enables the computer to understand your Java code and to execute it. It also has a debugger, and we'll be seeing what that is and how to use it when we've written a program to debug. Start up IntelliJ IDEA if you have not done so already. Firstly, there is the user agreement that you will have to confirm you agree with by clicking the checkbox and then clicking continue. It's recommended you actually read this first though. Next is this option for data sharing. I recommend clicking Don't Send, so we'll do just that. IntelliJ is now loaded up and gives us these three options: New Project, Open, and Get from VCS. We'll ignore the other options on the left for now, and also ignore the tour at the bottom. New Project is used to create a new project, which is the one we'll use shortly. Open will let you open a project that you created earlier so that you can continue working with it. If you use a version control system such as Git, then the Get from VCS button will fetch a project from your version control system, hence VCS. But don't worry if you don't know what a VCS is. You won't use one until you've been programming for a while. Let's start off by clicking on the New Project button. Notice that IntelliJ came up with a Detecting JDK pop-up. It's looking for the JDK we installed a few videos back. Most of the time it should find the installation, and you can see in my case it has found it. If you look, you can see the numbers correspond to the JDK we downloaded previously. 17.0.4 in my case, the last number is not shown. If you didn't install the JDK, you should go back to the JDK install video and do that and come back here. In the rare case of IntelliJ not finding a JDK installation, you can still proceed by clicking the Dropbox box and selecting a JDK and navigating to the folder where Java was installed. I'll show you how you would do that if you're on Windows. Program Files, Java, and then the JDK version, in my case JDK 17.0.4.1. You would click that folder and click OK, and IntelliJ would then use that version for your Java programs. I won't do that because, as we saw earlier in the video, my JDK was found. So I'll click Cancel to go back. If you're on a Mac and didn't find the JDK, click Add JDK, and this is the folder where the JDK is installed. And finally, if you're on Ubuntu Linux, this is the location where the JDK is installed, as you can see on screen. OK, back to the main screen of IntelliJ. The only other thing you would do is ensure Java and IntelliJ are selected, which they are, and that my JDK is showing, which it is. Anytime you want to create a project in IntelliJ, this is the screen to do it on, and you will be doing this a lot moving forward. For now though, I will click Cancel to go back to the main IntelliJ screen, and this time I want to click Customize to change a few settings. Now click All Settings. Here we can change the theme. Dark is a nice background for programming, as it's gentle on the eyes and many people recommend it. I'm actually going to select this drop down and choose IntelliJ Light because a white background is better for videos. Choose whichever one appeals to you, and keep in mind you can come back here and change the setting at any time. Now come down and click on Editor and click on General. I'm expanding the options, as you can see there. What I'm doing is selecting a few options to make life easier for people new to programming and or to Java. I'm going to select Auto Import. I highly recommend that you check both, add unambiguous imports on the fly, and also optimize imports on the fly. Next, we're going to go down to code folding. I'm going to uncheck a few things here, and the reason we're unchecking some things here is IntelliJ IDEA is a professional editor meant to shortcut and make things easier for both beginners, but also for experienced developers. With some of these default options, it effectively hides some of the source code, and when you're first learning Java, you want to see all the code you are writing. I'm going to come down here. I'm going to deselect File Header and Imports. I'm going to deselect one-line methods. We're going to deselect closures, this one here, and also generic constructor and method parameters. So, in other words, I'm telling IntelliJ to show as much code as possible for those things, and you can always come back here later in the course if you need to and change that back, but it's probably something that's pretty useful for you to leave on. Alright, one other thing we need to do now is go up to Appearance here. We need to make sure that Show Line Numbers is checked. In earlier versions of IntelliJ, sometimes that wasn't checked, but you can see that it is checked by default, but if it's not checked for you, make sure you check it. We are done with the configuration and can now click OK. To get back to projects, where you normally want to be, click Projects here. The main part of this pane will show you a list of all the projects you've created, which will make it much easier to open them again. Right now, of course, there are none to show. But don't get too hung up on the position of these three buttons. That's the new project, open, and get from VCS. JetBrains moves things around from time to time, so it's possible they will be in a different place in future versions. Ultimately, that doesn't matter. When you see me click the new project button, you'll know where to find it on your screen. As I say, it might be in a different place when you are watching this. Alright, so we're all set up now and ready to program. We'll make a start on that in the next video. So, up until now, we've used the interactive shell included with Java, JShell, to write all of our Java code. Now we'll start using IntelliJ, the integrated development environment you just installed in the previous videos, to take another look at our first program, Hello World. If you haven't installed IntelliJ IDEA yet, please go back to the video for your operating system and do that now, and come back and continue on with this lecture. Alright, so we've got IntelliJ IDEA loaded, as you can see here. I'm going to come up here and click on New Project. I'm using the Community Edition, the free edition of IntelliJ. If you're running the Ultimate Edition, you'll find there's some extra options down the left-hand side. Next, we need to tell IntelliJ something about the project we want to create, including the name of the project, its location, the language our project is using. We will always select Java here, the JDK we want to use, which should default to the JDK we configured previously. So name is the name of our new project, which I'll change to Hello World. Now, note that I can use spaces in the name, but it's generally not a good idea to use spaces in a name as a file name or as a project name, because this name will ultimately be part of the folder or the project location, and spaces in these names are treated differently by different operating systems. So, I'm going to suggest you always just capitalize the first letter of full words in project names, as I do here with a hello and a world, if you want to separate them. This is called camel case and visually allows separation of words instead of using spaces, just like we've been doing with variable names in previous videos. This is the practice of capitalizing the first letter of every word in a name for readability, removing spaces or characters such as underscores between the words. Upper camel case capitalizes the first letter of the name, lower camel case does not. Examples are shown in this table. Note that project name is not a Java element, it's part of the IDE's configuration. More on this in a future video. Unlike variable names, spaces are actually allowed in project names, but if you want to save yourself some trouble and your application may be deployed on different types of operating systems, it's best to avoid spaces in the project name. Also, I recommend that project name should start with an uppercase letter when camel case is used. I point this out because you may remember that we've usually used a lowercase letter when using camel case in variable names. The next thing we need to specify is a project location. In the previous video, we configured IntelliJ to use a default location. I used the folder name JMC17, and you may have used a different folder name. This will be the parent folder of all your IntelliJ projects. You don't need to change this now unless you have some reason for putting one of your projects in some other folder. In the language section, make sure that Java is checked, and then you'll come over here to the JDK, and also make sure that Project SDK has got the current version 17, Oracle OpenJDK version 17. Now, as of the time I'm recording this video, it's 17.0.5. So if you haven't got anything there, or you've got a different version that doesn't start with 17, go back to the installation of the Java Development Kit videos and make sure you download JDK 17. There's also a video in there which explains the reasoning for using JDK 17 in case you're wondering, because, of course, there is a newer version already available. Make sure that that sample code is unchecked, and now we'll press the Create button. So next, we get this little project pane on the left-hand side open. This project location, which we're going to be talking more about later, is essentially an area that has automatically been set up by IntelliJ for our program code, and it's organizing things in a certain way. So we can come over here and click on this little arrow symbol there, which will open up or close the folder. So we've got this .idea folder below it, which has IntelliJ IDEA's working files and this IML file. We don't need to worry about any of these just now. It's time to create our first Java class. To do this, right-click on the SRC folder and select New, and then move up here to click Java class and type in first class. Be sure to type it exactly as you see it, with a capital F for first and capital C for class with no spaces and the rest lowercase. Then press enter. IntelliJ generates some code for this using the name first class. You can see that IntelliJ created some code for us, and that code is showing up in the right pane in the user interface. This is the editor window. Also notice that under the SRC folder in the left pane we can see an item, first class, with a little c in blue, which is IntelliJ's way of denoting that it's a class. I'll double click this tab here to make it full screen so you can see the code better, as we are done with the project pane for now. The next thing I'm going to do some code to print something out. I'll move my cursor to the end of this line and press enter. IntelliJ indents for us. I'm going to use an IntelliJ shortcut to save some typing. I'll type PSVM and then press the tab key. IntelliJ types all that code for us and positions the cursor ready to type our output statement. I'll type system.out.println hello world. Note that in IntelliJ, the ln is required, as is the semicolon at the end of the line. Be sure to type it exactly as I have. So how do we run this code? In JShell, we ran the code by typing a command, but we also ran it from the command line or terminal outside of JShell using the Java executable. As you might expect from an integrated development environment, which is designed to make life easier for programmers, IntelliJ provides ways for you to run this code, and we can run it a few ways in IntelliJ. At the moment, we have a few ways to run the code. We can click this green arrow up here on the right. Alternatively, we can click one of these green arrows to the left. The other alternative is to right-click and select Run First Class.main. I'm going to choose that option, but all of them should work for you. Be sure when right-clicking to right-click in the second set of curly braces near the system.out.println line. Otherwise, you may not see an option to run. You can see down the bottom right, something's happening. Let's give IntelliJ a moment. And now this run pane has shown up and we can see some output. This is the run pane. So what's actually happened is that IntelliJ, via the Java Developer Kit, has compiled a Java program which needs to be done before running Java code and then displayed the result. The first line there is the command that IntelliJ sent to Java to execute our program. Next we can see the output from the program, hello world, which came from our println statement, and then it's followed by this process finish with exit code 0, and what that means is everything's completed successfully. 0 is often used to indicate that there wasn't a problem. So there you have it. We've successfully executed our hello world Java file in IntelliJ. I'm going to stop the video here, and in the next video, we'll talk about the source code we see in the editor window. I'll see you in the next video. In the last video, we ran our first Java code in IntelliJ. In this video, we'll look at the source code from this class as it's displayed in IntelliJ more closely now. A couple of things you'll notice right away is that there are multiple fonts and colors used to display the code, and it's nicely formatted, meaning everything is indented. We may or may not have created the text in the file that way, but even if we didn't, IntelliJ will format it for us here. Looking at the code, we can see on the screen there, public and class. Those are two Java keywords, and note that IntelliJ highlights those or bolds them. Each of these keywords has a specific meaning, which we'll talk a little about now. The public Java keyword is what's called an access modifier. An access modifier allows us to define which parts of our code, or even someone else's code, can access a particular element. But we'll be going into details for that later. For now, we're going to be using the public access modifier anytime we create a new class in Java to give full access. And again, we'll come back to access modifiers at the appropriate stage in the course once we've filled in some of the blanks with your Java knowledge. Alright, next we need to look at the keyword class, and what we've done here is we've defined a class. The class keyword is used to define a class, and the class name will be the text following the keyword, so first class in this case. Also notice the left and right curly braces, they're used to define the class code block or class body. So to define a class, it requires an optional access modifier at the start, and in this case, we've used public followed by the keyword class, then the class name, first class, and finally followed by the left and right curly braces, and the left and right curly braces are defining the class body. Now, anything inside that body between the left curly brace and the right curly brace is considered part of this class. Within a class, we can have data and code as you'll see as we progress through the course. Alright, that's our first project and our first class defined. We also see that we have a main method to this class to print out our Hello World message. But first, what is a method? A method is a collection of statements, one or more, that perform an operation. We'll be using a special method called the main method that Java looks for when running a program. It's the entry point for any Java code, and Java looks for the main method to start and run the program when we use it. You can also create your own methods, as you'll see later. Right, so let's talk about this method and all the keywords we see here before the method name, which is main. Firstly, looking at this statement, public was the access modifier we discussed when defining the class, and it's the same principle here for a method, and this means that other code can access this method. Static is a Java keyword that needs an understanding of other object-oriented concepts to really be explained adequately, so for now, just know that we need to have static for Java to find this special method to run the code that we're going to be adding. Next, void is yet another Java keyword used to indicate that the method won't return any information, but again, we'll be talking more about that later. And just a tip here, you might be perhaps thinking, well, why can't I learn all these things now? But there is a specific order to learning Java, and it pays to learn things in the right order so that things don't get too overwhelming. Rest assured that we'll be going into all these things in a lot of detail at the relevant point in the course. Moving on, we've got the left and right parentheses that I talked about, and that is needed for a method declaration, and that's what we're doing here. By typing in this code, we're defining a method. So the left and right parentheses are mandatory, but you can optionally include one or more parameters, and parameters are a way to pass information to a method. Alright, so here you can see there's been one parameter that's been defined, and we'll talk more about what that means a little bit later. For now though, to enable Java to define the main method, it has to be typed exactly like it's typed here. So if you typed something different, like for example, if you used a capital P, now straight away when we do that, we suddenly get it highlighted in red, and that's IntelliJ telling us that, okay, I don't understand the word public with a capital P. But if we change that back to where it was, which was a lowercase p, it's then quite happy and the error disappears. So keep that in mind, that often you'll find errors can be purely relating to you typing something in uppercase or lowercase when it should have been the opposite. If you have a look at the main method declaration again there on line 2, notice that the left and right curly braces, which we said in the JShell video was a way to group statements together. Another name for this is code block, and in this case, the code block is the method body. Now, the code block is used to define the start and end of a method effectively, and we can put our code in between the block in the form of statements. So at the start, just to recap on that, we've got a class. A class has got the body block of code, which is the left curly brace and the right curly brace of the entire class, and our method is effectively within that class, and it's got its own code block, which is a group of code or statements that are unique to that specific method. Alright, so let's make some edits to the code on line 3, similarly to what we did in the JShell Hello World video, but this will let us see how IntelliJ handles errors. First, let's remove the last double quote. We immediately get an error to the right-hand side with that little indication to say that it's an error. We can see also that IntelliJ has underlined the text Hello World. Obviously, IntelliJ is trying to tell us, even before we run it, that something is wrong with this code. Let's go over to the underlined text and see if we can get more information. Note that when we hover the mouse over this text, a pop-up is displayed which says at the top, illegal line end in string literal. Although this is worded differently than the error JShell gave us, it means the same thing. Text used as a string literal needs to be enclosed by a set of double quotes. And I'll put the quote back again and the error disappears. And now let's revisit the first challenge I gave you. Remember, that challenge was to see whether you could modify the program. Instead of it printing hello world, print hello Tim or hello whatever your first name is. So basically, make the change and then click on the green arrow, the green run icon, to start the program and test it out to see whether it works. So click pause on the video now so you can actually go away and try that. When you're ready to come back and check on the solution, come back and restart the video or replay it from where you left off and we'll go through it together. So pause the video now. Alright, so welcome back. Hopefully you remember how to do this and manage to make that change. Let's remove the text to world and replace it with comma Tim. And then we'll run this. And there it is. There's the output. Hello, Tim. All right, so that's it. Our first program is now complete, done in IntelliJ instead of the JShell terminal, and congratulations if you managed to make that work. And even if you didn't, if you got an error, we'll start talking more about errors in videos coming up. Next, I want to show you again how to create a class in IntelliJ. So first, we want to right-click on that SRC folder in our Hello World project, and you'll see New as the first option. Select that, and now you have quite a few options, the first of which is Java class. So clicking that will give you a pop-up requesting a name and highlighting the class option below it by default. So we'll put in a name. I'm going to call this second class and press enter after that. Now, again, you'll see second class listed under the SRC folder with a little blue C icon beside the name, indicating it's a class. And now you can see in the edit window, we have our class name second class, and other than this first line and the curly braces is pretty much empty. In this instance, I'm going to open the first class.java file in another editor and show you how to copy and paste code from an external Java file. If you recall, the first class Java class appeared under the SRC folder in IntelliJ. The actual files are stored in a folder on your computer and displayed in IntelliJ. We can locate and open that in our OS's File Explorer by selecting first class in the left pane, right-click to bring up a menu of options, and select Open In, and then Explorer, and finally right-click to send that file to Notepad or your default editor. The point of this exercise is to show you how you would copy and paste code from a downloaded file if you only wanted a section of code from a particular class. Now that we have firstclass.java open in our local text editor, we'll just grab the main method, copy it and then come over to IntelliJ's editor window and paste it between the opening and closing curly braces there. So there is another way to use code created outside of IntelliJ and paste some part of it into your IntelliJ class, and running that will give us Hello Tim. But in general, you'll probably be starting with a new class, so let's create another one. We'll right-click on the SRC folder, select New Java Class, and enter the name Hello, this time in the class name field. Remember, before we can run our program, we'll need a main method. So I'm going to add that manually now, and then what I'll do is just add the Hello Tim print statement as the first line in the code block. And then finally, I want to add another statement to the output, so let's do that. Public static void main opening parentheses string opening and closing square brackets args closing parentheses opening curly brace. System.out.print opening parentheses double quotes hello comma Tim closing parentheses semicolon. System.out.print opening parentheses double quotes hello world closing parentheses semicolon closing curly brace. You'll also notice I added a couple of blank lines just to help with the readability of the code. Now, let's run that by clicking the green arrow beside the main method, and after a moment, you can see the outputs printed on the same line. So, that's not exactly what I wanted. I wanted the hello world to print on another line. So far in this course, we've only used system.out.print, but this, as you can see from this example, if you use multiple statements like this, just prints everything on the same line. Let's use another slightly different method on system.out called println. And if we want to run that now, our output looks a lot nicer, as you can see, with a new line being included after hello Tim. The use of system.out.println is much more common than just the system.out.print statement. Okay, so that was just a bit of housekeeping before we continue learning about more features in Java, which we'll get back to in the next video. In that video, we'll be learning about a very important Java language statement called the if statement. So I'll see you in that video. In the last video, we created our first class in Java using the IntelliJ IDE. So now it's time to get back to studying Java. In this video, we're going to take a look at some more operators, but before that, I need to talk about the if-then statement first. The if-then statement is the most basic of all the control flow statements. It tells your program to execute a certain section of code only if a particular test evaluates to true. This is known as conditional logic. Conditional logic uses specific statements in Java to allow us to check a condition and execute certain code based on whether that condition, the expression, is true or false. Let's see how this works in practice. We'll be using the hello class we created in the previous video. If you skipped that video, be sure to review it or pause now to create a class called hello with the main method we've shown you several times. Okay, so now we'll just come over here to line 5 in our hello class and we'll remove the print statement here with the text hello world. Next we want to add some code so that we can start looking at conditional statements. Boolean is alien equals false semicolon. If opening parentheses is alien equals false closing parentheses. System.out.println opening parentheses double quotes it is not an alien closing parentheses semicolon. So notice a few things here. Firstly, the if statement does not have a semicolon. So far in the course, we've been adding a line of code with a semicolon. The semicolon doesn't get added until the following line, which in this case is a print statement. So what's happening here is that the statement is actually spanning 2 lines, which is perfectly valid to do in Java. And we'll talk more about white space, which is the concept of using multiple lines in any number of spaces later on in the course. But check out the operators we've used in these 3 lines of code. You can see that on the first line it's got a single equal sign. And on the second line, it's using 2 equal signs put together. So the first one is an assignment operator, and we've seen that quite a few times. The assignment operator assigns the value of an expression to the variable to the left of the operator. So isAlien is the variable in this case, and it's been set to false, which is the value of our expression. But the second line is a bit more interesting. That's got 2 equal signs, and it does something completely different. The equality operator tests to see if 2 operands are considered equal and returns a Boolean value. So here isAlien is being tested against the value false. In other words, is the left operand equal to the right operand? And since we've assigned false to isAlien on the first line, the expression will return true. Therefore, the next line will be executed. So if we run this, it should print it is not an alien to the screen. And you can see there, it is not an alien. If we hover the cursor over the expression, IntelliJ is telling us there's a way to abbreviate isAlien equals false by using !isAlien. But we'll talk more about that later on in the course. So what we have there is valid, but IntelliJ will always give us helpful tips on how to make our code more efficient. Alright, so the other thing I wanted to show you is what happens if I add a semicolon at the end of the second line after the closing parentheses. Notice when I do that, everything is still valid. The light bulb indicates a potential warning, but there's no errors. And if we run this, we get the same output. At first glance, you would assume nothing's changed and the program is still working as it should. However, if we change false to true, obviously now the expression won't return true anymore. isAlien is still set to false, and the expression is asking, is false equal to true, and the answer is false. So what that means is the line below it should not be executed. And if we run that again, we still get the same output. That's the confusing part about putting a semicolon where it shouldn't be. By putting a semicolon there, we're closing off that line of code, which means the next line is not dependent on it anymore and will execute regardless if the expression is true or false. So the syntax of Java allows us to get away with that. But basically what we've done is create an if-then statement that doesn't do anything. And that's the reason why you don't want to put a semicolon there. So I'll change that back and run it again. We don't get any output, and that's correct because the expression is false and the next line doesn't get executed. So I'll just change that back to false. And we get our output back. The expression evaluates to true and the next line gets executed. Now, I wanted to show you this particular version of the if-then statement without a code block first. One of the disadvantages of using the if-then statement without a code block is that it's not immediately clear what the code is actually doing. Let's take a look at an example. So if we wanted to print 2 lines, we'd add another print statement, first changing our variable isAlien to true. System.out.println, opening parentheses, double quotes, and I'm scared of aliens, closing parentheses, semicolon. So we've changed the value of isAlien from false to true and added a second print statement. And since the expression is going to evaluate to false, we can expect both the print statements to not be printed to the screen. Let's run that. Now that's confusing. The second print statement gets printed out. The reason for that is, without the code block, only the line immediately following the if-then statement can be added. All consequent lines are not considered to be part of the if-then statement. The way we deal with this issue is we add a code block. Instead of using the if statement as we can see here, we should instead use a code block. A code block allows more than one statement to be executed, in other words, a block of code. The format is: add the left and right curly brace, put the statement or statements in between the braces. If the expression is true, the code block will be executed. If the expression is false, all code inside the block will be ignored. We've used code blocks before. You may remember in JShell to create a group of statements we wanted to execute together, and that's really what we're going to do here if the expression returns true. So we're going to add the curly braces in. And you can see that IntelliJ has highlighted the parentheses to signify a code block. Now that we've done that, if we run this code now, we should get no output. And that's exactly what we got, no output. This is because the second print statement is inside the code block now, and we get the expected output. And if we change isAlien back to false and run it again, we should get both lines printed out. And then we can see both lines printed to the screen. So using code blocks makes the code easier to understand. It also allows us to execute more than one statement if the expression is true. So in general, always use code blocks even if you're only executing one line. If you decide to revisit your code in the future and need to add another line, you may not have realized that you'd introduced a bug. So bottom line, always use a code block. Alright, so let's move on now, and the next video we're going to switch to another primitive type to continue our exploration of the if-then statement. See you in the next video. In the previous video, we got to work with the equals operator, also known as the equal to operator, and we used it in conjunction with the if-then statement. In this video, we're going to continue our exploration of the if-then statement. We'll also introduce a few other operators, including the logical and operator. Let's get back to the hello class we were working on in the last video. Before we continue, let me just show you an IntelliJ trick. If we come up to the tab above the editor window with the label hello.java and we double click it with our mouse, this minimizes the project pane on the left and maximizes the editing window. For future videos, I'll be demonstrating the code segments with the project pane minimized. To restore it, we can simply double click on that tab again. We can also just click on the tab on the left that says project for the same effect, which I'll do now. And we'll start this lecture with that minimized. Alright, let's continue outside of the code block from the last video in the class we called hello by starting on line 12. You may notice that I like to leave an extra line between each bit of code, which just helps the readability a bit, and if you want to review the code later, it'll be easy to locate the code that's associated with each topic we've covered. So let's add some more code next. Int top score equals 100 semicolon. If opening parentheses top score equals 100 closing parentheses opening curly brace. System.out.println, opening parentheses, double quotes, you got the high score, closing parentheses, semicolon. Closing curly brace. So you can see that the equal to operator is comparing top score to the literal value 100. And since top score equals 100, the expression top score equals 100 should return true and our code block will be executed. So if we run this, we should see the output. You got the high score. And there it is printed on the screen, so that's working correctly. but we can also do something like this, which you may remember was an IntelliJ suggestion. We can use the not equal to operator by replacing the first equal sign with an exclamation mark. So our expression is now asking, is top score not equal to 100? And the answer is no. If the previous expression returned true when we used an equal to operator, then clearly this expression will return false. And if we run that again, no output, and that's correct. The expression returned false, so the code block didn't get executed. Now we can use another operator, the greater than operator. Let's replace the not equal to operator with the greater than operator. So now this expression is asking, is top score greater than 100? We know that the answer is no to that, but we'll run it anyway to confirm our code is working. We don't get the high score message, so that's correct. Since the top score is equal to 100, and we're asking the question, is top score greater than 100, and the answer is false. But we can refine that expression even further. Instead of using greater than, we can use greater than or equal to, and we can do that by adding an equal sign after the greater than symbol, as we'll do next. Now this expression is asking the question, is top score greater than or equal to 100? So it's one operator to cover both those scenarios. And if we run that, we get the output because the expression returns true. In this instance, top score does in fact satisfy the condition greater than or equal to. We can contrast that and do a similar thing with the less than operator. And since top score equals 100 and 100 is not less than 100, the expression will return false and nothing will get printed to the screen. And next, we can also use the less than or equal to operator, which is similar to greater than or equal to. This time, though, we're testing to see if top score is less than or equal to 100. And again, we're seeing that output because top score is equal to 100 and the expression we tested was whether top score was less than or equal to 100. Now just to confirm that this is working, we'll change top score to 80 and the expression to just the less than condition. So now we're testing to see whether top score is less than 100. And since we've defined top score to be 80 now, that should be true. And if we run this, we get the high score message again, and this is because 80 is less than 100. Alright, so let's introduce another variable because I want to show you a slightly more complex example. So let's press enter a couple of times and start on line 17, and we'll create another variable and try something a bit more interesting. Int second top score equals 60 semicolon. If opening parentheses top score greater than second top score and then top score less than 100 closing parentheses opening curly brace. System.out.println opening parentheses double quotes greater than second top score and less than 100 closing parentheses semicolon. Closing curly brace. So looking at this code, this is actually performing two tests now. It's saying, is top score greater than the second top score? But it's also saying, is top score less than 100? So the two ampersands put together like that is called the logical and operator. This ensures that both operands to the left and right of the logical and operator are true. There's also a single ampersand that we can use, which is called a bitwise end. It works in a similar way, but you shouldn't use that here, and we'll talk about bitwise operators later, which is something you will use a lot less than the logical and operator. Now, going back to the code, we should find the message printed to the screen. And the reason is the left side is true because top score is 80, and that's greater than second top score, which is 60. And the right side is also true because top score is less than 100. So if we run that, greater than second top score and less than 100 is the correct output. And just to confirm this is working, we'll change second top score to 81. So that changes the scenario because now second top score is greater than top score. And if we run that, you can see there we haven't got the message in the output. So it only needs one side to be false to make the entire condition false. Alright, so that's a more advanced if-then statement. Let's end the video here, and in the next video we'll continue our exploration of operations. And we'll also be looking at something called operator precedence. See you in the next video. In the previous video, we talked about operators, including the logical AND operator. In this video, we'll continue with the discussion of operators and we'll get into operator precedence. We'll be starting with the class hello from the previous video in our Hello World project. We finished off the last video by talking about the ampersand symbols called the logical AND operator and how it required both the left operand condition and the right operand condition to be true in order for the code block to be executed. Let's confirm that by running the code. We can see that the last code block wasn't executed because it didn't print out the statement greater than second top score and less than 100. And this is because we defined second top score to have a value of 81, which caused the left operand condition to be false. Alright, so a useful thing to do with these expressions or conditions is to use extra parentheses to clarify your meaning. Now this could also have an effect on your code, but we'll talk about that in a future video. For now though, we're talking about enhancing meaning. So we'll put parentheses around the left operand condition as well as the right operand condition. This makes the code easy to read. It's clear now what the condition is for the left and right operands of the logical AND operator. And if we run the code again, nothing's changed, which is good. So adding the parentheses didn't change the outcome. We got exactly the same results. The idea is to remove confusion, and as a result of that, it makes it quicker to understand the code at a glance. This can be helpful in the future when you're looking over your code, or if someone else is reviewing your code, and you might have forgotten the reasoning for putting it there in the first place. So that's the logical AND operator. Let's move on now and talk about the pipe symbols, which is known as the logical OR operator. So the logical OR operator works in a similar way to the logical AND operator, but the difference is that it only requires one of the conditions to the left or right side of the logical OR operator, the two pipe symbols, to be true. Remember that the logical AND operator, or two ampersands, required both sides, both conditions, to evaluate to true. The AND operator actually comes in two flavors in Java, as does the OR operator. Ampersand is the logical AND, which operates on Boolean operands, checking if a given condition is true or false. The ampersand is a bitwise operator working at the bit level. This is an advanced concept that we won't get into here. Likewise, the two pipe symbols is the logical OR, and again it operates on Boolean operands, checking if a given condition is true or false. The pipe is a bitwise operator, which is also working at the bit level. And just like the bitwise and operator, we won't be using it as much as their logical counterparts. We'll almost always be using the logical operators. So let's put in some additional code here on a new line starting on line 22. We want to test a new condition using the logical OR operator, so we'll type if opening parentheses, top score greater than 90, closing parentheses, logical OR operator, opening parentheses, second top score less than or equal to 90, close both parentheses, opening curly brace. And now we'll print out a statement. Closing curly brace. Alright, previously we've defined top score to be 80. And looking at the code we've just written, the left condition is going to be false because 80 is not greater than 90. We've defined second top score to be 81. And this is going to return true for the right condition because 81 is less than or equal to 90. So we have one false operand and one true operand. Therefore, we should still get the output because one of them is true. And there it is, either or both of the conditions are true. And just to confirm that, if we change second top score to 95, an arbitrary number that's greater than 90, run it again. And this time we don't get any output from that last if statement because both the left and right conditions return false. Alright, so let's finish the video here. In the next video, I've got a mini challenge for you, which I think should be fun. And after that, we'll talk about the differences between the assignment and equal to operators and how to ensure you don't get into difficulty with those. So I'll see you in the next video. In the previous video, we worked with the logical OR operator. In this video, we'll start off with a mini challenge, then we'll talk about the difference between the assignment operator and the equal to operator. Alright, The challenge relates to a common bug that people who are new to programming may encounter. We'll start the challenge by typing some code. I'll start this code on line 26 of the Hello class in the Hello World project that we've been working with in the past several videos. Int new value equals 50 semicolon. If opening parentheses new value equals 50 closing parentheses opening curly brace. System.out.println opening parentheses double quotes. This is an error closing parentheses semicolon. Closing curly brace. So there's the code, and my question to you is, what is wrong with this code? Note that IntelliJ is flagging that line, and if we hover over it, we can see that it's saying required type boolean and provided type int. So why did we get this error? This is a type conversion error like we saw in JShell, but just worded a bit differently in IntelliJ. First, new value has been set to 50, and the if statement is testing to see whether new value equals the literal value 50. But is that what this code is really doing? Pause the video now if you want to solve that on your own, and I'll see you when you get back. Welcome back. Did you figure that out and get the code to run in IntelliJ? IntelliJ is telling us that there is a problem with the expression in parentheses their new value equals 50, and actually the problem is the equals sign. Before we fix the problem, let's talk about the difference between the assignment operator and the equals to operator. As you can see, we've used the assignment operator, one equals sign, in the if statement. What we need to do is to use the equals to operator, two equal signs. This is what the code should look like. We're not assigning a value here. Instead, we want to test if the values are equal to each other. All right, so how do we fix this? We need to put the second equal sign in, which is now an equals to operator, and we're correctly comparing the value of new value to the value 50. The errors disappeared, and if we change the message to match the if statement and then run the code again. We get the message printed out to the screen. All right, so again, that's a common problem you'll come across, and even very experienced developers will make this mistake when they're coding. Luckily, IntelliJ points out problems in our code as we're editing it, and before we even think about running it. Next, I want to show you another problem. This time, instead of comparing a variable to a numeric value, we'll compare a variable to a boolean. So let's pop down here to line 31 and start adding some additional code. Boolean is car equals false semicolon. If opening parentheses is car equals true closing parentheses opening curly brace. System.out.println opening parentheses double quotes. This is not supposed to happen closing parentheses semicolon. Closing curly brace. So what do you think is going to happen in this scenario? IntelliJ doesn't see any problem with this code, and there are no errors flagged. What about you? Do you see a problem with this code? So pause the video now if you want to try and solve it on your own. Otherwise, we'll be walking through it together next. All right, let's first run this code since there aren't any errors in the syntax according to IntelliJ. And look what's happened. We get the output. This is not supposed to happen. We can clearly see that we've defined the value of isCar to be false. And it appears at first glance that we're comparing isCar to the value true, but for some reason the code block has still been executed. And what's more, unlike the example using an int variable above, when we use the assignment operator instead of the equals to operator, we haven't got an error here. So why isn't IntelliJ flagging this as an error? In the case of the example above, where we use the assignment operator instead of the equals to operator, if we hover over that again, it says required type boolean and provided int. In other words, the if statement requires a boolean, but the expression new value equals 50 returns the value 50, which is an int. Whereas the expression new value equals 50 is comparing the values, and it'll return a boolean. Now in the case of the code we've just written, it's assigning the value true to isCar and then returning the boolean value true. So that's why we get an error for new value, but not for isCar. Let's just undo that change we made to the new value expression so this code compiles. So the bottom line is to make sure you use the equals to operator when you're testing to see if the values are equal and not the assignment operator. So I'm going to go back and fix this. We're now using the equals to operator. And if we run the code now, we no longer get the message, meaning the code worked as we expected now, and that's because we're using the equals to operator. We can also simply use isCar in the if statement. This is a valid shortcut in Java. Instead of checking to see if isCar is equal to true, we simply return the value of isCar, which in essence does the same thing. We can also do test for not true. So if we wanted to specifically check if isCar is not equal to true, we can change the code and add the not equals true. Or it might really be clearer to have the expression test if isCar is false rather than not true. So this code specifically checks if the isCar variable is false. But similar to just using the isCar variable by itself, in the expression, we can also use the shortcut of just testing a not isCar as follows. The exclamation mark is the not operator, and that basically checks to make sure that isCar is not equal to true. Another way to think of it is it returns the opposite value of isCar. In this case, isCar has been set to false, so it'll return true. The exclamation mark or not operator is also known as the logical complement operator. It can be used with a Boolean variable to test for the opposite value. In the code above, we are simply testing the value in the isCar variable, false in this case. But if we use the not operator, we are testing for the opposite value of the isCar variable, true in this case. I generally recommend using the abbreviated form if your variables are Booleans for two reasons. One, it's much harder to identify the error if you accidentally use an assignment operator. Remember, IntelliJ won't flag this as an error when you're testing a Boolean variable, so the only way you'll know you made this common mistake is by discovering the output from your code isn't what you expected. Secondly, the code is more concise, and more concise code can often be more readable code. Alright, we'll be ending this video here, and in the next video, I want to talk about something called the ternary operator, so I'll see you in the next video. In the previous videos, we learned how to use the if-then statement, as well as experimenting with the logical and the logical OR operators. In this video, we're going to take a look at something called the ternary operator. The ternary operator, Java officially calls it the conditional operator, has three operands, the only operator currently in Java that does have three. The structure of this operator is operand 1, question mark, operand 2, colon, operand 3. The question mark symbol appears between the first and second operands, and the colon appears between the second and third operands. So what this operator does is test if operand 1 is true, and if it is, it'll return operand 2. Otherwise, it returns operand 3. The first condition is always a Boolean test, but the other operands don't have to be Boolean values. So let's look at this operator in some code. We'll continue in the main method of the hello class in our Hello World project, and we'll enter a couple of lines of code. String make of car equals double quotes Volkswagen semicolon. Boolean is domestic equals make of car equals double quotes Volkswagen question mark false colon true semicolon. So first we have a variable that is the make of the car. In this case we assign it Volkswagen. On the second line we use the ternary operator, and with it we've got three operands. Incidentally, the ternary operator refers to the fact that the operator takes three operands, ternary meaning composed of three parts. The first part of this operator, the first operand, is the condition or expression we're testing and should evaluate, as all conditional logic does, to either a true or false outcome. In this case, we want to know if the make of the car is Volkswagen. The second operand is the value that will get assigned if the expression is true. So, if the make of the car is a Volkswagen, which we know it is, this is the value that's returned. Here we're assigning false to is domestic. And the third operand is the value that gets assigned if the expression is false. Our expression was true, so this value won't be used. Let's print out some text testing the value of the result of that ternary operation, which we assign to the is domestic variable. So, adding that code, if opening parentheses is domestic, closing parentheses, opening curly brace. System.out.println, opening parentheses, double quotes, this car is domestic to our country, closing parentheses, semicolon. Closing curly brace. If we run this, you can see that we don't get any output from this last statement. Basically what we're saying here is, if the condition returns true, we assign the value after the question mark to the variable on the left side of the equals sign. However, if the condition returns false, we assign the value after the colon to the variable. And since make of car is a Volkswagen, we assign the value after the question mark and before the colon, which is false, to be the resulting value, and assign it to is domestic. Let's review this operator more closely. The ternary operator is a shortcut to assigning one of two values to a variable depending on a given condition. So think of it as a shortcut of the if-then-else statement, and of course we haven't discussed else at this point, but we'll be discussing that later. Consider this example. Operand 1, age of client greater than or equal to 18 in this case is the condition we're checking. It needs to return true or false. Operand 2, over 18, here is the value to assign to the variable age text if the condition above is true. Operand 3, still a kid, here is the value to assign to the variable age text if the condition above is false. In this particular case, age text is assigned the value over 18 because age of client has the value 20, which is greater than or equal to 18. Now it can be a good idea to use parentheses, like this example below, to make the code more readable, particularly in the ternary operator. So string age text equals, and then we just put operand 1, age of client greater than or equal to 18 in parentheses to make it clear. In the first example we looked at in our code, we returned a Boolean value from the ternary operation. This was a good way to demonstrate the ternary operator, but wouldn't be something you'd do in real practice. A much simpler way to write this code is shown here. You can see that this code has the same effect and is quite a bit easy to read. The result of a ternary operator can be any data type, and the data types can be different if we aren't assigning the result to a variable. If we are assigning the result back to a variable, the type of both the second and third operands should be that data type or a compatible type. To reiterate, the ternary operator is a way to replace an if statement if you want to get a value back based on a condition. Let's consider the following code. String s equals opening parentheses is domestic, closing parentheses, question mark, double quotes, this car is domestic, colon, double quotes, this car is not domestic, semicolon. System.out.println, opening parentheses, s, closing parentheses, semicolon. In this case, a string is the result of the ternary operation, and you can see that in some ways this works similarly to the if statement we just reviewed above it. Running this code, we should get the output, this car is not domestic, so you can see from this example how a ternary operator could replace the if statement, returning a specific value based on some condition. Alright, so let's end the video here. In the next video, I want to talk a little bit more about operators with a bit of a summary, and then we're going to get into a challenge and talk a bit about operator precedence. See you in the next video.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
To start this video, let's have a look at a useful web page on Oracle's website, which will give you a summary of the operators we've discussed in this section of the course. I'm going to go over to Google and I'll type in Java Summary of Operators, and then I'm going to click on the first link. As you can see, we have pretty well talked about all of those operators now, but there is one important one that we haven't talked about at this stage. Let's scroll down and have a look. Is the type comparison, the instance of operator, and there's a reason for that, and that's because that really needs you to understand the concept of classes. So we'll be talking more about instances when we get to the stage of working on classes in the course. And the other ones we haven't talked about are the bitwise and bit-shift operators. These are ones that are very rarely used in Java. The important ones are the conditional operators, the logical, and and the logical, or which we've talked about at length in this course. I suggest you access this list if you want to find out more information, but you can see that we've pretty well dealt with most of these as we've gone through the course. Alright, next I want to open a new tab in my browser and do a search for Java operator precedence table. This first link here, this cs.bilken.edu.tr, is the one we'll look at, so I'll click on that. That gives us a handy list of the precedence table in Java. This table shows us how Java decides the priority of evaluating things in an expression. The first column shows the precedence, and keep in mind, the higher the number in that column, the higher the precedence. So note, for example, that the highest precedence, 15, has parentheses, so that's a way Java ensures that your condition overrides standard precedence rules for things like you see in precedence 12, which is multiplication, division, and modulus, and precedence 11, which is addition and subtraction. There is a bit of a hint there to keep in mind when you get to the stage of solving the challenge, which I'm going to talk about shortly. We can see that multiplication, division, and the modulus, or the remainder operator, have a higher precedence than addition and subtraction. Because of this, you may not get the results you expect using those operators depending on the precedence and the order in which you're doing things. For now, keep in mind that we can use parentheses to override other things like multiplication. Parentheses sort of force the condition to be evaluated in the order that we think it should be. So this is one reason why it's often a good idea to put parentheses around conditions. If you get stuck, come back and refer to this table when you're going through the challenge, and when we review my solution to the challenge, we'll be talking more about operator precedence. Alright, so let's test what you've learned about operators with this operator challenge. There are 7 steps to go through this challenge, so you might want to have this video paused while you're going through it and refer back to this as you're completing the challenge. Step 1, create a double variable with a value of 20.00. Step 2, create a second variable of type double with a value 80.00. Step 3, add both numbers together, then multiply by 100.00. Step 4, use the remainder operator to figure out what the remainder from the result of the operation in step 3 and 40.00 will be. Step 5, create a Boolean variable that assigns the value true if the remainder in step 4 is 0.00, or false if it's not 0. Step 6, output the Boolean variable just to see what the result is. Step 7, write an if-then statement that displays a message got some remainder if the Boolean in step 5 is not true. Now we've previously used the modulus or remainder operator on ints in this course, but I'm confirming here that you can also do the same for double, a variable of type double. Don't be surprised if you see output for this step where you may expect it not to show, and I'll explain that in my solution. So pause the video and try it out, and come back and we'll go through my solution. And I'll show you the potential issue you may come across with operator precedence in my solution as well. I'm kind of giving the game away a little bit there, but see how you do. Pause the video now and I'll see you when you get back. Alright, so welcome back. Hopefully you managed to finish the challenge or get a lot of it done. So let's step back over to our code again and start solving the challenge. Step 1 was to create a double variable with a value of 20.00. Double my first value equals 20.00d semicolon. Step 2 is to create a second variable of type double with a value 80.00. Double my second value equals 80.00d semicolon. Step 3 said to add those two variables together and multiply by 100.00. We'll include a system.out.println statement here so we can see what that value is. Double my value's total equals my first value plus my second value times 100.00d semicolon. System.out.println, opening parentheses, double quotes, my value's total equals plus my value's total, closing parentheses, semicolon. Step 4 uses the remainder operator to figure out what the remainder from the result of the operation in step 3 divided by 40.00, and again, we'll print that result out. Double the remainder equals my value's total modulo 40.00d semicolon. System.out.println, opening parentheses, double quotes, the remainder equals plus the remainder, closing parentheses, semicolon. In step 5, we want to create a Boolean variable that assigns the value true if the remainder in step 4 is 0.00, or false if it's not 0. Let's use the ternary operator to do that and print the value out for step 6. Boolean is no remainder equals opening parentheses, the remainder equals 0, closing parentheses, question mark, true, colon, false, semicolon. System.out.println, opening parentheses, double quotes, is no remainder equals plus is no remainder, closing parentheses, semicolon. Finally, the last step, step 7, is to write an if-then statement that displays a message got some remainder if the Boolean in step 5 is not true. If opening parentheses is no remainder, closing parentheses, opening curly brace. System.out.println, opening parentheses, double quotes, got some remainder, closing parentheses, semicolon, closing curly brace. Alright, so looking at the code and summarising what we did. The first line we typed has our assignment of 20 on line 47. On line 48, we assign 80 to the second variable, and then on line 49, we've got my first value plus my second value. So that's 20 plus 80 is 100, multiplied by 100, and that should give us the answer, 10,000. So therefore, the remainder of 10,000 divided by 40, which is the code on line 51, should give us no remainder because 40 goes into 10,000 exactly 250 times. So technically, if we run this code, we should see my values total set to 10,000. We should also see the remainder set to 0. We should next see is no remainder set to true. And then the if-then statement on line 55 shouldn't be executed because there isn't any remainder and we're assigning the value true to our variable if there isn't a remainder. Alright, so let's run this code and see what happens with all these values. So what's actually happened there was my values total is printing 8020 and we got 20 as the remainder, and therefore our is no remainder was set to false. So looking at the code, what we thought wouldn't happen has actually happened. So why is that doing what it's doing? Well, this is operator precedence in action, and this is the reason that I've coded it this way to give you an example of it. So firstly, we'll go back to our operator precedence table and let's have a quick look at that again. So I did hint at this a bit. Note here that multiplication has a higher precedence than addition. So what is actually happening if we go back to the code? So the code on line 49, what's happening there is that my second values, which is value 80, has been multiplied by 100 first. So Java has looked at the multiplication operator and decided that, okay, I need to calculate that part first because multiplication has higher precedence. So it's calculated my second value times 100 to be 8,000. Only after it finished the multiplication was 20, which is the value for my first value, added to that. And of course, 8,000 plus 20 is 8,020. That's the reason we didn't get the results that we thought we might get. What we really wanted to do in step 3 of the challenge was get 20 plus 80, which is 100, and then multiply that result by 100 to equal 10,000. And by doing that, we should get no remainder, and the message won't be output down at the bottom. To force this, we can use parentheses here to clarify the meaning. We'll put parentheses around my first value plus my second value. And because we know that parentheses have got a higher precedence than multiplication, that'll be evaluated first. So the result of that will then be multiplied by 100.00. Let's make that change now by adding those parentheses on line 49. So if we run this again, you can see now we've correctly got my values total equals 10,000. The remainder now has the value of 0 because 40 goes into 10,000 exactly 250 times, leaving no remainder. The is no remainder variable was set to true because there's no remainder, and consequently we no longer get the output, got some remainder. Alright, so now it's working as it should. So that's the challenge completed, and hopefully you managed to complete that. If you had difficulties because of the operator precedence, hopefully you'll now understand why it's important to use parentheses. Without parentheses, we'd need to code expressions evaluated in a specific order, knowing that they're going to be evaluated with the precedence table that I've shown you. Alright, so that's this video and our challenge completed, and in fact, that's the entire section now done and dusted. I just want to give you a quick reminder that you can grab the slides for all the videos with a handy PDF format that you can review by checking out the lecture at the end of this course. So I'll see you in the next section where we cover methods which give you a lot of flexibility to execute Java code. Once we learn more about methods, we can start giving you independent tasks that we call coding exercises. This is a way to work on your skills without having to watch me code every line and test whether the code you wrote meets the requirements we laid out for you. I think you'll find this part of the course both fun and challenging, so I'll see you in that next video. Welcome to Section 5, and congratulations on making it so far. Tim Buchaka here again. This next section is dealing with 4 really important concepts of Java. We're talking about expressions, statements, code blocks, and methods. These are 4 really key components of Java. It's really important that you get a good understanding of these, and that's the goal of this section, is to give you that understanding. So let's make a start. In this video, we're going to talk more about keywords and also just elaborate a little bit on expressions, which we've already covered to a degree previously. Firstly, with the keywords. Now, Java has actually got 51 reserved words that are used for keywords in your applications. So what I'm going to do is just go to a browser and I'm going to paste in this link to the Java language specification on keywords, and the link will be in the resources section of this video. And here is a list of Java keywords, and you can see in the Java programming language, a keyword is one of 51 reserved words that have a predefined meaning in the language. Boolean is one, double is another, and also float. But don't worry, you don't need to memorize any of these because we're going to go through each and every one of these in the course. You can see that Java actually uses the terminology character sequences to describe these now because, as of Java 9, the underscore by itself is a keyword. In addition to reserved keywords, you'll see that as of JDK 17, Java has 16 contextual keywords, which are only keywords in special situations. Let's swing back to IntelliJ and talk about keywords a bit further. For the next series of videos, I'll create a new project called Keywords and Expressions. We'll walk through the process of creating a new project one more time, and after that, the videos will just specify when a new project has been created. At the Welcome to IntelliJ IDEA screen, we select New Project. We'll give it a name of Keywords and Expressions using camel case for reasons we've previously covered. We'll select Java as the language and accept all the other defaults. Finally, we'll click the Create button and we're in a new project. In this project, we'll create a new class called Main by clicking on the src folder, selecting a new class, then giving it the name of Main. Now we have the code for the main class in the editor window. So we'll also have the main method as we've done before. Public static void main opening parentheses string opening and closing square brackets args closing parentheses opening curly brace closing curly brace. And you can see from this, IntelliJ is actually highlighting keywords in blue to show us that they actually are a keyword. Anything in blue that's in the IntelliJ editor is confirming to you that this is a reserved word. So for example, we can't go in here and create a variable name using any of the keywords. For example, if we move our cursor to line 4 and type in the following code, int equals 5 semicolon. IntelliJ is definitely trying to tell us that something is wrong with the red underscores, and if we hover over one of these red underscores, IntelliJ's messages identifier expected. And that's because as far as IntelliJ is concerned, the text int is a reserved word and it's actually a data type. We could use int2 instead as the variable name, and we'll do that next. Just tack on the number 2 to what is our variable name. And that's valid because that's only using part of the word, but you can't use a reserved keyword as we tried to do previously to name your elements in Java. So anytime you get into word errors, just make sure that you're not using a reserved keyword and you can refer back to that list. There are some words that aren't officially keywords but are specified below these 2 categories shown here. And although they aren't officially keywords but instead are literal values, we can't use true or false. You saw true or false before, or null, to name any of our variables or other elements. By the time we finish with this course, we'll have gone through all of these keywords and we'll develop a good understanding of what each is and where in code it's used. Writing code is similar to writing a document. It consists of special hierarchical units which together form a whole. These are the expression. An expression computes to a single value. The statement. Statements are standalone units of work. And code blocks. A code block is a set of 0, 1 or more statements usually grouped together in some way to achieve a single goal. We've talked a little bit about expressions in the past, and you've seen some of those in operations, but let's just expand on that a little bit as we look at some code. At the end of this discussion, you should have a specific understanding of what expressions are. We'll be using expressions a lot, and expressions are built using values, variables, and operators, which we've seen previously. Let's add some code to our main method, but first we'll delete that first variable we created since we don't need it for this next example. And now let's add some more interesting code on that same line. Double kilometers equals opening parentheses 100 times 1.609344 closing parentheses semicolon. So here we're creating an expression to convert miles into kilometers using the conversion formula of 1 mile is equal to 1.609344 kilometers. In this code, we want to figure out what 100 miles are converted to kilometers. This entire line of code is a valid statement. For that line, the actual expression is this component of the entire line. The data type does not form part of an expression, but everything else on the line typically forms or is part of the expression. So the expression component can include variables, values, and operators. All of those are used in this case. We've got a variable kilometers and we've got values like 100. And of course, operators, which in this case include the equals and multiplication symbols. So that's an expression, this component of the line. By including the data type and ending with a semicolon, we're now creating a valid Java statement. Let's look at some more examples of expressions. We'll type in a few more lines of code, starting here at line 6, first setting up a high score variable. Then we'll check its value, and if it's greater than 25, we'll add code to include extra bonus points to the score. Int high score equals 50 semicolon. If opening parentheses high score greater than 25 closing parentheses opening curly brace. High score equals 1000 plus high score semicolon slash add bonus points. Closing curly brace. Looking at this segment of code, we can identify 4 expressions. This part of the declaration statement, high score equals 50, is an expression. In the if clause, the component in parentheses is the expression high score greater than 25. The if keyword and the parentheses are not part of the expression though. And in the calculation, in the if statement code block, there are actually 2 expressions. First, the calculation by itself, 1000 plus high score, is one expression. Second, the entire line, excluding the semicolon, is an expression too. In the examples we're showing here, you can see that expressions make up almost the entirety of each statement. Next, let's add a bit more code, starting after that code block for the if statement. We'll keep going with our game theme and add a variable for health. Then depending on the health and the high score, we'll execute some code. So let me type that in now. Int health equals 100 semicolon. If opening parentheses health less than 25 closing parentheses and then opening parentheses high score greater than 1000 close both parentheses opening curly brace. High score equals high score minus 1000 semicolon. Closing curly brace. And now I want to give you a challenge. Looking at the code below, what parts are expressions? Have a look at the code that you can see on the screen. Write down what components of the lines I've entered there are expressions. Then come back and check your results after you've had a go at it. So how did you get on? Were you able to figure that out? How many expressions did you count? Let's go through this together and talk this through. So the components that are expressions, firstly on the first line. The health equals 100 component is the expression. Remembering that a data type and also the semicolon to the end are not part of the expression. In the second example, in the if statement, we have multiple expressions in parentheses. First, we've got health less than 25. And then we've also got high score greater than 1000. You'll remember the parentheses in this case aren't part of either one of those expressions. But the next expression is everything in the outer parentheses, which you'll remember is using the conditional and operator to evaluate two expressions at the same time and returning a Boolean value. So this is also an expression. And finally, we've got the code in the if statement block, which is a calculation. You'll remember this is similar to before and includes two expressions. The first is the calculation high score minus 1000. The other is the assignment, which is everything except that semicolon high score equals high score minus 1000. So that gives us 6 expressions altogether in this code. So did you figure all this out? Congratulations if you got them all. So that's expressions, and you'll be seeing expressions and keywords in use a lot more in future videos. In the next video, we'll look at statements more closely, and then we'll talk about what white space is and the use of indenting. So I'll see you on that video. In the previous video, we went through what keywords and expressions were. In this video, we're going to talk about statements, white space, and indenting, what they are and why they're important within Java applications. So I've created a new project in IntelliJ called Statements, White Space and Indenting, and I've created a new class named main with a capital M. I also added the public static void main method. In this and future videos, I'm going to assume you've done this and can get this set up on your own. If you're struggling, make sure you go back to that previous video and watch the first part of the video where I do that. So let's start off and just enter a simple declaration of a variable inside the main method on line 4. Int my variable equals 50 semicolon. And if you recall from the previous video when we discussed expressions, you know that the my variable equals 50 is the expression. So what is a statement? Well, a statement is the entire line. So the entire line that reads int my variable equals 50 semicolon. This is the statement within Java, so that actually is the complete line, if you will. So in this case, by adding the data type at the start to our expression and then finishing off with a semicolon, we've created a valid Java statement. So Java statements can be assignment expressions like the one there where we're assigning the value 50 to the variable my variable. And we can also do something like this. My variable plus plus semicolon. My variable minus minus semicolon. So those 2 lines of code we've added are both complete statements. The semicolon actually makes each of these a statement. Without the semicolon, my variable plus plus, for example, is really an expression. But also, if we now add a system.out.println statement, including the semicolon, that's also a statement. System.out.println, opening parentheses, double quotes, this is a test, closing parentheses, semicolon. So a semicolon is needed to complete a Java line to make it a statement in most cases, but there are exceptions to that, and as we go through this video, I'll talk more about those. The other thing to keep in mind with statements is they don't have to be on the one line. We can start a print statement and put a plus sign at the end, and then add another part to the statement, and then still more and end the statement. So looking at that first part of system.out.println, there's no semicolon. This means the statement hasn't really ended, and somewhat similar to what we saw in JShell, we can continue on the next line here in IntelliJ. And we can continue to add parts of the statement on different lines, and then end with that final semicolon after still more. So what it does is, it collectively adds all this together and effectively creates the line that should look familiar to you. To Java, whether the parts of the statement are on one line or multiple lines, it has the same meaning and is interpreted as a single line of code. So you'll see that typed in Java code, and often it's a good idea to do that to break up the parts of your statement so it makes more sense, so it's more readable. From Java's perspective, it doesn't care if it's on one line or on many lines, provided you're not trying to end the lines. So for example, if you try to put a semicolon there, Java's going to get into difficulty because it's now saying, well, there's no parentheses there. And it's expecting a parentheses because we put a semicolon there, which is acting as a terminator to close off the line. In other words, we'll get rid of that semicolon again and put the plus sign back. And if we run that, we've got the answer there, so it's working fine. You've already seen multiple statements on a single line in JShell, and we can have them in IntelliJ as well. Let's add 3 statements on the one line. Int, another variable equals 50, semicolon, my variable minus minus, semicolon, system.out.println, opening parentheses, double quotes, my variable equals, plus my variable, closing parentheses, semicolon. So as far as Java is concerned, that is still valid because it's found the semicolon between the statements, the separator. Although this is perfectly valid in Java, let me recommend against doing this in general, since it can be confusing to readers of your code. They might overlook statements, and it does take a little bit more effort to figure out whether that's all part and parcel on the same line. In general, you want to make it very clear what your code is doing, and formatting your code is one way to help with that. Putting one statement per line, or breaking up a long statement across multiple lines are ways to make code more readable. And this brings up the concept of white space. What is white space? White space is any extra spacing, horizontally or vertically, placed around Java source code. It's usually added for human readability purposes. In Java, all these extra spaces are ignored. So Java treats code like this, the same as code like this. Obviously, in the second case, it's a lot easier to read for us mere mortals, which is why white space is recommended. So let's add some white space. Whether we have one space or whether we have 10 spaces, Java doesn't care and will simply ignore white space here. We can even go to the extreme with something like the following. You can see then that obviously that's certainly not the way that I'd recommend you code and doesn't help with the readability of that statement. But if we run that, Java's quite happy with that syntax because what it's doing is it's looking at these spaces and effectively it's going to delete out extra spaces internally. And as far as it's concerned, it's going to be exactly the same internally as that there. So in general, with white space, you can do whatever you like there. And Java will ignore the white space and work quite happily. This feels like a good time to point out that style guides exist for writing readable code, and one of these is Google's Java conventions, which I'll show here, going straight to their recommendations for white space. And you can see there are rules for vertical white space and horizontal white space. For example, here's one on variable declarations. A blank line between 2 consecutive fields having no other code between them is optional. Such blank lines are used as needed to create logical groupings of fields. This is saying, in general, when you're declaring a set of variables, you wouldn't normally include an extra empty line between them, but if you wanted to group your variables in some way, an additional line of white space might make a grouping more clear. We'll be coming back to this document as we progress through the Java language, but also IntelliJ is configured with many Java conventions for white space built in. Let's head back to the code now. You'll note we don't get any warnings or errors, so it's a perfectly valid line of code. But IntelliJ has a little feature to reformat code, so I'm going to highlight that line of code, go up to the code menu bar item, and find reformat code and select it. Now, you can see that IntelliJ did reformat that code for us. It put each statement on a separate line, and notice also the first line in another variable equals 50, it added spaces around the equals sign. So IntelliJ can be used to help you comply with general best practices when using white space in code. You'll probably be using that IntelliJ feature quite a bit. So next let's explore the concept of indentation, which can also help your code to be more readable. So looking at a worst case scenario, if we went back and changed this code and removed all the default indentation, we'll do this by highlighting the code and using the Shift-Tab key code combination several times until we've removed all leading indentation. And I think you'll agree if you look at that scenario there, that is much harder to read to try and figure out where things are. You can use the Tab key for selected sections you want to indent, or again, we can just select the entire code portion and use the code menu and reformat code option to get the code back to proper indentation. And this code is a lot more readable. IntelliJ will automatically indent for us as we start code blocks at different levels in our code. So the concept of indenting is to make it easy for us to see the logical flow. Let's just quick add an if statement so we can see that if opening parentheses, my variable equals 0, closing parentheses, opening curly brace. And now you can see when we press enter, the cursor is waiting for us to enter code already indented appropriately for this code block. And we'll let some code properly indented now. System.out.println, opening parentheses, double quotes, this now 0, closing parentheses, semicolon. Closing curly brace. Code conventions for white space do exist, which you can refer to for more detail. The Google Java Style Guide, which was seen previously in this course, has a section on white space, so refer to that for more information, and the link to that is again in the resources section of this video. So that's statements, white space, and indentation. In the next video, we're going to talk about code blocks. We've mentioned them briefly, but let's look at them formally next. We'll talk about what they are and why they're so useful when coding in Java. In the previous video, we went ahead and discussed statements, white space, and indenting. It's now time to move on to the if-then statement and also discuss code blocks in more detail. Let's review what we've learned so far about the if-then statement. So as we've already seen, the if-then statement is used to check some condition or set of conditions, and then if that check evaluates to true, it will execute the code contained within the code block. Let's go back to IntelliJ and start taking a closer look. So, as you can see, I've created a new project. I've called it if keyword in code blocks, and I've also added a main method inside the main class and some white space. If you need some time, pause the video briefly, create a new project, and then add a class and main method as we've done before. What I want to do first is just go through the if statement a little bit more so you're familiar with the various ways that you can actually use it. So what we're going to do is create some code and then we'll go through it. Boolean game over equals true semicolon. Int score equals 5,000 semicolon. Int level completed equals 5 semicolon. Int bonus equals 100 semicolon. If opening parentheses score equals 5,000 closing parentheses opening curly brace. System.out.println opening parentheses double quotes your score was 5,000 closing parentheses semicolon. Closing curly brace. Hopefully you understand what we've done here. We created 4 variables, 1 of type boolean and 3 of type int, and we initialized each of them with a starting value. And then we have a simple if statement to check for if score is equal to 5,000 using the equality operator. Lastly, if we find that that condition is true, we'll print out a simple little response as we see with the println statement within the curly braces defining our if code block. Let's go ahead and run this, and I hope you can already see what should happen. So as you can see, this if statement was pretty basic and it printed out your score was 5,000 as we expected. So that's the first use of the if statement, which we've already seen previously used in a similar way. What I generally recommend is, even if you've got only the one line of conditional code, use a code block anyway. That's a best practice and something you will almost always see in order to make code easier to read and understand. So now I want to show you the other parts of the if statement, which I know we've talked about a little bit, but it's time to make it a little clearer. This slide shows the syntax for an if-else statement. As you can see, the else statement comes after the code block for the if statement and has its own code block also. What this does is evaluate the if condition, and if it's true, the code inside that code block will be executed. If the condition specified in the parentheses after the if keyword evaluates to false, the code inside the else code block will be executed. So the if-else will always result in an either or situation where some code will get executed, either the if statement's code block or the else statement's code block, assuming there's actually some code to execute within those code blocks. Before we add more code, let's first just change our if condition to check if score is less than 5,000 instead of equal to 5,000, and we'll change the statement we print. I'm going to delete these 2 lines and re-enter it again. But feel free to just edit the parts that need to be changed rather than typing it out again. If opening parentheses score less than 5,000 closing parentheses opening curly brace. System.out.println opening parentheses double quotes your score is less than 5,000 closing parentheses, semicolon. Next, we'll insert the else block into our if statement, and then we'll talk about it to help you understand. Else, opening curly brace. System.out.println, opening parentheses, double quotes, got here, closing parentheses, semicolon. Closing curly brace. So here, we've added the else block with a print statement and a different message, so we'll know which part executes. Well, just to see what happens, let's go ahead and run that. As you can see, we get the output got here. And the reason that we see that and we don't see any other output is the first if test was checked. So is this score less than 5,000? No, it isn't. So this line, this code block, was not executed as a result of that. So what happens then is the computer goes to the next part here, which is an else statement. And because we've got no other condition there, it says, okay, in all other circumstances, I'm going to just print got here. Now let's change that if condition again from less than 5,000 to less than or equal to 5,000 and see if we get a different result. And once again, I'm going to re-enter the code, but you can just edit it if you prefer. If opening parentheses, score less than or equal to 5,000, closing parentheses, opening curly brace. System.out.println, opening parentheses, double quotes, your score is less than or equal to 5,000, closing parentheses, semicolon. So we've changed it to less than or equal to 5,000. Now what do you think will happen when we run this? Let's run it and see. We get the message, your score was less than or equal to 5,000, and we see now the else wasn't executed. So this line didn't get executed because the if condition evaluated to true, and therefore that code block was executed. So you can see that the if statement is useful from that scenario, but we can even expand it further. This is the syntax for an if statement with else if and else blocks. As we already know, both the else if and the else are optional, but if you're going to use them both, they must be in the order shown here. The else must always be last. It can follow as many else if blocks as needed. So as we can see on the slide here, the if condition is checked first, and if first condition is true, that code block is executed. If first condition is false, Java will then check the first else if a condition, which is second condition in this case. So if second condition is true, it will execute that code block. So in this statement, if both first condition and second condition are false, then the code in the final else block will be executed. As soon as a condition evaluates to true and its code block is executed, that is it. The remaining conditions will be checked. So as shown on the slide here, if first condition is true, the expression for the else if second condition will not even be evaluated. And as we've already seen, the else block will not be executed. Okay, let's add some code and take a closer look. Let's change the condition of the if block and its message, then we'll also insert an else if block before the final else block. If opening parentheses, score less than 5,000, logical and operator, score greater than 1,000, closing parentheses, opening curly brace. System.out.println, opening parentheses, double quotes, your score was less than 5,000 but greater than 1,000, closing parentheses, semicolon. Closing curly brace, else, if opening parentheses, score less than 1,000, closing parentheses, opening curly brace. System.out.println, opening parentheses, double quotes, your score was less than 1,000, closing parentheses, semicolon. Okay, so now this if statement is checking to see if score is less than 5,000 and greater than 1,000. I hope you recall that the two ampersands there are the logical AND operator in Java. So then, if the first condition is false, it will check to see if score is less than 1,000. And finally, if both the previous conditions are false, it will print the got here message. So let's run this and see what happens here. And we get the message got here printed. It was executed because, of course, the comparison tests on lines 10 and 12 both evaluated to false. So score is equal to 5,000, not less than, which is tested on line 10, and score is, of course, not less than 1,000 as tested on line 12. So let's change the value of score to 4,000 to check that this is all working. Int score equals 4,000, semicolon. Okay, so now the value of score is 4,000, which is less than 5,000, but also greater than 1,000. So that first condition should evaluate to true. So if we run that, and as we expected, we get that your score was less than 5,000 but greater than 1,000 message. So it's now executed the first component, and we can see that it's automatically jumping out of the section after it's executed something. So as soon as it's found something true, it's going to ignore any following else if conditions and any else along the way. Let's make one more check by changing the value of score to 800. Int score equals 800, semicolon. And just to confirm that we get what we think we should, let's run that. We've now got the result, your score was less than 1,000. So we can see there, now that's only executed line 13. So this can be very useful to use the if keyword to build up statements. We can test potentially a lot of scenarios and to proceed to execute certain segments of code based on what the results of those comparisons are. So that's the if keyword with its additional else if and else code blocks. In the next video, we'll be giving you a challenge. In this video, we're going to copy a class, edit the code a bit, and then give you a challenge to work on. Okay, so the first thing we want to do is copy the main class that we were working on in the previous video. So back in IntelliJ, first, I want to open up the project pane by clicking on project here on the left. This displays the project pane here on the left. So now we'll open our SRC folder if it's not already open and right click on the main class. We get lots of menu options, but what we want to do is select copy. We could also have just used the key combination for our operating system, which in my case is Control-C for Windows. And now let's right click on the SRC folder and we'll next select the paste option. Next, we get a pop-up window for copy class and we have the option to rename the class here because we can't have two classes with the same name. That will give us an error. So let's name this copied class main challenge. So now that we've got our new class, let's take it to the next level. The first thing I want to do is delete everything from line 10 to line 16. So let's highlight that and get rid of it. Next, we'll create a final score variable and set it equal to the value of score. Then we'll check if game is over, and if it is, we'll add some bonus points and print out the score. Int final score equals score semicolon. If opening parentheses game over equals true, closing parentheses, opening curly brace. Final score plus equals opening parentheses, level completed times bonus, closing parentheses, semicolon. System.out.println, opening parentheses, double quotes, with final scores plus final score, closing parentheses, semicolon. Closing curly brace. You can see we're using the compound assignment operator to add more points to the final score. You'll remember we talked about this operator in a previous video. And what that means is it's basically shorthand for final score equals final score plus level completed times bonus. So if we run that, we see that the final score is 1300. And that's because the final score equals the score, which was 800, plus the value in level completed times the bonus. Since level completed is 5, and we're multiplying that by our bonus, which is 100, we get 800 plus 500. And the final score is 1300. So you can see that the code block was executed because game over, of course, was set to true up on line 5. And as we've stated before, another good practice is to abbreviate the condition expression. We can change game over equals true that can be abbreviated to just if game over like this. So that essentially is exactly the same as typing if game over equals true. Making this change helps make the code more readable, and it can help you prevent making an accidental assignment error, meaning if you forgot one of the two equal signs, it changes the whole meaning of the expression. Coding it this way is a win-win, and I want to recommend doing that. You'll see that commonly used in Java code. Okay, so it's challenge time. Insert a code segment after the code we've just reviewed. Set the existing score variable to 10,000. Set the existing level completed variable to 8. set the existing bonus variable to 200. Use the same if condition, meaning if game over is true, you want to perform the same calculation and print out the value of the final score variable. Okay, so the challenge for you now is to create a second printout on the screen, this time with the score set to 10,000, with the level completed set to 8, and with the bonus set to 200. So you need to do something very similar to what we've done here in this first example, but you need to also make sure that you don't change that code and it still displays from line 14. So essentially, you'll have the first message displaying, then below that, you'll have additional code and a second line with the new scenario also displaying. All right, so pause the video and go ahead and see if you can implement that. And when you're ready, start the video again and come back and see my solution. So how did you get on? Did you figure it out? Well, there's a couple of ways to go about this. What we could do, the first approach would be to create a complete new set of variables. We could do a copy and paste of that code, but then edit it to use all new variable names. When we first paste the new code in, IntelliJ of course is giving us some errors because we're redeclaring all these variables and we've learnt we can't do this. So next, we'll change all the variable names by adding the prefix new to the beginning of them. When we do this, we want to use lower camel case, so we'll change some letters to uppercase in the names. We want them to be formatted the way they should be. Okay, so we've renamed all the variables that we pasted in there and we've changed the values to meet the requirements of our challenge. So let's run this. And we get the answer 11,600, which is 10,000 plus 8 times 200 is 1,600, and 10,000 plus 1,600 equals 11,600. So that's certainly one solution to it, creating all new variables. Remember, there is rarely ever a single right solution to one problem. But some solutions are better than others. Some may be more efficient, some may be easier to read and maintain, and others might be more reusable in the future. As a developer, you'll probably need to consider all three of these concerns. The disadvantage of the approach we just took is we're using extra memory because we're creating new variables that we potentially don't really need. So what we could do, as an alternative, we could just reuse the original variables that were set up and assign them new values. So let's go ahead and do that. But before we get started, let's comment out what we just did so we can leave it in there, but Java will skip it. To do that, we'll select everything we just did, the new variable stuff. And then to make all these lines comments, there are a couple ways to do it. You can go to the code menu up at the top, and then about halfway down you'll see comment with line comment. Notice also there's a keyboard shortcut we could have used, that is the second way. But since we're here, let's select the line comment option. Okay, then to keep this all looking neat, I'm going to come here to line 27 and hit enter a couple times to give us some nice space. The easiest and quickest way to do this will again be to copy the code we already have. So back up at the top, I'll select lines 6 through 15 and copy them. Then I'll come back down here and paste them at the bottom here on line 29. And once again, we get some errors from IntelliJ. But this time to fix them, instead of changing the variable names, we'll remove the data type, so the statements are no longer declaration statements. Now, they'll just be assignment statements. And we'll update the values to 10,000, 8, and 200. So let's do that. And we didn't have to make any changes to the if statement because all of our variables are the same. So we can run that to make sure it's working as we expect. And we still get the same output as we expected. So that's another way of doing it. That's just literally copying and pasting with only a few minor changes to the declaration statements to make them assignments. The advantage with that approach is it was quicker and we didn't create new variables. So we used the memory more efficiently. But the disadvantage is, firstly, we haven't got a permanent record of the original variable values up at the top on lines 6 through 8. So if we wanted to keep the fact that this first score was 800 and the level that was completed was 5 and its bonus was 100, we can't do that because we've now redefined the variables. Secondly, we've used game over equals true for both, and if we were tracking two players' scores, maybe game over was only true for one of them. So in that case, maybe we didn't want to actually print this out at all because this player's game was not over, and therefore the value of game over would actually be false. But the other disadvantage is simply that we're copying and pasting code. And the disadvantage with copying and pasting code is we're duplicating code. And that means if we need to make a change, then what we need to do is change it in more than one place. And if we forget that our code is duplicated, we may forget to change it in one place, which means our scores may not be calculated correctly or consistently. For example, let's just say we've decided to change the formula for defining our final score, and we're going to add a bonus of 1,000 to the final score that was calculated. Final score plus equals 1,000 semicolon. So that will be an overall final bonus. So if we run this, you can see the first score was correctly set to 2,300, which is the 1,300 plus the 1,000 bonus. But down here, we forgot to make the change in the bottom if code block. And as a result, that final score didn't have the extra 1,000 points added to it correctly. That's the disadvantage with duplication. We need to go back and remember all the places where the code is duplicated to make our changes. So we're really asking for errors in the long term because, let's face it, we're all human. We make mistakes and we forget things. It's very common in programming, particularly as the code we're working on gets more complicated, to forget if we're duplicating a lot of code where all that code is. Discrepancies and errors can easily creep in, so we definitely need to look for ways to avoid having the same code in multiple places. Luckily, there are lots of ways to help reduce or eliminate the need for any duplicate code. In the next video, I'm going to expand on this example and I'll show you how we can remove repeated and similar blocks of code by using the concept of methods. Methods take the code block to the next level and effectively allow us to reuse that code in many places, but it's written just once. So we type the code once and reuse it multiple times. Okay, so let's start talking about methods in the next video. In the previous video, we talked about the if keyword and then went into more detail about the code block. And we also talked about some of the issues with code blocks and duplication of code when we went through the challenge. What we're going to do in this video is talk about methods, which is a better way of ensuring that our code isn't duplicated and also makes our code a lot easier to maintain. Methods in Java give us a kind of way to write code once and then reuse that code anywhere in our program. So let's take a look at a more formal definition. Java's description of the method is: a method declares executable code that can be invoked, passing a fixed number of values as arguments. In this course, we use the terms invoke a method and call a method interchangeably to describing the process of executing method code. And as we briefly touched on, methods have some benefits. A method is a way of reducing code duplication. A method can be executed many times with potentially different results by passing data to the method in the form of arguments. Let's look at an example of code duplication. In the last video, we walked through the solution to a challenge together. So let's revisit that code now in the main challenge class. Note that I'm starting out with all the commented code removed so that it's easy to review. And of course, the big issue was, if you recall, we changed the code in one place in the first code block by adding final score plus equals 1,000 on line 14. But we didn't add that code in the second, very similar code block, showing you how easy it was to have errors if you have code replicated in many places. What would be a lot easier than trying to cut and paste code and then trying to support many instances of it would be if we could create code just once, put it in an area, and use it time and time again. And that's exactly what a method gives us. So let's have an attempt at creating a method now. Firstly, you may not be aware of this, but we've been using a method all along. This entire thing here, this entire section of code, that's actually a method. And the method has the name of main. And all the code in the middle of it are the statements that form the method block or method body. So if we want to execute the method named main, this is what's going to be executed, all that code that's in there. So what we're going to do is we're going to create our own method. One of the simplest ways to declare a method is shown on this slide. This method has a name, but takes no data in and returns no data from the method, which is what the special word void means in this declaration. It's accessible to the outside world because it uses the keyword public. It can be called directly using the class name, and we'll have more on this later because it uses the keyword static. All the code between the left and right curly braces is the method code block, which is also called the method body. Method name can be any valid identifier in Java, but we'll be using the lower camel case style to name methods. So let's create a new method that we'll call calculateScore. We want to add it underneath the last brace, the closing brace of the main method that is. And you can see that brace matches up with the public static void main. This is an IntelliJ way of saying that these two things line up. So we have to start our code for a new method outside of another method. You can't put a named method within another method, they need to be outside of it. It has to be within the class code block, meaning you can't have a method exist on its own outside of a class body. So this is where we would actually type it. Right now it's on line 28, but I'll add a blank line to help keep our code easy to read. So we're going to create our method called calculateScore. Now let's add that code in. Public static void calculateScore, opening and closing parentheses, opening curly brace. Closing curly brace. For now, we're not going to get too concerned about the public and static keywords. We'll be talking about those a lot in the future. But to avoid problems at this point, and to make life a bit simpler while we're still at this early stage in the course, we'll continue to use these keywords whenever we define a new method for the rest of this section, and we'll be doing that in the challenges as well. So, for the three terms here, public, static, and void, they all need to be in lowercase and all separated by a space. The ones highlighted in blue in IntelliJ are keywords which we've already talked about, so they're part of the Java language. Once we set up the definition of the method, we need to put our code in between the braces on lines 30 and 32. Anything that's in between the braces is a statement and is part of this method that we've called calculateScore. And when we execute this method, and I'll show you how to do that shortly, all the code we put in here will be executed. So to do that, I'm going to copy this first portion of the code and I'm going to paste it in this method's braces. So I've pasted it into our calculateScore method. You can see that IntelliJ isn't flagging any errors with this code at this point. If I mouse over the method name, IntelliJ will pop up some information about the method, mainly that the method calculateScore is never used. IntelliJ also is displaying a font color of light grey on the method name. For now, I just want you to make note of that, and we'll see what happens after we add code to call a method. To execute a method, we can write a statement in code which we say is calling or invoking the method. For a simple method like calculateScore, we just use the name of the method where we want it to be executed, followed by parentheses and a semicolon to complete the statement. So for this example, the calling statement would look like the code shown here. So let's actually implement that in our main method. We can replace all the code in that first if then block we created with a call to calculateScore. So we'll delete this part out because we don't need these statements now because the calculateScore method does all this work. After we delete that code, we can replace it with a single statement, and that is the call to our method. So we'll just type calculateScore, opening and closing parentheses, semicolon. And now, what I want you to notice is that the font used in the method declaration has changed from a light grey to a normal black, and IntelliJ also shows a helpful hint above the method name on usage. And that's IntelliJ's way of saying this method is being used now. Why is this important information to know? Well, once your method is in use, you should always proceed with caution when making changes to its code. And certainly you don't want to delete it if there's code dependent on it. In a production environment, it's critical to be aware of the effect your changes will have on any code that uses your method. On the other hand, a light grey method name indicates the method isn't being used and it might be okay to delete it. So what we've done now is we've actually said when we get to this portion of the code that we want the code to jump to this method, calculateScore in this case, and execute the statements in the method body. And once you get to the end of the method's code, come back where you left off and continue on down from here. So what should happen is it'll define the variables in lines 5 through 10. Then, when it gets to line 12, it will execute the calculateScore method once, and then it'll return back to this same point and run the second part for us until it gets to the closing curly brace for the main method down on line 24. So let's try that out. And you can see that it's worked quite nicely. So how would we do the second component How would we replace that second if block? Well, as it is right now, we would have to create a second method to do this next part of the code because our calculate score method has values hard-coded into it for game over, level completed, and so on. So we haven't really fixed anything yet. Doing it this way would mean we're really just converting two similar code blocks to two similar methods. But there's a better way to do this because the method offers additional functionality that we'll explore next. So if you think about it, what we'd really want to do, what would be ideal, would be if we could pass this information, the variables for game over, score, the level completed, and also the bonus to the method. So it doesn't have to create the variables in the method. Instead, they'd be sent to it, and the code could actually work with those existing variables. Well, as it turns out, we can do that. We can actually pass information to a method using method parameters. Where we previously had empty parentheses after the method name, we now have method parameters in the declaration. There are no limits on the number of parameters, and the basic syntax is to declare first a data type followed by a parameter name. Multiple parameter declarations are separated by commas. This method still returns no data from the method. Parameters and arguments are terms that are often used interchangeably by developers. But technically, a parameter is the definition as shown in the method declaration, and the argument will be the value that's passed to the method when we call it. So let's set up some parameters. First, we can look at the variables we defined in the method and ask ourselves if it makes sense for the outside code, the calling code, to set this stuff up and pass it to the method. And for all four variables, we'll want to just accept data from the calling code and not define them here. This will make the code much more readable. So what we need to do is define in the method declaration what parameters or what information we need to send through to it from our main method where we're actually calling calculate score. You define a parameter like a local variable first by declaring a data type and then give it a name of your choice. So let's add our four parameters and then we'll talk about it some more. Boolean, game over, comma, int, score, comma, int, level completed, comma, int, bonus. You'll notice I didn't put any values in there. I've only put the data type and the name of the variable. So what we've done is we've now said this method has to be sent four parameters. And they need to be a Boolean and three int variables. To execute a method that's defined with parameters, you have to pass variables, values, or expressions that match the type, order, and number of the parameters declared. In the calculate score example, we declared the method with four parameters, the first a Boolean and the other three of int data types. So we have to pass first a Boolean and then three int values as shown in this statement. We can't pass the Boolean type in any place other than as the first argument without an error. The statement below would cause an error. And you can't pass only a partial set of parameters as shown here. This statement, too, would cause an error. When we added these parameters, you'll have noticed that IntelliJ is now showing us some errors here on lines 28 through 31 and also up on line 12. So up here on line 12, the problem is our method call is now expecting us to pass four values because we declared four parameters in our method declaration. IntelliJ is actually saying, I'm expecting four values to be sent, and you haven't sent me any at all. So the parameters is what we define in this section when we're setting up a new method. But arguments are the actual values that get sent. So just to repeat, not the data type and not the variable name, but the actual values that we want to send to the method, these are the arguments. So how do we pass arguments? Well, one way is we can just type in the values that we want to send like this. True, comma, 800. So we've added two arguments, true and 800. But we've only typed two arguments. IntelliJ is saying, okay, you've got two there, but I still need two more. I can see game over, the actual argument is set to true and score set to 800. So they're going to be the values that match up as we call the method, but there's still two we need to finish off, and that's why we still have an error. So let's add the last two arguments, comma, level completed, comma, bonus. Notice that this time I used the variable names instead of the actual values, and this is valid in Java. As soon as I entered the last one, we don't have errors anymore on this line because as far as IntelliJ is concerned, the actual arguments we're passing match the parameters we've defined for the method. And this is really important. If we don't match those entirely, and in the exact order they've defined in the method declaration, we'll get an error. IntelliJ is confirming that the way we're calling the method is now okay, but it's still complaining down here on lines 28 through 31. So the thing is, when we're declaring a method and we're defining parameters of a certain type and a name, we don't have to create the variables in the method code block at all. In fact, if we do, like we currently have, we're redeclaring the variables, and that's an error. So let's go ahead and delete all those lines. What actually happens when you define these parameters, Java will automatically create variables with these names and the appropriate data type for us, which is really nice. So in this case, I deleted those variables, so there's now a variable called game over, score, level completed, and bonus that have been created automatically by Java for us because we've defined those as parameters for our method. Since we've fixed all the errors, we should be able to run this code now. And you can see we get exactly the same result as before. So since this video is getting long, I'll stop it here. In the next video, we'll be replacing that second set of code in the main method with a second call to our method. Then we'll launch into a discussion about returning data from methods. We'll be starting with the same code we've discussed here, so keep this IntelliJ project and class open. Okay, so I'll see you in the next video.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
In the previous video, we were working with the class main challenge, and I'm showing it here where we left off. You'll remember we replaced one if statement block with a call to our new method calculateScore. And so far so good. We've cleaned up some of the code, but it's still a little bit messy because of that second if statement and the extra lines in its code block. So let's change that second bit by making another call to the calculateScore method. Adding this method lets us delete all the following code in the main method. So we'll let the calculateScore call here and delete everything remaining after the call. CalculateScore, opening parentheses, true, comma, 10000, comma, 8, comma, 200, closing parentheses, semicolon. So now we have a second call to the method, and we pass 4 arguments, and they match up to game over, the score, the level completed, and the bonus. But notice this time, I'm actually passing the values directly. I'm not using variables or anything like that. This lets us delete all of the extra code that was assigning new values to our variables. Instead, we can just execute the methods with these new literal values. Remember, in the challenge video, we added 1000 to final score, but we only did that in the first if statement and not the second. But now, because we're calling code that's consolidated in one method, the code is consistently calculating final score, adding 1000 in both instances. So, of course, the second value has now got a score plus 1000 because it's correctly got the change we wanted to make in all cases. And if we run that, we get the 1000 added to both scores. Now, the other thing we could do here is, instead of mixing literal values and variables in the arguments we're passing, we could just pass all literal values in that first call. This lets us make this even more efficient by first deleting these variables because, of course, we don't need them anymore. We'll pass values directly to the method call, so we'll update that first call to the calculateScore method. 5, 100. And we've now got a fast, simpler bit of code. We've literally only got 2 lines that actually sends the information needed to the method. And if we run it, we get the same result as before. So that's one of the great features of methods, is that it makes it a lot easier for you to maintain your code because we've only got one place now where our code is modified, one method. And also you've noticed that we cleaned up a lot of code. There was a lot of extra code we had in our main method, but now we're down to just 2 lines. Let's add the local variables we had before back to the code, and this time, instead of passing just literal values or a combination of values and variables, this time we'll just pass variable names as arguments to the methods. So let's do that. We'll add the 4 local variable declarations back first, and instead of passing literals, I'll pass the variable names in the first call to calculateScore. Boolean, game over, equals, true, semicolon. Int, score, equals, 800, semicolon. Int, level completed, equals, 5, semicolon. Int, bonus, equals, 100, semicolon. game over, comma, score, comma, level completed, comma, bonus. Then we'll have the code we had before where we change the values in the variables before executing the code again. Score equals 10,000 semicolon. Level completed equals 8 semicolon. Bonus equals 200 semicolon. Game over, comma, score, comma, level completed, comma, bonus. In some ways, you can see this code is a little easier to read because instead of just passing unidentified literal values to the method, we're setting up logically named variables. This helps us figure out what is being passed to each execution of the method. So either way will actually work, and again, there's not really a right way to do it. A lot of it will depend on what coding standards you're using and also what the code around the call to the method is doing anyway. You might already have variables set up for some reason and would naturally code the statement this way. So all of this is pretty powerful. The fact that we can actually call a method, pass it some data, and get it to do something, and it helps make our code a lot cleaner. But it does actually get even cooler than that, because what we can also do is we can get our method to do some calculations much like it's doing now, but we can send the result of that calculation back to the code that called it. We do this by declaring a data type before the method name, much like we do for a variable, declaring a data type before the variable name. So similar to declaring a variable with a type, we can declare a method to have a type. This declared type is placed just before the method name. In addition, a return statement is required in the code block as shown on the slide, which returns the result from the method. In previous examples, we declared the type to be void, which has the special meaning that no data would be returned from the method. An example of a method declaration with a return type is shown here. In this case, the return type is an int. This method will return an integer when it finishes executing successfully. Being able to return a value from a method lets the calling code have a two-way conversation with the method code. So we can calculate something and send that value back to the code that called the method in the first place. So let's do this next. If we want to return something from our calculate score method, we need to first change the word void in the declaration to the type of data, the data type of the information that we'll want to send back. This is going to be the int data type, int. And once we do that, immediately IntelliJ is telling us there's a problem, we have an error. You can see that in the right-hand part of the screen, we have the little red icon with an exclamation mark. We can also see that IntelliJ has a red underscore under the method's closing brace. If we hover over that, IntelliJ tells us that the method is missing a return statement. So what's a return statement? Java states that a return statement returns control to the invoker of a method. The most common usage of the return statement is to return a value back from a method. In a method that doesn't return anything, in other words, a method declared with void as the return type, a return statement is not required. But in methods that do return data, a return statement with a value is required. So we've defined a method and said it was going to return an int, but we didn't actually set that up yet. So what we need to do is we need to add code to tell it to return that information. In the case of the calculate score method, we really want to return the final score that was calculated. So how do we do that? As you'd expect, there isn't just one way to do this. But since we've already got a variable in our method called final score, we can return that from our method. The most common place for a return statement is right before the method's closing brace, and that's what we'll do here. Return final score semicolon. Okay, so we've defined the type of information coming back in the declaration, and we've also defined the actual value to be returned in the code block. So next, what we need to do is take out the print line there, and now we're going to change the code in the main method that calls calculate score. So first, let's create a new variable called highscore, and we'll actually declare that right in front of the first call to our method. In other words, we're going to declare highscore, then immediately assign it to the value returned from the method call. Then we'll print that variable out, int highscore equals. System.out.println, opening parentheses, double quotes, the high score is plus high score, closing parentheses, semicolon. Let's run that. You'll notice now that we're only getting one line of output, The high score is 2,300. This is because, even though we are calling calculate score twice, in the second instance we don't assign the value that's returned to any variable, and we're not using it in any expression, so the return value is ignored by the calling code. You'll remember we also removed the system.out.println statement from inside the method, so nothing is in place to communicate the final score to the console for the second call of the method. This is not considered an error by the compiler or IntelliJ. We can use a method that returns a result either in an expression as we did on line 10 or as a statement as we did previously on line 17. Of course, in this instance, it doesn't really make a whole lot of sense to execute the calculate score method as a statement and not use the value returned. So let's change this code again. This time, instead of assigning the value to a variable, we're going to use the method like it's a value, and we can do that all in the system.out.println statement. System.out.println, opening parentheses, double quotes, the next high score is plus. So anywhere an int value can be used in an expression, we could make a call to a method that returns an int value like we did here. In other words, a method call that returns a value can be used in expressions and as an expression alone. Running this code gives us the output we see here. We get both lines printed out. And in fact, you can pass method calls as arguments to other method calls. We're not going to demonstrate that right now, but we'll be showing this quite a bit as the course progresses because this is very common practice. Okay, so in the next video, we'll be doing a review of what we know so far about methods and covering a couple of additional facts about methods before we give you a method challenge to code. In the last two videos, we covered a lot of ground with methods. This feels like a good place just to summarize what we learnt and review a few additional important points about the method. Java's documentation states that a method declares executable code that can be invoked, passing a fixed number of values as arguments. Like some of the abbreviated operators we learnt about, a method can be a statement or an expression in some instances. Any method can be executed as a statement. A method that returns a value can be used as an expression or as part of any expression. Some programming languages will call a method that returns a value a function, and a method that doesn't return a value a procedure. You'll often hear function and method used interchangeably in Java. The term procedure is somewhat less common when applied to Java methods, but you may still hear a method with a void return type called procedure. So there are quite a few declarations that need to occur as we create a method. This consists of declaring modifiers. These are keywords in Java with special meanings. We've seen public and static as examples, but there are others. Declaring the return type. Void is a Java keyword meaning no data is returned from a method. Alternatively, the return type can be any primitive data type or class. If a return type is defined, the code block must use at least one return statement returning a value of the declared type or comparable type. Declaring the method name. Lower camel case is recommended for method names. Declaring the method parameters in parentheses. A method is not required to have parameters, so a set of empty parentheses would be declared in that case. Declaring the method block with opening and closing curly braces. This is also called the method body. Parameters are declared as a list of comma-separated specifiers, each of which has a parameter type and a parameter name or identifier. Parameter order is important when calling the method. The calling code must pass arguments to the method with the same or comparable type and in the same order as the declaration. The calling code must pass the same number of arguments as the number of parameters declared. When declaring a return type, void is a valid return type and means no data is returned. Any other return type requires a return statement in the method code block. If a method declares a return type, meaning it's not void, then a return type is required at any exit point from the method block. Consider the method block shown here. In this method, we have a return statement in an if-then block. This code won't compile because there's no return statement to cover the cases where age is greater than or equal to 21. So in the case of using a return statement in nested code blocks in a method, all possible code segments must result in a value being returned. The following code demonstrates one way to do this. This code is valid because if age greater than or equal to 21, the code will return false in that instance. One common practice is to declare a default return value at the start of a method and only have a single return statement from a method returning that variable as shown in this example method. In this example, the local variable result is set to false at the start of the method. It gets set to true if age less than 21 in the if code block. You'll note in this code segment we're not returning from the if statement block at all, but setting the value of the result variable. Here, we have a single exit point from the method, and that's the last line of the method body. The return statement can return with no value from a method which is declared with a void return type. In this case, the return statement is optional, but it may be used to terminate execution of the method at some earlier point than the end of the method block, as we show here. So in this method, we use a return statement that doesn't return anything because the method is declared with a void return type. But we're returning from the method if the age parameter is greater than 21. Note that we don't pass any data on the return statement. This is perfectly valid, and you may see the return statement used this way. Also note that we don't need to add a return statement, in this case, at the end of the method block, as we did when the code had a non-void return type. A method is uniquely defined in a class by its name and the number and type of parameters that are declared for it. This is called the method signature. You can have multiple methods with the same method name as long as the method signature, meaning the parameters declared, are different. This will become important later in this section when we cover overloaded methods. In many languages, methods can be defined with default values, and you can omit passing values for these when calling the method. But Java doesn't support default values for parameters. There are workarounds for this limitation, and we'll be reviewing those at a later date. But it's important to state again, in Java, the number of arguments you pass and their type must match the parameters in the method declaration exactly. Now that we're armed with knowledge about methods, we can revisit the main method and examine it again. The main method is special in Java because Java's virtual machine, JVM, looks for the method with this particular signature and uses it as the entry point for execution of code. This method has two modifiers we've discussed briefly, public and static, and we won't discuss them here except to remind you that they are required for this special method to be recognized by the JVM. This method has void as the return type, so now we know this method doesn't return any data. The name of this method is main, all in lowercase. Again, this is important. You can actually name a method main with a capital M or all capital letters even if you want to, and the Java compiler will let you do that. But it won't have the special signature needed and therefore won't be the expected entry point for executable code. And we can see there's one parameter set up for this method, which we've glossed over a little bit. We know the name of this parameter is args. The type is actually a special type, which is an array of string. We'll cover arrays in a later section, but this method allows a user to pass a list of values into the code from the command line or terminal. You can see now why the name args is appropriate for this method, because it represents command line arguments, which this method has access to if they are passed in. Finally, in IntelliJ, if you type PSVM and hit enter, IntelliJ will insert the main method signature as we show here. The only reason to memorize this signature would be if you were taking a certification exam. IntelliJ is full of little helpful shortcuts like PSVM, and I recommend exploring IntelliJ tips when you have time. You can toggle tips to be shown on startup by using the search icon in IntelliJ and looking for tips. Okay, so that's a recap of what we know so far about methods. We'll be covering more as we look at overloaded methods later on in this section of the course, and overriding methods when we get to the object-oriented features of Java. Now, let's put all this knowledge to work. In the next video, I have a challenge for you. So let's move on to that next video. Okay, so it's time for a challenge. In this challenge, we're going to create two methods. The first method should be named display high score position. This method should have two parameters, one for a player's name and one for a player's position in a high score list. This method should print a message like Tim managed to get into position 2 on the high score list. The second method should be named calculate high score position. This method should have only one parameter, the player's score. This method should return a number between 1 and 4 based on the score values shown in this table. Finally, we'll call both methods and display the results for the following scores 1500, 1000, 500, 100, and 25. Okay, so see how you go with this challenge, go away and try and see how you get on. And once you're ready, come back and I'll show you my solution. So I've created a new project called First Method Challenge, and I've also created a new class method challenge. I've added the usual main method, which you should now be well aware of while we start with it. Okay, so let's have a go with the solution. So firstly, we have the method display high score position, which has the player's name as the first parameter, and the second parameter will be the position in the high score list. So let's create that method, then we'll talk more about the code. Public static void display high score position, opening parentheses, string, player name, comma, int, high score position, closing parentheses, opening curly brace. System.out.println, opening parentheses, player name, plus, double quotes, managed to get into position. Plus, high score position, plus, double quotes, on the high score list, closing parentheses, semicolon. Closing curly brace. So this method, the requirements didn't say anything about returning any data from it, so you see we start with public static void and then the name display high score position. We're going to be using a string data type for the first parameter and we're calling that player name. The second parameter is a position in a high score list, so we're using an integer for that. It wouldn't really matter what you use, but probably integer would be the most efficient, and we're calling that parameter high score position. And then we want to display the message that includes the player's name and text like managed to get into position, and we put the high score position next and finish off with the text on the high score list. So that's it for the first method. Now let's talk about the second method. So the second method is supposed to be called calculate high score position. We'll start with public static, but this one needs to return some data, so the method should be returning an integer, therefore it won't be void, but it will be int, which is the data type. This method, calculate high score position, just needs one parameter, which is an integer. This is the player's score. So let's start adding the code for this method. We'll build out the method structure first. Public static int calculate high score position, opening parentheses, int player score, closing parentheses, opening curly brace. Closing curly brace. So now we have the method structure and an empty code block. You can see that IntelliJ is not happy. It's saying we have one error and it's showing a red underscore on our method closing brace. You remember why that is, I hope. If we hover over that red underscore, IntelliJ will tell us we're missing the return type. That's because we're not done coding this method yet, so let's fill this out. Let's look at that table again with the values we're supposed to return based on the score. So our ranges are shown here, so let's write some code that does this. And we'll do that with an if, else block. I'm going to type in some code next, and then we'll talk about it. If opening parentheses, player score greater than or equal to 1000, closing parentheses, opening curly brace. Return 1, semicolon, closing curly brace, else, if opening parentheses, player score greater than or equal to 500, logical and operator, player score less than 1000, closing parentheses, opening curly brace. Return 2, semicolon, closing curly brace, else, if opening parentheses, player score greater than or equal to 100, logical and operator, player score less than 500, closing parentheses, opening curly brace. Return 3, semicolon, closing curly brace, else, opening curly brace. Return 4, semicolon, closing curly brace. Okay, so now you'll see that IntelliJ isn't showing any errors with the code. You might remember that one of our examples in the method recap video was using the return statement in an if statement. When this was the only return statement, this caused an error because we didn't have a return statement as the last statement of the method code block. But you can see here, we don't have that same kind of error. So why not? That's because we do have a return statement in the final else block. The else block is the catch-all for any conditions that don't match the conditions above it. So Java is smart enough to know that a value will get returned in all cases because of this. So since it compiles, let's try to call our methods from the main method. The requirements told us to test the values 1500, 1000, 500, 100, and finally 25. What we need to do is we'll actually call these methods with various argument values. I'll type in the first test case with 1500. We'll call the method calculate high score position with the value 1500. Then we'll call display high score position with my name Tim and the high score position that was returned from the previous method. Int high score position equals calculate high score position opening parentheses 1500 closing parentheses semicolon. Display high score position opening parentheses double quotes Tim comma high score position closing parentheses semicolon. Let's run that and make sure it works. And we can see we got the output that Tim managed to get into position 1 on the high score list. So we passed the method to score 1500 and calculate high score position return 1, which is what we wanted. Remember, our table said anything over or equal to 1000 should give a result of 1, so this test worked. Let's cut and paste this code 4 times, changing the values for the other 4 tests to 1000. $500, 100, and lastly 25. We'll also change the names for each player. Okay, so those are all of our test cases. For testing, we could have picked any values in between the ranges that were specified in the challenge table. But here, we've picked values that were right on the edges, and this was on purpose. This is called testing the boundaries of your conditions, which is where most of the problems or bugs in your code are likely to happen. You might have missed an equal sign when specifying a greater than or equals condition where one was required or something like that. So testing these boundaries, meaning using values like this along the lines where our ranges are changing, can hopefully help flesh out any problems in our code. So let's run that. So that looks pretty good. Bob, with a score of 1000, was given a position 1, and Percy with a score of 500 got position 2. Gilbert got position 3 with a score of 100, and finally, James was position 4 because his score was 25. So these results match the requirements. Let's test on the other side of the boundary. Instead of using 1000, 500 and 100 will change these values to 999, 499, and 99, and then we'll throw in a negative number test for good measure. This wasn't part of the challenge, but again, this is a good way to test your code. And then we'll run it. So looking at the results, we see that Bob, with a score of 999, is now in position 2, which is good and means the code meets the specification. Percy, with a score of 499, is now in position 3. Again, that's good and confirms that the code is checking for less than 500 accurately for the 3rd position. Gilbert, with a score of 99, is in position 4, which is right, and James, with a negative score, also scores last, confirming that anything less than 100 results in a value of 4. Okay, so let's revert back to our original tests. And now, let's talk about ways to improve this code. It's always a good idea, after you get it working, to ask yourself if the code could be more readable, more efficient, or more succinct. Pause the video for a moment and look at this method, calculate high score position. So, can you see ways to improve it? Okay, so what did you come up with? So let's look at line 28. Here, we're testing if the player score is greater than or equal to 1000, and if it is, we exit the method with a value of 1. This means that for all other test cases that are left, the player score will be less than 1000, so this test condition on line 30, where we test if player score less than 1000, is actually unnecessary. And that's also true for line 32, where we test player score less than 500. Again, if the code makes it to this test, it's already been determined by the condition above that player score is less than 500. So let's take those 2 conditions out of the code. Okay, so that's an improvement, and I would actually argue it makes this code more readable. each of the steps in the conditions is easily understood from the code. Did you see any other ideas for improvement while you were looking? What about this else statement block? It's actually unnecessary since the code will fall through without it, and we can just return the value 4 as a default at the end of the method body. So let's make that change as well. So if those 3 conditions end up being false, it drops down to here, then we're just going to return the value of 4 anyway. Let's test our changes with our existing tests. And the good news is we get the same results. So this exercise of reviewing your code, looking for ways to improve it, is always a good one. It's also a good idea to get another set of eyes on your code. This is a great way to learn Java. Maybe you found other ways you think may have improved the code. Before I end the video, I want to show you one more solution that actually eliminates the use of multiple return statements. Having the return statements in many places can sometimes be confusing for people reading our code, so let's instead make our code easy to follow and use only one return statement. We do this by creating a variable in the method at the start called position and setting it to a default value of 4, and then we'll make changes to each statement block as follows. Int position equals 4 semicolon. Position equals 1 semicolon. Position equals 2 semicolon. Position equals 3 semicolon. Return position semicolon. So here we changed each statement block to set the value of the position variable instead of returning from the method. And finally, we return position as the last statement of the method block. Whether you code with multiple return statements or set it up like this is a matter of style. So again, there are many ways to a successful solution. It's always good to try out alterations, especially in the beginning, and research the many sites on the internet that have coding samples. You'll also find there is a lot of discourse about the advantages and disadvantages of one technique over another. The more code you look at, the faster you'll learn Java. Alright, so that's methods. I hope you've got a lot out of it. I'll see you in the next video where I'll show you how to compare your challenge solutions to mine using a code compare feature in IntelliJ. So you've coded your challenge and it's different than mine, and maybe you can't quite see the difference. My solution works and yours doesn't, and it's frustrating to try to identify the differences by watching the video and trying to examine the solution in the video to your code in IntelliJ. Let me show you a better way to compare code. First, remember that my solution will be in a zip file in the resources section of each lecture. This zip file is the entire IntelliJ project zipped up. Second, we'll talk about an IntelliJ feature that will help you compare your code to mine. Finally, there is another feature that lets you look at the history of your own versions in IntelliJ in case you had something working, broke it, and want to get back that old version. So I'm in the project from the previous video, the first method challenge project in IntelliJ. And I have the class open, and I'll make a couple of small changes to our method calculate high score position. First, I'll set the initial value of position to 0. And then I'm going to add back an else block. You might remember from the previous video, we removed it to make the code a little more efficient, but now we'll just add that back. Else, opening curly brace. Position equals 4 semicolon. Closing curly brace. The reason we did this was so that my code would be different from the code in the resources section. And running that code gives us the same results. Now we'll walk through comparing this code with the code in the resources section. You can download that zip file from the resources folder, which I've already done, and we'll now unzip it into a folder. Alright, so now getting back to IntelliJ and our current method. We want to click the project tab to the left of the editor window to display the project panel. You'll remember that I like to keep the project panel minimized during videos, so let me just display that now. And now, what we want to do is to come over here to the project panel on the left and right-click on the method challenge class listed under the SRC folder. This displays a menu list. Then we want to scroll down to compare with and click on it. Now what we want to do is to navigate to the folder we looked at previously that contains the downloaded copy of the source code from the course. If we look in the SRC folder, we'll find the method challenge.java file. This is my solution to the challenge that we downloaded from the resources folder. So let's select that file, which pulls the source code of the method challenge.java file on disk into a special editor window. You can see that the code is displayed side by side with the method challenge class in our current project. So again, on the left is the code from our current IntelliJ project, and on the right-hand side, we've got the code that was downloaded from the Udemy lecture. You'll remember we made a couple of edits to our current class at the start of this video, and now we can see that these are being displayed in IntelliJ. Before we talk about what this screen is showing us, let's minimize the project panel again, along with the run window. Now we can better see IntelliJ's code compare tool now, and that it's highlighting differences in the two versions of codes in various ways. So first, you'll see that the symbol on the tab is a bit different than just the usual class 1 beside it, so you can close out of this tab at any time. Next, you can see that we have side-by-side viewer selected. If it's easy for you to look at the two files merged into one, you can select Unified Viewer. For now, we're going to stick to side-by-side. In the right-hand corner, IntelliJ will tell you how many differences it found, so we can see there are two differences identified. And the screen does a pretty good job of highlighting what has changed. You can see we've changed the value of the position variable from 4 to 0 on line 28, and we've added the else code section here on line 35. And now, if you want to just accept the changes from the code you downloaded from Udemy, you can use the double left arrows in the center of the screen to move the changes on the right to the left side. Remember that the left side is our current code in IntelliJ, so that's what we want to do. So I'll do that for both changes. And now our code is the same as the code we downloaded. So that's one way you can review the differences in your code with the code we provide for each lecture. I want to encourage you to play with this feature and get familiar with it. We'll close that tab now because I want to show you another feature in IntelliJ which might help you down the road at some point. And we'll also get our project pane back by clicking on Project over here on the far left. And again, let's select the Method Challenge class and right-click on that to bring up the menu options available to us again. And down here, you'll see Local History, so let's select that and then pick Show History. And now you can see that IntelliJ has been saving all of our versions of this class as we've been making edits. So, if you change something and can't quite remember what, or you want to revert back to a previous version, you can use this tool. In this screen, the current version is on the right-hand side of the window, and whatever version you have highlighted in this left navigation pane is displayed by default in the left half of this editor window. So here, you can see our differences again. And like before, we can select the changes from the previous version, this time by clicking on the two right arrows in the center of the two views, and this will copy the code from the previous version into your current version. In this way, you can pick and choose to revert portions of your code back. Or you can highlight a previous version in the left pane, right-click to show the options menu, and here you see Revert. This will revert the entire class to a previous version. So these are two features which can help you out quite a bit as you progress throughout this course. You can use the Code Compare feature to see the differences between the downloaded classes and your own classes. You can also compare the contents of entire folders, which we didn't walk through here. This will become useful once we get to packaging up class files for deployment. This feature will help you identify if the files in one folder match another. We'll look at this later in the course. And you now know that you can use the Local History feature to find and revert to a previous version or sections of a previous version if you've found that your code has really gone off the rails at some point. And you want to get back to the last point where everything was working. Alright, so at this point now, I'm going to finish the video. I hope you've got a lot out of this review of IntelliJ's code comparison features. Next, we're going to introduce you to something called coding exercises. This is a way for you to take the skills you've learned to date in the course and apply them to some independent study. So, see you in the next video. So let's discuss a new feature you'll now see in this section in the course, as well as future sections. And this is the coding exercise. Coding exercises are a feature added by Udemy to allow instructors to add exercises that students can complete on their own. The goal of these exercises is to help reinforce concepts you've been taught and to encourage you to share your solutions with other students in the course to start a dialogue about different ways to solve an exercise. You'll need to understand the problem, the specific requirements, and then design and code your own solution. You'll find them in the course sections going forward, including this one, and they'll appear just like a video, but will be labelled beginning with coding exercise. The cool thing is that you can literally click a button and have your solution checked immediately. So in other words, I'll give you a coding exercise to complete, and you can type in your solution to it interactively on the screen. When you think you've coded it completely, you can click a button and see if the solution is correct. This is different to the challenges that you've seen so far in the course, where we show you the requirements on the screen, then we ask you to pause the video to solve the solution on your own, but then we walk through the solution together. Coding exercises are different in that I give you the exercise, then you do them without seeing a solution in a video, but you do have that button to click to check the answer. So there's still plenty of upcoming challenges in this course, as well as coding exercises that are meant to complement those challenges. I think you'll find the coding exercises are a lot of fun once you learn some tricks to doing them. Coding exercises might be a bit hard to understand initially. So in this video, we're going to walk through a sample coding exercise together, step by step. This is the only time we'll do this, and the purpose of this video is to help you be successful in doing the rest of these exercises on your own. Probably the easiest way for you to follow along would be to have this video playing in one browser session and have the coding exercise pulled up side by side in another browser session. We can do this by first duplicating the current browser tab, and from the Udemy course list, pick coding exercise 1. And now select Move Tab to New Window in the browser tab options. So now you should have two different browser sessions running, which will allow you to play this lecture as you actually walk through the steps I'll show you in the coding exercise window. Alright, so as you can see in the browser, we've got the coding exercise text here, or description showing this is the problem that we need to solve. Now below that down here, in the right part bottom of the screen, we've got an area where we can type our source code in. This is the coding exercise editor. So that's one way of doing it. We could just type the code in there, but you might find that after using IntelliJ, you miss the features in IntelliJ's editor. So alternatively, we can use IntelliJ's editor to write the code, benefiting from its shortcuts, formatting and hints, and once happy with the code, we can copy and paste it from IntelliJ into this text area. The bottom left-hand corner has got a browser Q&A section, which we can click, and make sure to click Current Lecture, and that enables you to leave any questions you may have about the coding exercise. But you'll also be able to check other students' responses and solutions to this particular coding exercise. So as I mentioned, you can either type your solution here directly, or you can go back to IntelliJ and test your code in it, then paste it back in here. We're going to do a little bit of both as we go through this video. We'll first enter the code directly into this editing window of the coding exercise right below where there's this comment write code here. So you can see in terms of this solution, it's asking us to write a method called checkNumber with an int parameter called number. There's some more information below that, but let's just start with that. Public static void checkNumber opening parentheses int number closing parentheses opening curly brace closing curly brace. Okay, so we have our method checkNumber, and we've made sure to make it a static method as directed. There's also another note here about not adding a main method to your solution code, but more on that shortly. Now notice the file name here, positive-0.java. That's important because that's going to be the name that we need to make sure we use. As we get through the course, you'll find that we may need more than one file to solve a particular coding exercise, so naming them correctly will be important. But in this case, we've just got the one file, so we're going to deal with that. And notice that there is some smart terms here. It's automatically highlighting Java keywords. And you saw I added a left parentheses, it added the right one, and it also added the right curly brace, so it does recognize the Java language. So you can do your entire solution in here if you like, or if you prefer, you can write and test it in IntelliJ and then paste your final version in here. So let's go to IntelliJ and do some of our coding in there. But before we do that, I'm going to copy the code we just typed in so we can paste it into IntelliJ. As you can see, I've started a new project called Sample Coding Exercise, and I've added a new class called positive-0. If you need to pause the video and get this project and class started, please do that now, and keep in mind that how you name this class is very important. It must be named exactly as we saw in the coding exercise and as you see it on screen right now. Okay, go ahead and pause the video if you need to. So now I'm going to paste that method into IntelliJ. we've now got a method called checkNumber, and at the moment in IntelliJ, we haven't got a main method. Remember, there was a note on the coding exercise saying that we weren't to add a main method to there. But if we want to test this code that we're creating in IntelliJ, we'll need a main method. Public static void main opening parentheses string opening and closing square brackets args closing parentheses opening curly brace. Closing curly brace. So I can only be using the main method here to test our checkNumber method when we're in IntelliJ. We won't be pasting that into the actual Udemy coding exercise. Alright, so let's go back to the exercise again and see what we're meant to be doing. It says here that the method shouldn't return any values, and we've met that criteria by specifying void here, so that's correct. So first what we need to do is print out the word positive if the parameter number is greater than 0. So we need to add an if block within the checkNumber method to check if the value of the number variable is greater than 0. And by the way, notice that the results that they're looking for there are in lowercase, so we should be printing out whatever they're asking for here. And the double quotes is just an example there. We don't include the double quotes when we're actually printing the value. So let's go back to IntelliJ and write the code for that. Okay, so let's add an if block. And while we're doing that, let's go ahead and add a statement in the main method that we'll call the checkNumber method. And we'll just pick an arbitrary positive number, say 5. checkNumber, opening parentheses, 5, closing parentheses, semicolon. If opening parentheses, number greater than 0, closing parentheses, opening curly brace. System.out.println, opening parentheses, double quotes, positive, closing parentheses, semicolon. Closing curly brace. So we're going to meet the first condition if our number is greater than 0 because we're passing 5. So let's actually run that and see whether this works. You see we've got the word positive in the output. So far so good. Alright, so the next part of the coding exercise, we need to print the word negative if the parameter number is less than 0. Let's get back to IntelliJ and do that. So this will be similar to what we just did, except this time we'll use an else if block. So first, we'll add another method call in the main method, but this time we'll pass a negative number, say -10. checkNumber, opening parentheses, -10, closing parentheses, semicolon. And now we'll write the code to handle negative numbers. So on line 12, I'll hit enter to add a new line, then type in the else if section, checking the condition number less than 0. Closing curly brace, else, if opening parentheses, number less than 0, closing parentheses, opening curly brace. System.out.println, opening parentheses, double quotes, negative, closing parentheses, semicolon. Let's run this again to make sure everything is working. You can see we've got positive and negative working. Okay, so far our testing in IntelliJ is working well. We can see we're getting positive and negative showing. So let's take the opportunity now to finish off this exercise and get it working back in the Udemy interface. So I'm going to take a copy, and notice that I'm only copying at the moment the code in between the checkNumber method. So I'm not copying any other code. Now we're back in the coding exercise, making sure the cursor is in the right place, and I'm going to paste it into the checkNumber method. That's the code again that we've worked on in IntelliJ. Now, we know that we haven't finished the challenge yet because we haven't checked for or tried to output 0. But anytime that you want to check your solution, you can come over here and click on Check Solution, and the computer will actually check that and tell you if something's wrong. And you can see here that a method called to checkNumber with a value of 0 passed in parentheses returned and says printed a value of and then double quotes. So in other words, an empty value, but 0 was expected. So you can see that the test was automatically trying to check for a value of 0 and was expecting the word 0 to be returned, but it didn't get anything. It didn't get anything because, of course, we haven't added that part of the test yet. So you can see how this solution is working for you when testing your code. Now keep in mind here, when we're talking about return values, we're not talking about your checkNumber method because we declared it with the void keyword and it doesn't return a value. The return value here has to do with the automated system that checks your code. So I don't want that to confuse you. The other thing to keep in mind is if we add another error, something like we forget to put a last closing right brace. When we check the solution again, you can see it's smart enough to determine that our code is invalid Java, and we get a compilation error there. I'll go back and edit that again. So basically, our Java code will actually be checked, so we know that it's working and properly solves the problem as described in the coding exercise. Give it a moment to check, and we should get the same problem of 0. So it's a matter of reading what this says, because it's giving us an indication of what we haven't completed for the challenge, or showing us if we've actually got some errors in our code. In this case, it's telling us we now need to check for the value of 0. So let's fix the issue with 0, but I'm going to do something a little bit different. Now, keep in mind, when we're in the coding exercise editor, we can't use any IntelliJ shortcuts, so we have to type our code out completely. So that's one of the reasons why we might consider using IntelliJ to save us a bit of typing. So what I'm going to do is introduce another error by telling it to print the number was 0 when number equals 0. And you'll see why in a second. So I'll select that last closing brace of the else if statement, and I'll add a final else. We don't need to put a condition for this because we've already tested if number was less than 0 and number is greater than 0, so the only value number can be by this point is exactly equal to 0. Closing curly brace, else, opening curly brace. System.out.println, opening parentheses, double quotes, the number was 0, closing parentheses, semicolon. So now if we check that solution again, and you can see we've got a different result here, method called check number 0 in parentheses, printed a value of the number was 0. But just 0 was expected, so we need to get the output to be returned identically to what's being asked for in the coding exercise. We're going to change that, so I'll come up here with some changes, and we'll try putting the value of 0, but with a capital Z, and we'll check that solution again. Notice here that we've got the output of 0, capital Z, but it's expecting 0, lowercase z, and noting that it's basically telling us that the code is correct, but the capitalization is different. So you can see that it's smart enough to know that we've got the answer correct, but we've got, in this case, an uppercase Z, and we weren't asked to do an uppercase 1. So I'm going to change that back to a lowercase z and check the solution again. And you can see at this point of time now, we've now solved the coding exercise correctly. We've got well done, your solution is correct, and the code that's been placed in there is correct. A couple of other last things to note, if we go ahead and we try and add another method and check that. Public static void timtest, opening and closing parentheses, opening curly brace, closing curly brace. We get a problem here. We get an error returned, extra methods were detected. Please add only the required methods. So make sure that you only have methods in there that are needed. That's one of the reasons why we don't include the main method. Let's just get rid of that extra method. So the other thing is it's important to get the method declarations correct. If we remove the word static from here, so we've just got public void, and if we check that solution, we've now got a compilation error here. And the error here is relating to the fact we're trying to access something from a non-static method. So the point of the exercise here is that the description said to use static, so we need to use what they're suggesting and make sure we do exactly that to get this to work properly. I'll set this back to static again, click on check solution, and we should be correct again. Alright, so that's it. We've got our solution to the coding exercise correct. Now keep in mind with this that there's no universal solution for the coding exercise. The most important part is that it works as per the training exercise's text. In other words, it's giving the outputs that's being asked for in the coding description. We can write every coding exercise in many different ways. Let me delete the code block in the check number method in the coding exercise editing area, and I'll replace it with a one-line alternative. System.out.println, opening parentheses, number, greater than 0, closing parentheses, double quotes, positive, colon, opening parentheses, number, less than 0, closing parentheses, question mark, double quotes, negative, colon, double quotes, 0, closed both parentheses, semicolon. This method works, but might be a bit cryptic for a lot of readers. It's a ternary operator nested in a ternary operator. I've added parentheses to help you identify the inner ternary operator. So I hope you can see that there is no limit on the variations that might exist for solutions. I hope you'll find it fun and educational to see what other students are coming up with. So be sure to check the Q&A and review any code samples there after you've worked out your own solutions to these. Alright, so that's coding exercises. Let's now move on to the next video. In a few earlier videos, we tackled what methods were and how to actually put them to use in our program code. In this video, we'll be talking about method overloading. Method overloading occurs when a class has multiple methods with the same name, but the methods are declared with different parameters. So you can execute a method with one name, but call it with different arguments. Java can resolve which method it needs to execute based on the arguments being passed when the method is invoked. This technique lets us create methods with the same name for many types and number of arguments, and the calling code doesn't have to sort out which method to call. To the calling code, it looks like the method takes a variable set of arguments, when in truth, this isn't the case. Instead, there are a variable number of methods with the same name and different sets of parameters defined which can be called, and Java will figure out which one to execute. A method signature consists of the name of the method and the uniqueness of the declaration of its parameters. In other words, a signature is unique, not just by the method name, but in combination with the number of parameters, their types, and the order in which they are declared. A method's return type is not part of the signature. A parameter name is also not part of the signature. The type, order, and number of parameters in conjunction with the name make a method signature unique. A unique method signature is the key for the Java compiler to determine if a method is overloaded correctly. The name of the parameter is not part of the signature, and therefore it doesn't matter, from Java's point of view, what we call our parameters. This slide demonstrates some valid overloaded methods for the doSomething method. So we start out with a simple method called doSomething with one parameter, parameter A, of type int. In the next method, we still have one parameter, also parameter A, but the type is float. This method has a unique signature because the parameter type is different from the first, and it's a valid overloaded method for doSomething. In the case of the third method, we have two parameters, and this is definitely different from the first two methods, so this is a valid overloaded method. In the fourth method, we have two parameters, and they have the exact same types as the third method, but the order is different. So this is a valid overloaded method for the previous three. Finally, we have a method with three parameters, and again, because this has a unique signature among all of the methods described here, it's a valid overloaded method for doSomething. Parameter names are not important when determining if a method is overloaded, nor are return types used when determining if a method is unique. In the second method on this slide, the only difference in the method is the parameter name. This method has the same number of parameters and same type as the first doSomething method, and therefore this is not a valid overloaded method. This will cause a compiler error. In the third method, we again have the same name and parameter, but we have a different return type. But return type is not used in the determination of whether a method's signature is unique, and so this method too will cause a compiler error when it's in the same class as the first. Now, method overloading is very commonly used in Java programming and actually in many other programming languages as well. Let's look at an example in code. I've created a new project called Method Overloading and created the class name with a capital M and set up the main method as usual. So let's start by creating a method which we'll call calculateScore, and let's type this method in: public static int calculateScore, opening parentheses, string player name, comma, int score, closing parentheses, opening curly brace. System.out.println, opening parentheses, double quotes, player, plus, player name, plus, double quotes, scored, plus, score, plus, double quotes, points, closing parentheses, semicolon. Return score times 1000, semicolon, closing curly brace. So here we're returning score times 1000, which is just an arbitrary number. We've just done that so we can return something. That's because we've defined the method to return an integer. So to confirm that runs, we can make a call to it in the main method. CalculateScore, opening parentheses, double quotes, Tim, comma, 500, closing parentheses, semicolon. And if we run this, we should find that that works, no problem. We see the result, player Tim scored 500 points. So no surprises there. And if we wanted to, we could take the value that's returned, because that's what return does. It actually returns whatever the amount is back to, in this case, the code up here on line 5. We could change it and put new score equals calculate score, because you can see on line 11, we multiplied score by 1,000. System.out.println, opening parentheses, double quotes, new score is plus new score, closing parentheses, semicolon. And running that to confirm that works. We get the extra line, new score is 500,000, which of course is the 500 we passed as an argument value times 1,000, and that gives us 500,000. So that's how we use a value that's been calculated and returned from a method. So nothing particularly unique there. We've seen that similar setup used in the past. Okay, so let's go about overloading the method. From the slides, we know that we can create a method with the same name, calculate score, as long as its method signature is different from the first. So we'll start off by creating the second one by actually copying the method and pasting it right below the first one. Now notice when I do that, IntelliJ is showing both methods have an error. If we hover the mouse over one of these underscored methods, we can see that IntelliJ is saying calculate score with a string and an int as parameters is already defined in this class main. So that's Java telling us, look, we can't use an identical method with an identical set of parameters. There's a problem there. So the option to fix this, well, the first option would be to put an S1 on the end to make it a different method name. And of course, that will work, but that's then a separate method. This means we're not actually overloading the method this way, we're defining a method with a new name. So in this case, we don't want to do that. So the way to overload this method properly is to revert it back to the same name, and now we'll change the number of parameters, so we'll just get rid of the first parameter. And we've made it so that this method now has only got one parameter, which is the score. And notice that the overall error went away. But we got an error now on line 17 because we're trying to access the variable, the parameter that no longer exists in this particular method. So let's replace the first part of that statement with just unnamed player. Unnamed player. Now notice there are two methods there now, and we have a warning on the screen now. Because it's grayed out the method name compared to the method on line 9. It's saying that that's not being used. So that is IntelliJ saying, by the way, you've created this overloaded method called calculate score, but you're not using that particular one. You're only using this first one, which is in a darker color. You can see that we're using that on line 5. So we can still run that. And we still get the same results we got prior to overloading the method. But we want to use the second method, so let's add a call to the calculate score method next. Calculate score, opening parentheses, 75, closing parentheses, semicolon. And you can see that that's valid. And that's now going to call that second method if we run it. So let's run it to make sure it does work. Unnamed player scored 75 points, which is clearly the code from the second method. Now Java is checking data types, so we can't actually do something like try to execute calculate score and use 100 and 100 as arguments. Calculate score, opening parentheses, 100, comma, 100, closing parentheses, semicolon. So here, we actually get an error now. If we hover over that, we get required type string, and provided was an int. So what IntelliJ is saying here is, well, okay, if you want to call this overloaded method with two parameters, I know that you set up a method on line 12, but that needs to be a string. So that's what it's complaining about. And now let's add a third argument in that line. And now we're getting a new error that just sort of says altogether, well, hang on a minute, you haven't actually created an overloaded method with three parameters of int. And notice that when we hover over that error, it's actually saying int, 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 and the point to all that is that what makes it unique is the data type in the parameters. The thing you need to get the same, what Java uses to determine whether it's unique or not, is this, the data type. In this case, the string and the int. Okay, so let's do one more thing. Let's try and execute that method with the same name, but we won't pass any values to it. We'll first change that last call to calculate score and remove all the arguments. So again, we get an error. And at the moment, that is coming up and saying cannot resolve method. This is now saying, well, hang on, you haven't got a method with that name that doesn't have any parameters. So let's now try and create another overloaded method with no parameters. We'll copy and paste that second calculate score method, but we'll strip out the parameter and change the system.out.println statement. We can't return anything since we can't use any input values to calculate the score with, so we'll just return 0 from the method. Double quotes, no player name, comma, no player score. And you notice that the code is now valid and we can actually run that. So if we run that now, you can see we've got all three methods working on there and all got separate output. And you can see that output working quite nicely on the screen. So what we're trying to do here, when overloading a method, we need to create a unique method signature. We've talked about the signature already, and it consists of the actual method name. You can see that's the same in all three cases here. But it also uses the parameter definitions. Now you might think that you could change something here. You could say, okay, let's create another method calculate score. And I'm going to copy and paste that last method with no parameters. But let's make it a different return type. We'll make it return void instead of an int. We also need to remove the return statement that returns 0, so let's get rid of that. So you might think you can do that by changing the return type. Does that make it unique? But the error we're getting here says calculate score is already defined. And what Java is telling us is just changing the data type of the return type. The type of data that's going to be returned from the method doesn't actually change the overall signature. So we do need to change the number of parameters there to make it unique. So I'll just delete that new method. Before we move on, let's just talk about how we can use overloaded methods to support what looks like default values for method parameters. In the code we just looked at, we have several overloaded methods. Looking at the two methods we set up parameters for, consider the scenario where maybe we've made player name optional, and if the user doesn't want to provide it, we'll just default player name to anonymous. As stated previously, other languages let you define default values for parameters, and this could be done in the method definition. But not so with Java. But we can do the following. We can change the method that only has one parameter to set up a value for player name, and then execute the calculate score that takes player name as its first argument. Let's change this code. We can replace the code that executes this println statement and returns the same calculation as the overloaded method. And now we'll just call the other method and pass in the value anonymous as the first argument to the other existing method. Return calculate score, opening parentheses, double quotes, anonymous, comma, score, closing parentheses, semicolon. And let's change the main code to just execute two methods. I'm going to remove the existing code and insert two new println statements that will print the score returned from calculate score. You might remember we've previously said we can use methods that return data where we can use expressions, and this is true in the println statement. System.out.println, opening parentheses, double quotes, new score is plus calculate score, opening parentheses, double quotes, Tim, comma, 500, close both parentheses, semicolon. System.out.println, opening parentheses, double quotes, new score is plus calculate score, opening parentheses, 10, close both parentheses, semicolon. So you can see how this code might make it look like that default values are supported by the calculate score method. Here, we're not requiring the name in the second instance, but it will do the same thing as the code with the player name. Except it will use anonymous in place of the player name. And executing that code, you can see we get almost the same behavior whether we execute it with two arguments or just one, where it printed anonymous as the name. So overloaded methods offer some of the same functionality that you can get from default values for parameters in other languages. Okay, so that's how overloading methods work. In the next video, I'll be giving you a challenge to test what you've learned about overloaded methods.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
So what I'm going to do now is issue a challenge to give you a chance to try your hand at overloaded methods. So here are your challenge instructions. Create two methods with the same name, convert to centimetres. The first method has one parameter of type int, which represents the entire height in inches. You'll convert inches to centimetres in this method and pass back the number of centimetres as a double. The second method has two parameters of type int, one to represent height in feet and one to represent the remaining height in inches. So if a person is 5 foot 8 inches, the values 5'4" feet and 8'4" inches will be passed to this method. This method will convert feet and inches to just inches, then call the first method to get the number of centimetres, also returning the value as a double. Both methods should return a real number or decimal value for total height in centimetres. Call both methods and print out the results. The conversion formula from inches to centimetres is 1 inch equals 2.54 centimetres. Also, remember 1 foot equals 12 inches. You can use the link below to test your results. So let's go to that link and have a look at this website before I pause and let you go away and create your version of the code. So there's the website on the screen there now, and there will be a link to that in the resources section. So we could type something like 646 feet, and that gives us 182.88 centimetres. So you just type in either the number of feet or a combination of feet and inches, or just inches alone. And this will tell you what the height you entered in is in centimetres, and from there you can confirm that your code is correct and working properly. Okay, so that's it. So pause the video now, go away and complete the challenge. And when you're done, you want to come back and see what I've done. Come back and I'll show you my solution, so pause the video now. I hope you've had some success and managed to get it working. So I've created a project called Overloaded Challenge with the usual main class and the usual main method. So the challenge is to create overloaded methods named convert to centimetres, each of which returns a double. The first method has one parameter for just inches. The other method has two parameters for feet and inches, which we've said can be of type integer or int. So let's start with the test cases we want to use in the main method. I'm going to use 5 feet, 8 inches for the test of the method with two parameters. And I'll use 68 inches for the test of the method with only one parameter. System.out.println, opening parentheses, double quotes, 5 feet, comma, 8 inches equals, plus, convert to centimetres, opening parentheses, 5, comma, 8, closing parentheses, plus, double quotes, cm, closing parentheses, semicolon. System.out.println, opening parentheses, double quotes, 68 inches equals, plus, convert to centimetres, opening parentheses, 68, closing parentheses, plus, double quotes, cm, closing parentheses, semicolon. So, at this point, we have errors in IntelliJ because we haven't defined these methods. So let's do that next. These are pretty simple methods. We'll start with the one parameter method first. We use public static, as usual, return a double which was the requirement, and our parameter is just an integer representing inches. Public static double convert to centimetres, opening parentheses, int inches, closing parentheses, opening curly brace. Return inches times 2.54 semicolon, closing curly brace. And in this code, we're just returning inches times the conversion number that was given to you in the challenge instructions. And you can see we aren't setting up any local variables. We're just returning the equation, and this is perfectly valid. And we can do almost the same thing with the second method. This time we have two parameters. Public static double convert to centimetres, opening parentheses, int feet, comma, int inches, closing parentheses, opening curly brace. Return, opening parentheses, feet times 12, closing parentheses, plus inches, closing parentheses, times 2.54 semicolon, closing curly brace. So again, in this case, we're just returning the whole equation in the return statement. We multiply the value of feet by 12 to get inches from feet. Then we add that to any inches that were in the inches parameter. Then we multiply that total number of inches by the conversion formula 2.54. So now we should have code that compiles, and if we run that, so that looks like good answers. And if we go back to that website in the challenge, and we enter 5 feet and 8 inches in there, we get an answer of 172.72 centimetres. You'll remember that by default, Java, when outputting doubles, will omit any trailing zeros in the output, so this answer is the same as the one that we got from our code. Let's also enter 68 inches on this website, and there again, we get the same answer, 172.72 centimetres, so we know our code is correctly converting inches to centimetres in both cases. But we missed one requirement, and that was to call the first method, which has only inches as a parameter, from the second. So let's change our second method to call the first. Again, I'm going to do that right in the return statement. Convert to centimetres, opening parentheses, feet, times 12, closing parentheses, plus inches, closing parentheses, semicolon. So here, and you'll see this a lot in Java code, we're returning a call to an overloaded method in the return statement. We're calling the first method that only accepts inches, and we're passing it an expression directly. Here, we're passing it the feet and inches to just inches conversion equation. We multiply feet by 12 to convert feet to inches, and then we add that number to the inches value passed in on the method. And this is the argument passed to the method that only takes inches as a parameter. And running that, we get the same output. We could have written that method differently and set up local variables to do all the same work, so let's do that. First, we'll comment out that single return statement. And now, let's add some local variables. Int feet to inches equals feet times 12 semicolon. Int total inches equals feet to inches plus inches semicolon. Double result equals convert to centimetres, opening parentheses, total inches, closing parentheses, semicolon. Return result semicolon. So in this code, it's a lot easier to understand what's happening for someone else reading our code. We convert the feet parameter to inches by multiplying it by 12. We then get total inches by adding the feet to inches variable to the inches parameter value that was passed to the parameter. We can then pass total inches as an argument to the first overloaded method, and we'll call that method and assign the return variable to a local variable which we're calling result. And we simply return result. So, although both implementations gave us the same result, coding it this way is much clearer, much more readable. Although you'll see a lot of code written, like we wrote with the single return statement there, I want to encourage you to practice writing more readable code. You may ask, isn't it taking up more memory to write it this way? And it is, but all the local variables in this method will be eligible to have their memory reclaimed when the method completes execution. Again, it's a matter of style, and it's more work for you as a developer to write out 4 lines of code versus 1. But even the future you is less likely to make mistakes and find reviewing the code at some later date a bit easier. Okay, so that was the challenge. For this challenge, we didn't include validation, but we'll be doing that in the next challenge, which is similar to this one. In the next challenge, you'll be converting seconds and minutes to other time units. So you'll often find that when you're overloading methods, you'll be calling one overloaded method from another, as we did here. In this case, the conversion formula isn't going to change in the future because centimetres can always be retrieved by multiplying inches by 2.54. So we didn't really have to call the overloaded method. But if your formula or calculation may change or get updated, you want to centralise that equation into one method. Then all your overloaded methods can call the one that has the formula code in it, just as we've done here. This will keep your calculation code in a single place and prevent inconsistent results if the code is changed in one overloaded method and not another. You'll remember we talked about centralising and deduplicating code in a previous video. Okay, so I hope you got that on your own and you're starting to appreciate methods and overloaded methods and how they really help make our code more efficient and easy to read. So I'll see you in the next video. Alright, it's time for another challenge. In this challenge, we're going to create a method that takes time represented in seconds as the parameter. We'll then want to transform the seconds into hours. Next, we'll display the time in hours with the remaining minutes and seconds in a string. We'll do this transformation in 2 steps, which allows us to use overloaded methods. We want to create 2 methods with the same name, getDurationString. The first method has one parameter of type int, named seconds. The second method has 2 parameters, named minutes and seconds, both ints. Both methods return a string in the format shown, where XX represents the number of hours, Y the number of minutes, and ZZ the number of seconds. The first method should in turn call the second method to return its results. Make both methods public and static as we've been doing so far in this course. Remember that 1 minute is 60 seconds and 1 hour equals 60 minutes or 3,600 seconds. Start by creating a new project and call it Seconds and Minutes Challenge. Add validation to the methods as a bonus. For the first method, the seconds parameter should be greater than or equal to 0. For the second method, the minutes parameter should be greater than or equal to 0, and the seconds parameter should be greater than or equal to 0 and less than or equal to 59. If either method is passed an invalid value, print out some type of meaningful message to the user. Alright, so pause the video now and go ahead and complete the challenge. And when you've done that, come back and see what I've done and we'll go through it step by step. So pause the video now. Alright, so I hope you managed to have some success with the challenge, so let's now go through it step by step to get this working. So what we're going to do is start with the challenge. Right, so first things first, you can see that I've already created a seconds and minutes challenge project and I've already created a class called main. I've also already created the main method so that we can test our code. So one of the first things I like to do with this kind of challenge is set up my methods as empty shells. We'll declare the methods with no code in them really, and we'll add statements in increments as we build up the code later. So let's do that. First, we'll set up a test case in the main method, then we'll create both methods. We'll have each of the methods simply return an empty string. System.out.println, opening parentheses, getDurationString, opening parentheses, 3,945, close both parentheses, semicolon, slash, slash. This is the first test case. Public static string getDurationString, opening parentheses, int seconds, closing parentheses, opening curly brace. Return, double quotes, semicolon, closing curly brace. Public static string getDurationString, opening parentheses, int minutes, comma, int seconds, closing parentheses, opening curly brace. Return, double quotes, semicolon, closing curly brace. Here, because each of our methods should ultimately return a string, we'll return an empty string to start with until we build the code out. So don't worry, we'll be filling that out in just a bit. But even with these shell methods, we have testable code we can run. It won't print anything out, but it runs. We're going to work through the methods one step at a time, which is the way I like to approach code. It's a lot easier to test things in smaller parts. We can write a few lines of code and verify they're doing what we expect them to do. This is a good way to approach any coding exercise rather than build the whole thing and try to test it all at once. For now, we want to figure out how many hours are in the parameter seconds, which was passed into the first method. If you think about our first test case, we're passing 3,945 seconds. We know there are 3,600 seconds in 1 hour, so we're going to print something that the interval is 1 hour with some remaining minutes and seconds, and that's the challenge. So we can do this one of 2 ways. First, we could get the number of minutes and then extract the number of hours from those minutes. Or we can just divide seconds by 3,600 to get the right number of hours. We're going to try both of these approaches and print the results of each out. First, we'll type out the 2-step approach. Int minutes equals seconds divided by 60 semicolon. Int hours equals minutes divided by 60 semicolon. System.out.println, opening parentheses, double quotes, hours equals plus hours, closing parentheses, semicolon. And then the 1-step approach. Int hours 1 equals seconds divided by 3600 semicolon. System.out.println, opening parentheses, double quotes, hours1 equals plus hours1, closing parentheses, semicolon. So this, if we run it, shows that either approach will give us the result, 1 hour, when we pass in 3,945 seconds using the test case that we set up. So next, we want to get the remaining minutes after we've extracted hours. We want to print the remaining minutes and not the total amount of minutes. We're going to stick with the first approach for this reason. So let's delete the second approach, which I called the one-step approach, to get the hours from seconds. Then I want to get the remaining minutes, the minutes that didn't fit evenly into the hours calculation. Int remaining minutes equals minutes modulo 60 semicolon. System.out.println, opening parentheses, double quotes, minutes equals plus minutes, closing parentheses, semicolon. System.out.println, opening parentheses, double quotes, remaining minutes equals plus remaining minutes, closing parentheses, semicolon. Here, what we're doing is we're taking the minutes variable and using the remainder or modulus operator on it with 60. When we divide it by 60, we got the number of hours. When we use the remainder operator, we get the minutes that are left over after that. Let's run this, and we'll talk about the difference between minutes and remaining minutes after we run it. So from this, you can see that minutes hold 65 minutes, which includes the 1 hour we've already extracted. To get the minutes remaining, we use the remainder operator. I think you'll agree that 65 minutes is 1 hour and 5 minutes. So remaining minutes is the 5 minutes left over after we divide minutes by 60. And finally, we want to get any seconds that are left over. This again is a job for the remainder operator and can simply be done by dividing the parameter value, seconds, by 60. And then we're finally going to return the actual text we want to see from this method. Int remaining seconds equals seconds modulo 60 semicolon. System.out.println, opening parentheses, double quotes, remaining seconds equals plus remaining seconds, closing parentheses, semicolon. Return hours plus double quotes H plus remaining minutes plus double quotes M plus remaining seconds plus double quotes S semicolon. And if we run that, we get the additional information that the remaining seconds equals 45, and we're printing the output as specified by the challenge instructions. Okay, so now we have one method written. But it's missing one of the requirements, which is to call the overloaded method that uses two parameters. Before we start writing the second method, let's go back and remove the system.out.println statements in the code. Using system.out.println as your building and testing code is a valid way to debug any issues and verify your code is working as you work through it. Later on, we'll show you how to use IntelliJS Debugger to walk through code and look at variable values. But for now, this way is fine while we're working on the code. But we don't want to keep those println statements in our final code. So running this code now only outputs the hours, minutes, and seconds. Let's write the second overloaded method next. But before we do that, let's add a test case in the main method for the second method. System.out.println, opening parentheses, get duration string, opening parentheses, 65, 45, close both parentheses, semicolon, slash, this is the second test case. Okay, now we'll go back to our method and start working on it. The requirements were to return text similar to what we did in the first method. In fact, the difference in the first method and the second method is simply that the second method will already have minutes figured out and passed to that other method. So let's just copy and paste the code from the first method into the second one. Once we do that, though, you'll see that IntelliJ is telling us that the minutes variable can't be declared there. This is because there's already a variable named minutes defined. But we don't have another variable named minutes, do we? Well, turns out we do. Remember that when you declare a parameter, it creates a variable with that name that the method can use. So because we have a parameter named minutes, we can't have a local variable with the same name. And in fact, we don't have to calculate minutes at all now because it's being passed in on the method. So we can just delete that line of code. And now this method should work with our test case. Let's run it. And we got the same result. That's because 3,945 seconds is the same as 65 minutes and 45 seconds. Okay, so you've probably noticed there's a lot of duplication of code going on here. And duplication isn't a good thing, as we've previously discussed. One reason we use methods is to reduce code in multiple places like this. And we can do this with overloaded methods as well. So we'll just come up here to our first method, and we're going to replace all of that duplicated code with a call to our second method. And now we make a call to the overloaded method. In fact, we'll just return the value coming back from that overloaded method. Return get duration string, opening parentheses, minutes, comma, seconds, closing parentheses, semicolon. So you might be asking, don't we need a local variable to get remaining seconds? Well, this depends on what the requirements are. In our case, if we look at the bonus part of the challenge, we can get more information about what's supposed to happen with these methods. For the second method call, with two parameters, there's an assumption about what data should be passed to it, and this is part of the validation challenge. The assumption is that this method will be called with minutes and seconds, and the seconds will never exceed the number 59. So really, we shouldn't be passing seconds directly to the overloaded method as we are doing here. In this case, we're passing in the original value of seconds, which is 3,945. We get the same result though, because of the way we coded the second method. In that method, we have the remaining seconds variable we created in that method, which gets the true remaining seconds. So we'll still get the right answer, which hides the fact that this code is a little buggy right now. Let's leave the code this way now. We're going to talk about why seconds isn't what we really want to pass to this method in our next video. Though it does seem to work, and it does give us the result we want. So we've coded the challenge with two overloaded methods, and this solution gives us the right answer if we don't do any validation. Congratulations if you got through that on your own, and I hope you learned something either way. In the next video, we'll look at the bonus part of the challenge and add validation to both of these methods. This will shed some light on what might be a problem in our current solution. So I'll see you in the next video. So in the last video, we created two overloaded methods. The first took one parameter called seconds. That method transforms seconds into hours, minutes, and remaining seconds. The second method took two parameters called minutes and seconds and did the same thing, but started with minutes and seconds instead of just seconds alone. And you'll remember we called the second overloaded method from the first one. In this video, we want to look at the bonus part of the challenge. In this part of the challenge, we'll add validation to the methods as a bonus. For the first method, the seconds parameter should be greater than or equal to 0. For the second method, the minutes parameter should be greater than or equal to 0. And the seconds parameter should be greater than or equal to 0 and less than or equal to 59. If either method is passed an invalid value, print out some type of meaningful message to the user. So getting back to our code, you remember we have two test cases set up. Both of these really test the same duration of time. 3,945 seconds is 65 minutes and 45 seconds, or as we found out when we ran this code, 1 hour, 5 minutes, and 45 seconds. So the first thing we want to do is set up some different test cases that will test the validation we want to add. First, we'll make the first test case pass a negative number. We'll just put a minus sign in front of it. Then in the second test case, we'll pass in negative minutes. And finally, we'll add a third test case, but this time we'll pass seconds that exceed 59 seconds, so we'll pass 65 minutes and 145 seconds. System.out.println, opening parentheses, get duration string, opening parentheses, 65, comma, 145, close both parentheses, semicolon. And so, if we run these with our current code, we get some interesting results. So in the first case, we've allowed the user to enter negative numbers in the seconds parameters, which gives us negative time. This could be perfectly valid in some situations. For example, if we were calculating the difference between times, negative could indicate the difference in time in the past and positive could be in the future. But in our case, we're not interested in negative calculations. We do something similar in the second test case, passing negative minutes. And again, depending on where this data might be coming from, this could be okay, but for our test case, we've stated it isn't. We're assuming the data will contain any number of positive minutes. So the challenge is to validate that the seconds parameter is positive or zero for the first method and use similar validation on minutes in the second method. In the third test case, we're passing in a value for seconds that is greater than 59, meaning that a number greater than 59 should affect the number of minutes we calculate in the outcome, but you can see the output isn't doing that, it's missing 2 minutes. 145 seconds alone is 2 minutes and 25 seconds, and we know that 65 minutes is 1 hour and 5 minutes, so this result really should be 1 hour, 7 minutes and 25 seconds. But we got 1 hour, 5 minutes and 25 seconds in the outcome. So our validation needs to verify that the seconds passed won't exceed 59 seconds and therefore wouldn't contribute to additional minutes in the result. So if you haven't done this part of the challenge and you want to pause the video now to try it on your own, go ahead and do that. Okay, so now we'll go through the bonus part of this challenge and add validation code to our methods. We'll start with the first method, which has only one parameter, seconds, which we said should not be less than 0. That one is pretty straightforward. One way to do this is to simply add an if-then statement, checking to see if seconds is negative and return a string to that effect. So let's code it that way. If opening parentheses, seconds less than 0, closing parentheses, opening curly brace. Return, double quotes, invalid data for seconds, opening parentheses, plus seconds. Plus, double quotes, closing parentheses, comma, must be a positive integer value, semicolon. Closing curly brace. If we run that, we get the output with our informative message for the user. In this code, the very first thing we do is check if the parameter is valid or not. And if it's not, we won't execute any more code. We just exit the method with that different message. You can see we're returning from the method here with that return statement. This is a pretty efficient way to set up validation code, but we can also do this with an if-else statement. So let's see what that looks like. And this does the same thing, except it's a little harder to see that the validation code is separate from the remaining code. And also, all remaining code is now in a code block of its own, the else block, which is not really what we want. So I'm going to revert that back to the previous code because I think it's easier to understand. It's more obvious that the validation code is exiting immediately when the parameter doesn't pass the validation. Okay, so let's add the validation code for the second method. Since the validation code 4 minutes is exactly the same as 4 seconds in the method we just worked on, we'll cut and paste that validation code. We'll add it to the top of our second method with 2 parameters. And we'll change it because this time it's not seconds that we want to check that minutes is greater than or equal to 0. Okay, so let's run that. And we can see that worked on our second test case, the one where we passed in negative minutes. And to complete this bonus part of the challenge, we'll add the validation that seconds should be between 0 and 59 in the second overloaded method. We'll just make this a separate if statement. If opening parentheses, seconds less than or equal to 0, logical, or operator, seconds greater than or equal to 59, closing parentheses, opening curly brace. Return, double quotes, invalid data for seconds, opening parentheses, plus seconds. Plus, double quotes, closing parentheses, comma, must be between 0 and 59, semicolon. Closing curly brace. And then, when we run that with our test cases, we get invalid data or value messages for all 3 test cases. And so that's the challenge completed. But before we go any further and call this done, let's just add some good tests that were valid before, back into the code again. System.out.println, opening parentheses, get duration string, opening parentheses, 65, comma, 45, close both parentheses, semicolon. system.out.println, opening parentheses, get duration string, opening parentheses, 3945, close both parentheses, semicolon. And then run it to make sure our code works with valid data too. And now you'll actually see that one of these valid tests that worked before doesn't work now, and it's giving us a validation error message. Let's look at the way we called that overloaded method. You might remember from the previous video that I said that simply passing seconds from the first method to the second method was not the ideal way to go, but we left it anyway. But because we've added validation, this call to get duration string, when we're passing the original value of seconds to it, is now a problem. So we had a flaw in our code and maybe might never have seen it without doing some validation and testing. Let's fix it now. The easiest way to fix it is to pass an expression as the second parameter and use the remainder operator in the expression. And to make the code even a little cleaner, we could do the same thing with the minutes local variable. We don't really need to declare a minutes local variable at all. So here, we're just passing equations or expressions straight in as parameters, which is perfectly okay in Java. In the case of the second expression, we're getting the actual remaining seconds that would be left over after minutes and hours were extracted from the total number of seconds. And now running that, we can see these final two tests pass validation now and print out the results. And finally, there's one other thing we can do to make the code more concise. In the getDurationString method that has two parameters, we can simplify that code now because we have validation enabled. We know that this code will never be called or should never be called with seconds greater than 59. So now the code doesn't have to set up the remaining seconds variable. This is because the seconds parameter will really always be the remaining seconds. So we'll remove that variable. And we'll also change the text to use just seconds and not remaining seconds in the next line. And if we run that, we'll get the same output, but now our code meets all the requirements of the challenge. So that was the bonus part of the challenge, and of course, with every challenge, there are many ways to do it. This was one way. So I hope you enjoyed this video and this section on methods. With methods, we're now set up to write a lot more complex code. But there are some other ways to execute code blocks repeatedly, and this is with the use of looping. In the next section, we'll be talking about looping and other control flow statements, which, like the if-then-else statement, lets us decide which code block will be executed when, and with looping, how many times it will get executed. So I'll see you in that next section. Welcome to section 6 of the course. Tim Buchaka here again, and in this section, we're dealing with control flow statements. Something that you really need, that's essential for programming, is to be able to determine the flow of your program. In other words, what should be executed and under what conditions. And also, how often should a code segment be executed. In this section, you'll be learning about the switch statement, which, like the if-then-else statement, allows you to execute different code blocks based on different conditions. We'll also be looking at 3 additional statements, the for statement, the while statement, and the do while statement, which are used to repeat code segments based on conditions. These are the 4 key control flow statements that you need to understand to get the most out of Java. So let's make a start. So I've created a new project named Switch with a main class and main method. And inside the main method, I've declared an int value and added a complete if, and else statement. As you can see, it's very simple. If you need some time, pause the video and set up the new project, main class and main method. If you want to, you can add the other code, but you won't need it after we're done talking about it. So you see, that's a simple example there, and if we run that, in this case, we should get the value as 1. And we can change value to a 2 and run it again. Int value equals 2, semicolon. We get the value as 2, as you can see there. And finally, when we specify value equals 3, int value equals 3, semicolon. We get was not 1 or 2. So nothing unique about that. Now, this can get a little bit messy if we've got 10 values to test or a large number of values we want to test and perform different code for based on that value. Java provides another mechanism called the switch statement that lets us test if a variable matches a particular value and will then execute one or more lines of code if the check is true. The switch statement has gone through many enhancements since Java 8, but we'll be looking at the traditional switch statement to start. As you can see on the slide, the syntax for the switch statement is quite a bit different than it is for the if statement. We start with the keyword switch. That's followed with the value we want to check in parentheses, followed by the opening curly brace, which starts the switch code block. And of course, eventually the corresponding closing curly brace. Within the curly braces, there are some new keywords we haven't seen before. These are case, break, and default. The case keyword, as shown here, is used with the switch statement for comparison. So, as shown on the slide, switch value, case X, essentially means in the case that value equals X, execute this code. If it doesn't, then move on to check the next case. The break keyword tells the switch statement to terminate any further checks. It's technically optional, and we'll talk about it more shortly. As you can probably guess, the default keyword means if none of the above cases were true, execute this code. So let's go to IntelliJ and talk more about the switch statement. So let's do something equivalent to what we've done with the if and else statements, but using the switch statement. So let's go ahead and type that in, and we'll talk more about it. First, I'm going to comment out the if statement, because like I said, we won't be needing it again. Okay, now let's add the switch statement. We'll start with an int variable named switch value and set it to 1 to start with. This is the variable we're going to be testing, similar to the way we tested value in the if else statement we commented out. Int switch value equals 1 semicolon. Switch opening parentheses, switch value closing parentheses, opening curly brace. Case 1 colon. System.out.println, opening parentheses, double quotes, value was 1, closing parentheses, semicolon. Break, semicolon, closing curly brace. Double slash, more code here. Okay, so as we saw earlier on the slide, the switch statement starts with the keyword switch, followed by the value you want to test in parentheses. In our case, we're testing the variable switch value. Then we start the switch code block using the opening curly brace. So the next line is the keyword case, and that's followed by the value you want to test switch value against, in this case 1. And that is then finished with a colon. Below that is the code that we want to execute. For this example, just a simple print statement. Finally, we end the case with the keyword break. The break tells Java, okay, I found a true case, I've executed the code for that case, and now I want to leave the switch block completely and go on to the next lines of code. So here, it will execute the print and then move on to line 21, where we have that comment, more code here, which is just a reference. And this is basically all equivalent to doing something like if its switch value equals 1. So let's run this to make sure it's working like we think. And then we see our printout value was 1, just as we expected. Now we can use multiple cases, so let's put another case label in there, this time case 2. Case 2 colon. System.out.println, opening parentheses, double quotes, value was 2, closing parentheses, semicolon. Break, semicolon. And then, as we discussed during the slide, we can add a default case as well, so let's do that. Default, colon. System.out.println, opening parentheses, double quotes, was not 1 or 2, closing parentheses, semicolon. Break, semicolon. So now what we've got is our first case, followed by our second case, case 2, which is basically the same as else if switch value equals 2. And then our print statement, followed again by break. Because of course, if we match the second case, we also want to terminate the switch block. And then lastly, we have the default case, which is equivalent to the else statement because it will execute for all other circumstances. And we end that with a print statement and the final break. So that's the switch statement, which emulates what we did with the if else statements. So we know it's working for case 1. Let's change this and check for case 2. So switch value equals 2 and run it again. Int switch value equals 2 semicolon. So we now get printed out value was 2. Let's do one last run and change switch value to 3. Int switch value equals 3 semicolon. That's good. We get was not 1 or 2. So you can see that's all working. So that's a switch statement. Now it's often a matter of style to choose between the if statement or the switch statement because both can really achieve the same thing. You can see that we used if value equals 1 effectively, and it's equivalent to using a switch statement and putting case 1. The if statement is a little bit more flexible in that each time we do a test here, we don't have to use the same test criteria. So we could put if value equals 1 or else if cat equals 4. In other words, we can test a different variable altogether. For the switch statement, we're testing only the switch value here, and we're testing different values for that switch value. So a switch is good to use if we're actually testing the same variable and we want to test different values for that variable. Now, you can see that there would be situations where if you had 20 values to test for, this could get a little bit tedious. But there's actually a bit of a shortcut, so let's look at that now. Case 3, case 4, case 5, System.out.println, opening parentheses, double quotes, was a 3, a 4, or a 5, closing parentheses, semicolon. System.out.println, opening parentheses, double quotes, actually it was a plus, switch value, closing parentheses, semicolon. Break, semicolon. System.out.println, opening parentheses, double quotes, was not 1, 2, 3, 4, or 5, closing parentheses, semicolon. So what we're doing here on line 23 is we're testing for multiple cases. We're testing for 3 or 4 or 5. And if any of those are true, then we'll execute those two print statements and then break out of the switch. We also updated the default case output to reflect that if it gets to that point, then it's not a number between 1 and 5 because those cases were already covered. Let's run this again. So we'll assign 3 to the value of switch value. Previously, we got was not 1 or 2, but now it doesn't hit the default case because we've added additional cases here, including this one for number 3. So the results was a 3, a 4, or a 5. And then it printed out the value with the output there outputting, actually it was a 3. You could keep extending that, so you could have more case labels here on line 23 for case 6 and 7 and so on. The important thing is here, pertaining to case 3, case 4, case 5, we're grouping our case tests together in the one line effectively, which makes it a lot easier to group values that will have the same behavior. So another important thing to know that the switch statement is that it can only be used with a limited type of variable data types. So you can see this is a limited list. We can only use half of the primitives, byte, short, int and char, and their corresponding wrappers. We can use strings in a type called enum, which we'll be reviewing in the next section when we get to object-oriented programming subjects. But importantly, note that the primitive types of boolean, long, float, and double cannot be used. They'll result in an error in your code if you try to use them. And finally, before we end this video, I want to quickly talk about a concept that applies to the switch statement called for through. Once a switch case label matches the switch variable, no more cases are checked. Any code after the case label where there was a match found will be executed until a break statement or the end of the switch statement occurs. Without a break statement, execution will continue to fall through any case labels declared below the matching one and execute each case's code. Let's swing back to IntelliJ and take a look at an example in code. So it's important to know that if you don't have a break, you may get unexpected results. Now, just to show what will happen, let's comment out that break here on line 26. Now let's run it and see what happens. Can you see what's happened there? The results of the two strings was a 3, a 4, or a 5, and actually it was a 2 that we got before, but now we also have this last line printed was not 1, 2, 3, 4, or 5, which is listed under the default label. So why does that happen? Well, the reason it happened is we've commented out this break statement on line 26. So what happened is the processing got to here, and because the switch value was set to 3, it executed lines 24 and 25. But then there wasn't a break statement, so it continued on to this line here. Because the switch has matched a case, it stops checking any remaining cases if there are any, and will continue executing code until it finds a break or the end of the switch block. And here eventually, it did find a break to get out of the code on line 29. Let's just change that back to the original code. Okay, so we'll end this part of the introduction of the switch statement here. In the next video, we'll take a look at some of the new features of the switch statement. So I'll see you in that next video. In the last video, we looked at the switch statement and how we can use it instead of an if statement if all our test conditions are testing a single variable state. The switch statement has seen quite a few updates through the years. So in this video, we're going to explore some of the new features of the switch statement. We'll be looking at a couple of these now and reviewing others a bit later in the course, which require some knowledge of classes and object-oriented programming. So getting back to the code, some of you may have noticed already that IntelliJ has been trying to get our attention. The switch keyword is highlighted. If we hover our mouse over that, IntelliJ tells us we can replace the switch statement can be replaced with the enhanced switch. So let's do it. Let's select replace with enhanced switch statement and see what happens. So IntelliJ has transformed the switch statement. Let's look at these statements side by side. So in the previous video, we introduced you to the switch statement and the syntax that's been used since Java's beginnings. This is shown on the left side of this slide. Since JDK 9, the switch has been undergoing enhancements, but to keep it backwards compatible, Java has introduced new syntax for the switch as shown on the right side of this slide. When we compare these two statements, the first thing we notice is that the colon after each case label has been replaced with the arrow token as shown here. There are no breaks in the enhanced switch statement. The enhanced statement doesn't require them. Fall through, which we examined at the end of the last video, never occurs in the enhanced switch statement. Also, notice that it's replaced the multiple case labels we had, case 3, case 4, and case 5, with a comma-delimited list of the values. Maybe you'll agree with me that this new switch code is easier to read and much more succinct. And for beginners, it comes with more controls in place to prevent coding errors. You'll see the traditional switch statement in code written before Java 14, so this is a fairly new feature in Java. For this reason, it's important to be familiar with both versions. Which one you use is really dependent on your development and production environments. If your code needs to be backwards compatible to earlier versions of Java, then stick to the traditional switch. Okay, so let's get back to the code. We'll first walk through the traditional way a switch case statement could be used in an expression and then the enhanced switch way. Prior to the enhanced statement, if you wanted the switch statement to return a value, you wrapped it in a method that returned the value. So let's do that. The first thing we'll do is make a new method that takes a string as its single parameter and also returns a string. So down below the end of our main method, but still inside our class block, let's do that. Public static string get quarter, opening parentheses, string month, closing parentheses, opening curly brace. Closing curly brace. Alright, so then we have a new method, get quarter, taking a single string parameter called month and returns a string value. This code is going to return first for the first quarter if the month is January, February or March, second for the second quarter if the month is April, May or June, and so on. You probably see that IntelliJ is showing us an error there, but we'll fix that shortly. So the idea is this method will receive a month of the year and then it should return a string representing what quarter of the year that month is in. And we can use a switch statement to do that, and we can do it in a few ways, but let's look at the traditional way first. I'm going to type this code in, then we'll talk about it afterwards. Switch, opening parentheses, month, closing parentheses, opening curly brace. Case, double quotes, January, colon. Case, double quotes, February, colon. Case, double quotes, March, colon. Return, double quotes, first, semicolon. Case, double quotes, April, colon. Case, double quotes, May, colon. Case, double quotes, June, colon. Return, double quotes, second, semicolon. Case, double quotes, July, colon. Case, double quotes, August, colon. Case, double quotes, September, colon. Return, double quotes, third, semicolon. Case, double quotes, October, colon. Case, double quotes, November, colon. Case, double quotes, December, colon. Return, double quotes, fourth, semicolon. Closing curly brace. Return, double quotes, bad, semicolon. So what we've done here is we have again a fairly simple switch statement. Now, instead of using a primitive type like we've done before, we're using a string for our switch and case values. We said in the last video that string was one of the few data types you can use with the switch statement. You remember the list consisted of numeric whole primitive types and the smaller types, short and byte, as well as char. String and the wrappers are also supported. And you can see for our cases, we surround our test values in double quotes, indicating these are string values. What's really different here is that we're not using a break, but instead we're using a return statement. This works like a break since the code will exit out of both the switch statement and the method at this point. There's no chance to fall through the switch. We also don't need a default label in this instance, since if the month isn't found, the code will just fall through to the last statement on line 49. If we get bad back from this method, it means the month was invalid. You may remember we can use method results anywhere an expression is used. So let's go up to the main method and call the getQuarter method. I'll delete this comment on line 25 and add some space, and we'll print the month and quarter out. String month equals double quotes April semicolon. System.out.println opening parentheses month plus double quotes is in there plus getQuarter opening parentheses month closing parentheses plus double quotes quarter closing parentheses semicolon. You can see we're making a call to getQuarter directly in the system.out.println statement. Okay, so let's run that, passing April as the parameter. And then we have April is in the second quarter is being printed there. Of course, we're still getting this other stuff printed too. Next, we can do a test for October. We'll change the month variable to October. String month equals double quotes October semicolon. And we'll run that again. And here we get October is in the fourth quarter. But the enhanced switch case statement gives us another option. First, let's change the case statement in the getQuarter method to an enhanced switch. We'll do what we did before, hovering over the switch keyword and selecting the option to replace with switch expression. So you can see this did a similar transformation of our code, but there's one interesting difference. Notice that this code has the return keyword before the switch keyword. This enhancement was previewed in JDK 12 and 13, experiencing improvements due to the previews, and became standard in JDK 14, so it's pretty new. So what's subtle here, but very important, is that this switch statement is really an expression, meaning it resolves to a single value and can be assigned to a variable, or in this example, returned from the method. Let's consider this code side by side. There are some important differences. So again, we can see that the multiple case keywords have been removed for a comma delimited list, and the colon is replaced with an arrow token, so this looks a lot like the enhanced switch statement. But look at the right side of the arrow token, it's just a string literal. This isn't a statement at all. This code only compiles because we're using it as an expression, meaning we're using the result. In this case, we're simply returning the result from the method, but we could just as easily have assigned it to a local variable. The other important difference is this default label. When the enhanced switch is an expression, meaning it returns a value, then a default label is required under most conditions. We'll be talking about the exception to this rule later when we use the switch with the last special type it supports, the enum. But in all other cases, default is required when the statement is used as an expression. So let's test these statements out in code. First, let's rerun our code with this newly formatted method. And no surprise, it works as before. What happens if we leave out the default case? Let's comment that out. IntelliJ doesn't give us a warning, but if we try to run that, we get an exception. The switch expression does not cover all possible input values. So you should always include a default label in the switch expression. In truth, it's usually a good idea under almost all circumstances to include a default case label. Let's revert that change. Okay, so what happens if I want to do something in the case branch before returning the value? Well, to do that I'll need to create a code block, so let's do that. Default, return type, opening curly brace. String, bad response, equals, month, plus, double quotes, is bad, semicolon. Return, bad response, semicolon. Closing curly brace. This code tries to return a string form using the data that was passed to the method, and the string is bad. But IntelliJ is flagging that line, return bad response, as an error, return outside of enclosing switch expression. That's kind of hard to understand, but the fact is that if you're going to use a code block like this in a switch expression, we need a new keyword. We need to use yield and not return, so let's change our code and see if that works. Yield, bad response, semicolon. The word yield is a new keyword introduced for the switch expression to return a value back. And now IntelliJ seems happy, so let's run that. And we get the same result because we're still using October, but let's change it to XYZ. We do that in the main method. String, month, equals, double quotes, XYZ, semicolon. And running that. So that's not really pretty output, but you can get the idea here that if you're doing additional code in the case branch, you need to use a code block and this keyword yield. Yield is only required under certain conditions. Your switch statement is being used as a switch expression returning a value. Your case label uses a code block with opening and closing curly braces. What happens if we just put it here before first on line 33? Case, double quotes, January, comma, double quotes, February, comma, double quotes, March, return type, yield, double quotes, first, semicolon. You'll notice this doesn't actually work. IntelliJ is saying it cannot resolve this symbol. The yield statement has to be in a code block, so let's add the curly braces around this yield statement. We have to put the opening curly brace after the arrow token and the closing curly brace after the semicolon. So now this compiles and works. Generally, if all you're doing is returning the value from one of your cases, you'll just put the value that's returned like we're doing on lines 34, 35, and 36. But if you're making calculations or doing some other work, you can use a code block, but you're then required to use yield before you return the value back. Okay, so that was a lot to take in, I know. But I thought it was important to show you all of these enhancements that have been occurring with the switch. If you're like me, you might prefer the enhanced version to the traditional one. It takes away the need to add breaks and has more checks in place, and it's easier to read. But at the time of this recording, the traditional switch is the one you'll probably be using predominantly until companies can afford to move code to newer versions of Java. We'll be revisiting the switch statement, including additional switch syntax and features as the course progresses. In the next couple of videos, I want to give you a couple of switch challenges so you can practice some of the things we've learnt so far, so I'll see you there. In the previous couple of videos, we looked at the switch statement and how we can use it in a similar way to an if statement. We talked about the traditional version, which you'll see in older applications. We've also looked at the enhanced version, which I would recommend if you're using JDK 14 or greater, and if you also have the luxury of not having to be compatible with older versions. In this video, we'll give you a chance to work out a challenge using the traditional switch statement. Let's look at the slide we saw in the last video, which describes the syntax of both. The version on the left uses colons to start a case block, case 1. For example, which makes it a traditional switch. This means it permits fall through to occur and it can't be used as an expression. Therefore, in this type of switch, it's important to ensure you include a break statement in each case block to prevent accidental fall through. On the right, where the arrow token replaces the colon in the case label, the break statement is part of the new syntax and you shouldn't use it. Okay, so keep these two variations in mind. You can come back to this slide to refer to what we mean by traditional versus enhanced. Now, for the first challenge. In this challenge, we'll be using the NATO alphabet to replace a character or letter with NATO's standardized word for that letter. In radio transmissions, the word car, C-A-R, would be read Charlie Able Roger for clarity. We'll take a single character and return the matching word from the NATO phonetic alphabet shown on this slide. We'll just do this for the letters A through E. To do this, create a new char variable. Use the traditional switch statement with a colon in case labels that tests the value in the variable from step 1. Create cases for the characters A, B, C, D, and E. Display a message in each case block with the letter and the NATO word, then break. Add a default block which displays the letter with a message saying not found. Okay, so your challenge is to create the switch statement, but this time you'll be testing for the values A through E in the cases. Display a message, if any of these are found, that prints the character and the NATO word that represents that letter, and then break. Add a default label which displays a message saying that letter was not found in the switch and include the letter in the message. Alright, go ahead and do that and pause the video now. When you're finished, come back and you can check out my solution. Okay, so did you figure it out? What we need to do is very similar to what we've already done in the previous videos on the traditional switch statement. The main difference will be that we're using a char instead of an int. So let's add this code. Char value equals single quotes a semicolon. Switch opening parentheses, char value closing parentheses, opening curly brace. Case single quotes a colon. System.out.println opening parentheses, double quotes A's able closing parentheses, semicolon. Break semicolon, closing curly brace. Okay, so what we have first here, of course, is our variable declaration and assignment. And I hope you remembered that char uses single quotes, as you can see on line 5. And then, just like we did before, we have our switch statement with the value to test, which is inside parentheses, and we're testing char value here. This is followed then by the opening curly brace to start our switch block. Next we add our first case, in particular here, case A, again using the single quotes for our char value, and then followed by the colon, which is how Java determines what type of switch it is. If the case is true, we print out is able and then break. So that's the first case, but of course we have more tests we need to do and a default message we need to add. So let's quickly add those in. Case, single quotes, B, colon. System.out.println, opening parentheses, double quotes, B's baker, closing parentheses, semicolon. Break, semicolon. Case, single quotes, C, colon. System.out.println, opening parentheses, double quotes, C's Charlie, closing parentheses, semicolon. Break, semicolon. Case, single quotes, D, colon. System.out.println, opening parentheses, double quotes, D's dog, closing parentheses, semicolon. Break, semicolon. Case, single quotes, E, colon. System.out.println, opening parentheses, double quotes, E's easy, closing parentheses, semicolon. Break, semicolon. So here, we've just set up the other cases. Because we're printing something different for each letter, we don't have the need for multiple case labels. And now let's include that default label. Default, colon. System.out.println, opening parentheses, double quotes, letter, plus, char value, plus, double quotes, was not found in the switch, closing parentheses, semicolon. Break, semicolon. Alright, so that's our switch statement with the first 5 letters in the alphabet coded. If we give that a go, we've got the value A that we've defined, so we should get a message saying A is able. And we can see we get A is able printed out. So we can change the value to B and run the code again. char value equals single quotes B semicolon. And of course now B is baker. Lastly, we can put something like an X there. char value equals single quotes X semicolon. And now we get the default case, letter X was not found in the switch. So that's how we use the primitive type char in a switch statement. So that was pretty easy and basically what we saw with using an int type. Okay, so that was using a traditional switch statement to do some work conditionally based on the value of the character that was passed to it. In the next video, we have another challenge for you, but in that challenge, we'll be using the enhanced switch statement.
This video is over. Go to starfreelance.eu to download these videos, materials, and sources. Watch more videos to get premium videos and ebooks. We'll be a Starfreelancer.